put together a fixed object on the a single object running on a Raspberry Pi and a serial connection to a Raspberry Pi, say a Pi Zero, a small Raspberry Pi, and then the Pi Zero providing all that connectivity with very simple requests. So you can text from the P2, you can update the web backend, or you can even send email. I can see clearly how to do that. Does anybody have any interest in that, you think?
I do.
Okay.
I do, because people are asking for such applications and the Pi has proven itself there.
Okay. I'll put that together and then put up a forum post on it. I've been visualizing this thing for about 6 months now, and it's like, well, I probably should do it.
Yeah, we talked about it. At this point, we just need to get people connected to the web through the Pi or whatever and have something that works.
Okay, that'd be a trivial object set to do, so I'll go ahead and work on it. That'll be a good quick bite thing too, and even a presentation, I'll bet. So I'll just plan on being able to do that.
Well, I see JonnyMac showed up, so I'm going to go ahead and hit record and we'll just get started. All right.
Hey, John.
Thank you. Hello, everybody. Welcome to the P2 Live Forum. We're back for our second event after a break for a while. And today, just to get us all on the same page, this is the second of the third presentations from JonnyMac. And John has spent a lot of time working with this next-gen HMI display. So if anyone's not sure what we're doing today, I'll just kind of give you a little picture if my cords will allow that. But we're using this display. Okay, and that's the latest code just now published by John. And we're using it on a P2. I'm using a P2 Edge. You could use any board, and I'm on a JonnyMac, as you can see. And what we're doing is we're controlling these NeoPixel displays. Okay, so I've also got a setup here, and I know what people are dealing with who will be running this today. It's actually a very easy setup. So that's our interface is this display and a propeller, P2, and then some NeoPixels. So for JonnyMac, if you could do some muting. Thanks, Stephen. Got it. JonnyMac has, yep.
Quick question. I think you gave the co-host to Michael Green in case he doesn't know.
Oh, okay, thanks. I'll move it off of you. All right, and check now.
Still looking. Yep, there we go.
Okay. We all know JonnyMac has a lot to say, and JonnyMac, for every word he says today, he's probably written an hour of code. All right, so there's a lot more behind the scenes here, and we want to keep John moving. Ask your questions in chat. Stephen or I will grab them, or you can unmute yourself and ask John, but we'll keep John going, keep him on track, and keep this moving along. And if you actually have the hardware and you want to hook it up, there are several resources you might like. I will paste those right now into the chat. Come back here. Thank you, Zoom bar. So there's a number of links for you. Okay. So before we turn to JonnyMac, we'll just breeze through the housekeeping today. We still got this bundle on some kind of sale if you want to grab one of those, and we're using these LEDs today, but as you just saw from mine, they're more like a bar, a strip. Doesn't matter. These are just WS2811 or 12 LEDs. P2s, if you're still waiting for P1s, let's talk about that first. We are getting 20,000 coming into inventory shortly. In the next coming days, we have to test them, then they'll be available, all right? So we should have met all back orders momentarily. And the P2, we have plenty in stock and more coming if you're designing a product. All of our events are on parallax.com/events. Go here and check it out, and you'll see there are different tabs. You can click on P2 events or on education events or all of them. And it's good to know where you are and what you're looking for. So click on the P2 if you're here. And if you're an educator, then you can click on the educational events because we have a lot of those coming up. One of them is this Thursday with Andy. This is before we send teachers off on break. We're just going to get them fully charged for a good semester when they return. When we also come back, we'll have, well, next week we have a presentation. 1 week from now, then we'll take a little break. And when we return in January, we'll talk about the state of P2 docs, and Jeff will show us where he is. Good progress on this hardware today. And as a matter of fact, we seem to have chased out the gremlins out of the hardware. And mid to end, I guess, January 19th, we'll talk about this. And January 26th, Francesco's industrial controller. Someone asked if we'll have these in stock. Yeah, I'll try to get a few of these in stock for you, along with the add-on cards. And Eric Smith in February for educators, Arduino stuff. And oh, here's a big one. The propeller tool. 1 week ago, we've added the floating point. Good job, Jeff. And there is a link to download that if somebody wants to get it. So I guess next will be the final debugging work from Chip, and we'll have that done in time for this presentation. More educational stuff. Stephen is here. He's going to update us on the P2. This is his cube with it all flattened out and under some level of control a few months ago. More educational stuff, more educational. And then around mid-March, we'll have a 2-session activity around the P2 Edge, how to design it into your product. And we'll be including all the PCB files and all the best practices. And we're actually going to make a board out of this presentation, a little kit, a P2 project board. And we'll talk about that at the second. And then on March 30th, Gavin, who's with us today, good to see you, Gavin, will give us an update on his book. He's been very busy at work, and we've been sorting through his plan for the spring semester. Good to see him. This event was canceled, but it was never really, I think, announced. That was our P2 Expo at Parallax. So not happening. Okay, before we turn to JonnyMac, I should say that John's code is lovely, and I've been working with it this morning. And when I say working with it, that's a very liberal term. I mean, pretty much loading and go. And I feel like I have a very spoiled, luxurious position when I work with John, because he works for thousands of hours and then he turns this code over and I just get to run it. And I think that's been my career with engineers, which is really lucky. And some of them take a long time, like Chip worked for 14 years on something once before I got to use it. So I'm very thankful for what John has done here, and encourage all of us to free JonnyMac. And you can make a donation to John like I'm going to do today for his work, to thank him, because truly he's given us a huge jumping off point with this kind of interface. And just to get ready for this presentation, it's like he's made a whole product out of this display. I mean, it is a whole product. It's a Christmas tree light controller, or whatever you want to use it for, adjust it for. So tons of work. And thanks, John, for working with such deadlines. And you set a good role model in that way for engineering. So John, I'll turn over to you and let you roar. So live from Hollywood, California, JonnyMac.
Thank you, Ken. Hello, everybody. I'm glad to see so many people back after the marathon we went through last week. So this week won't be so bad. We have a lot of work to do, though. This is there's some pretty crazy stuff going on, but fun. You know, I think Ken will attest to that. He got the code earlier probably than everybody else. So if you don't have it, I posted it about 20 minutes ago in the forum. There's a thread in the P2 forum called Getting Started with the Next Gen. Your interface should show you it's, you know, should float to the top, because I just posted new files there. In post number 2 are the files that you'll need for this week. So they're all the P2 files. We have 6 demo files, as Ken will also attest to. There was only going to be 5, but I scrambled and got 6 working at the last second. It's not perfect, number 6, but it's useful. And, you know, everything I do is very iterative. So you'll understand that in a moment. And then there's 2 next-gen files. One is an update from the passcode project that we did last week, the one that looked like an iPhone thing where you could lock and unlock, because I learned a new trick this week. One of the things that I try to do every day is learn something a little bit new. And since this display is so interesting, and my friend John Huffman, who's here, he's right below me on my screen, and my friend Rick are using this. And then I don't know if he's here. My friend Josh called me one day and he said, yeah, I might have to stop watching your presentations, because every time I watch one, I end up spending a lot of money. So it was a very nice kind of roundabout compliment. But Josh and I work for a laser tag company, and I have been putting effort into this because I have product ideas for laser tag. And Josh, now having seen that, because I talked to him a little bit about it, but we take in most of our information through our eyes, right? And so once you see it, and now when you can play with it, it really becomes, I think the value comes out. Again, my friend John, he's doing quite a large project with this. So a lot of the tricks that I've learned with the next gen have been coming from helping John with his project. So again, we have a bunch to do today, but I hope it'll be fun. I expect it will. And as Ken indicated earlier, if you have a question on the topic at hand, please just jump in and ask. I don't want anybody to feel left behind, or you can go through the chat. I guess Ken and Stephen are monitoring that. So thank you guys for that. So I don't miss any questions, because honestly, I never look at the chat, obviously, while I'm talking. And with that, are there any preliminaries before I turn on the presentation and go? Okay. All right, so I will share my screen if that's okay, Ken.
Yep. I'm curious if anyone has hardware, let us know in the chat. We'd like to know.
Hopefully everyone's seeing my presentation from PowerPoint. Okay, and I'll go ahead and put it in presentation mode. Where is that? I know it is. Okay, we know what we're doing here. This is just a point of clarification. Last week we had a little bit of a confusion, and I want to clarify that. So what we're talking about last week, this week, and next week is using the Propeller 2 with the thing you see on screen. This is a smartish LCD HMI from a company called NextGen. So this particular one we're using is 480 by 320, has 16-bit color. And it's not a generic display like you would use with, say, a VGA driver. You can put text and graphics and things on there, but they tend to be pre-built. What's nice about this is it has a scripting language built in and widgets and objects so that you can create a functional HMI, which you'll remember from last week stands for human machine interface. So generally, we're going to use this kind of thing to control something else. And, and we can also get values. Now, for our project, at least this week, it's a pure input device. We're not, even though we're talking to the display, we're not putting any information on it. Next week, we're going to change that. But this week, it's a pure input. So you can see on the screen, there's sliders. There's what looks like radio buttons. There's some color patches. This is another slider. One of the things I am going to talk about as well is that you can, with a little bit of effort, like I did here, make really attractive displays. Now, I think this is attractive. You may differ, but that's okay. I like the way this looks. It just looks something more like a commercial product versus if you use their standard kind of widgets, then, they're not, well, they're dull. Let me just say that. They're dull and flat, and they don't look very exciting. So we're talking about this. If I happen to use the term mobile, I mean something that I can pick up and carry around. I'm not talking about a phone specifically. Okay, that got us into some trouble last week. So this is the topic at hand. Here's the things we're going to talk about today. Because we've been away for a long time and we have some newcomers, we're going to do a real quick review of the P2. We're going to talk about connections between the P2 and outside devices, specifically with serial, I2C, and then smart pixels, how they work. And then we're going to go back to the next gen and pick up where we talked, from some things we did last week. There is a feature that is part of the next gen that I finally sorted out this week called Touch Cap, and I'm going to show you that the little passcode entry screen project. If you look in that folder, I just uploaded the whole folder. So yeah, there's this one new file in there. It's called Passcode TAC2. That is the same program. It just behaves differently using the touch cap object versus button objects. We're going to then talk about the pixel interface that you saw on my device a minute ago, and how to connect it to the P2 and make things work. So in the process, we're going to go through 6 demo programs today. Some of them we'll go through quickly because they are for review. But as you know, I was talking to Ken earlier, and John, who I've known and worked with for a long time, and Josh, who I've known and worked with for a long time. I do things in a very iterative manner because I want to make sure that things are working here before I move here. If you don't check this, it could break, and over here becomes a really big mess. So sometimes that seems a little plodding, but what you end up with is a much stronger product in the end. All right, as Ken was saying, we're talking about the P2. This is a picture from Ken. Here is the JonnyMac that we're going to talk about this RTC today. Because we're talking about I2C, and there's an EEPROM on here as well. We're going to talk about that. We're not going to use it very much other than to demo it. Next week, we'll fold it into the next gen. We don't have an LCD for this project because we've got that fancy new next gen display. All right, P1 and P2. And please don't be shy. Unmute yourself. If you've never programmed a P1 or a P2, please say so or identify yourself. Okay, no absolute newcomers. All right, then a lot of this will be very quick review. This is a table I had done up for a presentation over a year ago, and it just shows the differences between them. We, of course, are focusing on the P2, and these are conservative, some of the numbers. So for example, Chip will say, no, John, you can run 350 megahertz, which you absolutely can run the P2 much faster than 300. I actually run my code at 200. That's a choice that I make. Just remember, the faster you run it, the more energy you're taking. The P2 will comfortably do 300. It will go faster, as many have attributed to. The RAM space has grown quite a lot. We go from 32 to 512. I'm very happy about that, especially for the laser tag projects. The storage now for our program goes from EEPROM to flash. There's 2 reasons: size and speed. And they are related, of course. You know, we had 32K in the Propeller 1. It doesn't take a lot of time to program, you know, a 32K EEPROM, but whenever you got 512K, I don't know that anybody makes an EEPROM that big. You'd probably have to bank them, and then it's a little slowish. Flash is very fast. Now, there is a tiny bit of a downside, is that we don't yet, that I'm aware of, have a nice flash driver. And, you know, that we can use, you know, any way that we want. Flash is a bit different. With an EEPROM, we can just write to any individual memory location willy-nilly without worrying what's already in it. The Flash, there's rules about that, so it's a little trickier to write. Thankfully, that EEPROM that we have, or sorry, that little RTC module that we're using on a project has an EEPROM on it. And so in next week, for saving our settings that we put together, so when we boot up, they you know, the thing comes back where you left it. I'm going to use the EEPROM until we've sorted out a really nice flash driver that's just as easy to do. The cog RAM, to remember, we have 8 cogs. I did already say that. The cog RAM in the P1 is 2K. It's 4K divided into 2 sections in the P2. We can execute the cog rather can run code out of the hub, which makes, then you can have essentially an unlimited assembly program. Is that right, Chip? With hub exec, it doesn't matter what the size of my assembly program is.
That's right.
Okay.
If you run in the hub, you can take the whole 512K.
There you go. So this makes the compiler people really happy. because now they can compile to straight assembly and not worry about size constraints or using something like LMM. IO pins have doubled. Now, the little asterisk I put on there is because there are IO pins on both propellers that have devoted functions. So you'll see if you look in any of my objects, there's a section that are child objects. You'll see a section that says fixed IO pins. So you have 63 and 62, which are the programming and debug port. And then the next 4 down connect, they're the SPI pins for the flash chip. And with some monkey motion, you can flip 2 of the pins and also talk to an SD card. I've not done that, but there are boards that are hooked up that way. The great thing about the P2 is that we have analog capabilities built in, and it's analog in and out. And on any pin, we can do that. And that's through the smart pins functions. The smart pins allow us to do things in the pin that we would normally have to use external circuitry or assembly code to do. So it's really a great thing. I like the P2 a lot. All right, so here we go. We have 8 cogs. They all run at the same time. You know, I get irritated at there are members of the staff of the magazine I used to write for that rhymes with nuts and bolts that say, oh no, they're just running into one at a time. No, they're not. They're all running at the same time. All the cogs have access to power, all the IO pins, and the system counter. In the P2, it's called CNT as a register. In the P1 rather. In the P2, we use a get count, the GET-CT to grab that register. And in the P2, it's actually 64 bits. The cogs run PASM or PASM2. And so that's where the interpreter is. The interpreter is running in a cog and it's assembly. The great thing about, or one of the many great things about the P2 interpreter, the spin2 interpreter, is that we can stuff little chunks of assembly into the interpreter on the fly and run it as if it was always there. I use this very, very frequently where I don't want to have to instantiate a whole cog to do a small process. There's improved access to the hub. I'm trying to go quickly because we have so much. In the P1, only 1 cog at a time was connected to the hub. In the P2, all 8 are connected. And I have a diagram that is an update of what Chip did. Adjacent cogs can share data together through the LUT, right? Chip, it's through the LUT there where they do the share. And we talked about earlier, this is called hub exec. The cog can run assembly code that is in the hub. So you can have assembly programs of any size.
Right, that's right, John.
Yeah. Here's an update of a diagram that I had last year. And this Chip has a really cool animated version of this, but here's the thing to note. In the P2, once a cog, let's say a cog wants to write several values into the hub. Once it gets synchronization with its initial value, it can write on every clock cycle. So that this hub rotator, this middle rotates around, and you'll see that it does that because of the way the RAM is organized in pages where the lower 3 bytes bits point to a page. So it's a little complicated, but here's the end for people who haven't heard me say this before. I took a very simple spin program and ran it on a P1 at 80 megahertz, which is kind of the standard P1 speed. I moved that code over to the P2, made whatever language adjustments that were necessary, but no efficiency changes, just the language naming conventions. I set the P2 to run also at 80 megahertz, and I measured speed differential between the two. The P2 running the same code at the same clock speed was 16 times faster than the P1. The reason for that is several layers. It starts with the processor, of course. In the P1, it takes 4 clock cycles rather per instruction. The P2 only takes 2. We have a much more efficient instruction set in the P1. There's about 70 assembly instructions. In the P2, it's about 350, which looks a little daunting at first. But once you start poking around in there, you find that a lot of the P2 instructions will take the place of 2, 3, sometimes even more P1 instructions. So I have found as I'm porting my P1 code to the P2, my assembly code sections are getting smaller because the P2 code is just more efficient. What was the other thing? Well, and then the hub access, sorry. So the hub access and the way that the interpreter is written, adds that all up. So now, again, that was same clock speed. Imagine now if you take a P1 program and you port it to the P2 and in my case, for example, I was 80 megahertz on the P1. Now I'm 200 megahertz on the P2. Well, that's another 2.5x speed increase. So in fact, again, I was helping John over the weekend with one of his, camera control things. And he has 16 channels of analog that he is using an external ADC because he already had that circuitry set up. And before we needed 2 cogs to be able to read the ADCs and do a running average. So we actually will take the last 4 readings from an ADC channel and average them, and that's what we send out. So what that does is it just allows the ADCs to be really clean, especially with the joysticks. And in the P2, that's all in 1 cog and runs much faster. It's lovely. Okay, for those of you, this is more of my proselytizing. When you're programming, start with a template. It will make your life a lot easier. And Jeff has built into the propeller tool the ability to add a specific P1 template and a P2 template. If you don't have one, you're welcome to use mine. I make them available until you want to create your own, but it'll just make your life so much easier. When you're starting to put together a program, think about what you're wanting to do. I tend to build out the structure of a program with empty methods, just so that I can see where things are going to go. Then I code and test each method independently to the degree I can. There are some times where we have dependencies where you have to do more, but if I can test an independent method at one time, I'm happy to do that. This is my anal retentiveness. Now, if I showed you around my office, you'd think that that hurricane that ran through Arkansas came through my apartment. Well, it didn't. My desk is kind of artistic, say it that way. And but my code is really nice and tidy. For me, looking at that, and since I'm sharing my code with all of you and many other people, do that. So think about that. Just make your code easy on the eyes. Document as you go. This is a trick, and even I catch myself sometimes because I'm working really fast. Once I get into a flow and I understand what I want a system to do, I can code quickly. But make sure you're documenting things. Now, something that I've said many times before is that choose variable names and your constant names that make the code self-documenting. Spin is a really nice language. It's small and it just makes sense. So once people see it and look at it, oh, wait, that's actually pretty easy. Yes, I go through this all the time with new people that that think that nothing exists outside the Schmarshmino. And then they show them what's happening with the propeller and they say, wow, that's really neat. And it's easy. So, perceptions are one of the things our community, the propeller community, have to break down for the other guys, because they think when you hear 8 processors that must be difficult to deal with, when we all know for a fact that it's not. It's the way that it's been designed makes it really nice and easy to do. And, Ken will attest to this. I sent Ken 5 programs earlier and I said, I'm trying to get one more, but I got to test. And I will confess, and I'll show you, I actually pulled a feature out of program 6 that you got today because it wasn't working as nice as I wanted, but I wanted you to have that program. So test, and then send it out. If you look at my programs, they're all structured like this. This is how I organize things through the code. This is where having a template plays out. Set all that up, and the objects that you're going to use all the time. For example, I'm always using serial. and a couple of other things. So they're built right into the templates. Make your life efficient. Okay. Here are the protocols that we're going to talk about today. This is just a review, so I am going to go quickly, but because now we're getting into the technical stuff, if you have a question, just shout out. I'd rather you get what you need right now so that later you're not struggling. So asynchronous serial is the kind of serial that we use going, say, when we're downloading or we're doing debugging. And the reason we say asynchronous is because the transmit pin, for example, transmit from one device to the other is a signal. There's no associated clocking signal with it. And so what we have to do on both ends is they have to agree about timing. And that's what we call the baud rate. Now, there are some devices that can listen and do an auto baud thing where the transmitter, say, will send out a specific packet and the receiver will listen to that and then figure out what the baud rate is and set itself up. We're not going to do that. We're going to make things pretty clean and easy. Now, in the embedded microcontroller world, now most of the time we're just connected point to point, where transmit here goes to receive here, and then the transmit over here goes to the receive there. Very, very straightforward. But you can do on a single wire, and you can do things like the open and driven signaling, 4 different tricks. I'll show you that. But again, the key to understand is the serial is what we're using when we download. And when we talk to the next gen display, for example, we're using serial. So in TTL, which is our 0 to 3.3 or 0 to 5 volts, we're going to normally, well, let me say this. There's 2 modes that we worry about when we're connecting to things: true, which is the normal mode, and inverted. So true mode, the idle state or the resting state of the transmit line is high. So it's in the propeller 2, it would be 3.3 volts. When we start a transmission, that line goes low. This is called the start bit. Now, after the start bit, and the width of that bit is determined by the baud rate. So after that bit, there's going to be 8 data bits. The level of the line for the data bits in true mode will be the level of the bit. So if you have a 0 bit, the line will be low. If you have a 1 bit, the line will be high. After those 8 bits, we're going to go back to the resting position for at least 1 period usually, and this is called a stop bit. There is a mode also called inverted, where everything is flipped. So the resting state is ground, the start bit goes high, the data bits are inverted from what they are. So if you have a 0 data bit, you put a 1 on the line, and vice versa. And then when you're finished, you go back to the resting state, which is going to be ground. Now, there are devices that work this way that we have to deal with. And the great thing about the propeller is if you have a device that wants to run inverted mode, like I think the servos that we did for the RC transmitter, it used an inverted mode. With the propeller in the pin configuration, we can toss an inverter into the pin without having to hook up any external circuitry. It's a really fantastic feature. So we can write our code per normal and then just say, oh, invert that pin, and everything else gets sorted out. It's really, really great. RS-232 levels we don't deal with much anymore, but they're at much higher voltages. And then occasionally you'll get parity requirements. So, oftentimes you'll have then 7 data bits and a parity bit. Again, we don't see that very often. Again, going back to I wish I could remember the name of that protocol. The servo, Ken.
S-bus.
S-bus, thank you. Yeah, with those servos, that they used a parity bit. All right, serial on the P2. If we use spin 2, you can do this. You can write serial code in spin, and you can actually get reasonable data rates going out. Coming in, it's a big problem though, because you have no buffering. You can have serial arrive whenever it wants. So it's not really practical to do it. If you're just shooting a small message, and it's just going out, no problem. With assembly, really easy, and it's very fast. You can do anything you want, and you can even do, half duplex on the same pin. With the smart pins, there's a little bit more work, but I should have actually edited this. It's getting easier as I'm more accustomed to using smart pins, and they can be screaming fast. And we usually will use smart pins with separate transmit and receive, but we can, and I had before I said, hey, don't do this. Well, I edited this over the weekend saying, yeah, you can do it. So for example, there is those of you that are into robots, I know Kevin, he probably knows what these are. There's a actuator called a Dynamixel. It's like a smart servo that has a very wide range, and it will read back its position and all kinds of other stuff. It uses half duplex, and I just wrote a driver because John wants to use the Dynamixel in one of his projects, and I'm using the smart pins, and I didn't have any trouble with it at all. So you can use smart pins with half duplex. You just have to be aware of reconfiguring the pin in between transmissions. It's not hard to do, and I got it working quite nicely. These are what those signals look like. So again, this is what we're normally going to see when we define the serial pin in true mode. The idle state, the resting state, is going to be at, in our case, 3.3 volts. When we want to send a byte, then we take the line low, and this green dot indicates what's called the start bit. Now, this bit width is going to be dependent on our baud rate. And then you see here are data bits. So there's 7 data bits, and you notice they go low bit to high bit in their order going out. And then we have a stop bit. So the stop bit period allows us to offload what we just received into our buffer. So it is important to have that. The inverted mode you see is just exactly the opposite. Everything is inverted. So the start bit goes high, and then the data bits are inverted from what they are in the value that we're transmitting. Again, if you have this in the P2, it's really easy to deal with because we can tell the pin to invert the signal coming in, and everything from there looks like this. This is another way. Now, if you're coding your own serial stuff, which you don't have to in the P2 anymore with the smart pins, but if you were, what we tend to do is we wait for the start bit, and then we set a timer for 1.5 bit periods. That's why you notice that says 1.5, because what that does is that gets us out to what should be the middle of the first data bit, and then we can sample the bit and stuff it into a holding register, and then we do that 7 more times, but we're setting this bit period to 1. And then in the end, we can check to make sure that we went to the stop bit. Now, the smart pin does all of this for us. It's very nice. The only trick with the smart pins is that they always send out N81, and the one is a stop bit, one stop bit. If you wanted to add a little bit of padding between your bytes and send 2 stop bits, it's really easy to do in assembly. With the smart pins, there's a little monkey motion you have to do in the way that I've done it, unless Chip tells me there's a better way, is that I tell the smart pin I'm sending 9 bits, and I set that upper bit to a 1. So it creates a faux stop bit, if you will. And then that way I can get a little extra time in between so that the receiver has time to deal with that. On the receive side, it's not a problem. Okay. Here is a, for those that are new and experimenting, you can get, if you go to Amazon and you can look up logic analyzer, you can find a little tiny logic analyzer that looks like this and costs $12 and works reasonably well. And so you can then download a free program for whatever operating system you care. because it works across all, called Pulse View, and it will capture your signals. And then it built into Pulse View are protocol decoders. So I told it I have a UART, and it shows me what's going on here. So I can actually see this. When I'm doing, if I had a device, I'm helping a friend who works in the IT world do some hardware hacking. And I showed him how to take signals from the device he's looking at into a propeller and read it, but he had no idea what the data rate was. So instead of guessing, we hooked this up so we could actually see the signals coming from the device. And with that, we were able to figure out the baud rate. And then I wrote a little capture program for him for the P2. So now he has a capture system, so he can run things through. And this is something I'd done for laser tag. I had a piece of PC software that I needed to figure out, and the source code was no longer available. So I used a P2 hooked into the system as a spy device, and I could see the transmissions going back and forth, and the P2 logged it all and gave me a report. This diagram, sorry, I'm looking for my water. It's for full duplex. Full duplex means we can talk and listen at the same time, right? In half duplex, only one side can talk. So in this case, the blue guy is talking to the pink lady, and in this case, she's responding back saying, yes, I'd like $1 million. Thank you very much. Sometimes we'll connect microcontrollers together on a bus. This is an open drain or open collector half duplex bus. So only one device is going to talk at a time. And usually the protocol will include a message, some kind of addressing thing so we can indicate which device that we want to talk to. But in this case, we're using a pull-up on the line to create the high voltage level instead of using a driven condition, because imagine if this device was writing a 1, so outputting through the output driver, 3.3 volts, and then this guy put out through its output driver ground. You'd have a short circuit. So in this open collector, open drain arrangement, the way that this works is when a device wants to send out a message, all it has to do is pull the line low when it wants to write a 0 bit, and it floats the pin when it wants to have a 1 bit, because this pull up to VCC will handle that 1 bit. And there's the language or the naming conventions inside the P2 are really nice, because you have pin high, pin low, and pin float. Pin float, is what releases that pin. So if you're having a bunch of devices that want to talk together over a short distance, that's a really good scheme. Over one wire. Okay, sorry, I kind of blew through that. Any questions on standard serial? We all use it all the time without thinking about it, because we're downloading to the propeller. And if you open up a debug screen or sending stuff out or using the internal debug, that's all serial communication. Okay. I2C is another connection scheme that is a contraction for inter-integrated circuit. It was created by Philips, and the idea was so we could connect a bunch of chips on the board through 2 pins. Now, this is called a synchronous system because there's a data line and a clock line, and the clock line is used to synchronize the transmissions. So it is half duplex. It uses that open collector, open drain scheme that we just talked about. So on an I2C system, there are 2 pins. One's called SCL for the clock line. The other one's called SDA for the data line. Both of those will be pulled up to VCC. And so they're generally in the system as a single master. There are conventions for having multiple masters. I've not done that personally with the propeller. I think a few other people have, but I've not needed it. In my case, the propeller rules. It doesn't need anybody else telling it what to do. And it will talk to other chips. So for example, we're going to be using we're going to talk about today and demo today and then use next week, the real-time clock and the EEPROM that are on that module, those use an I2C connection. There is a feature of I2C called clock stretch, where when the master is talking, if the slave, which we call those external device slaves, if that device is not ready or it needs extra time, it will hold the clock line low. Remember that clock should normally be pulled high if everybody releases the clock line. The external device can tell the master, hey, I'm not ready yet, by holding the clock line low. And I think I told this story. A bunch of us in the forums that normally use I2C, we said, yeah, nobody uses clock stretch, let's get rid of it. As soon as I did, my friend Casey sent me a device that he wanted to use that did implement clock stretch. So I ended up putting it back into my driver. So it's in the driver you have from me. It is slower than SPI, which we're not talking about. SPI is that connection that we use for the flash chip, but it uses fewer pins and connections because it's a bus. In I2C, there are 4 elements that make up all of the transactions. You just stack them all together. There's a start condition, which is at the beginning of a transaction. There are write and read elements within a transaction, and then a stop. So it's very simple. If you look in my I2C driver, you'll see it has these things. Now I have enhancements on these where I can do a block read and a block write, but you'll see that they're just bigger versions of write and read. These are the 4 elemental aspects of I2C. It's a very straightforward, simple communication scheme to handle, and useful because there's a gajillion I2C devices available to us. When you get into I2C, you'll often see transaction diagrams like this in documentation. This is from an EEPROM thing. So the beginning, this section is called the control byte, or you'll sometimes see it called slave ID, because this is the device we want to talk to. And then this section here, the addressing will be device dependent. In this case, with this particular EEPROM requires 12 bits. The EEPROM on the P1 has 2 address bytes like this as well. The other thing to notice is that, and this is important because we're often used to sending data little endian, but you'll notice with EEPROMs, they go big endian. So you have to be mindful of that in your driver. And so the nice thing about these kind of transaction diagrams is they make writing code very, very simple. I've got a whole bunch of things. And in fact, a special effects shop just called me the other day for a little movie project, and they wanted me to do some motion thing. And I was able to find a couple of chips really inexpensively they're accelerometers. They use I2C. So I got a couple of different ones to see which one's going to work best for them. And I know I can talk over I2C without any problem at all. Here's an expansion of that slave address or slave ID or control byte. The upper 4 bits are going to be what the device is. So if you see 1010, it generally is a memory type thing. And then you can have up to 3 address bits. So in this case, I could have 8 of whatever these devices are. If it's an EEPROM, I could have 8 of them. Now, not all devices use the address bits, and some use them in a little different way. So you have to look at the documentation. This is something that I always say is once you get a new part, the first thing you should do is download the documentation and save it in your project folder so that you have access to it, so that you understand how you're going to be dealing with this. So for example, the EEPROM on this clock module has an address. It's preset to address 7. So all of these bits are high. The RTC, on the other hand, has the slave ID has no ability to use address bits. The logic being, if you have a clock on the bus, you only need 1 clock on the bus. And so they don't allow you to have multiple clock chips on the same I2C bus. Here's a capture again using that pulse. And what I wanted to show you, this is an actual thing. This is how I figured out what was going on with Casey's little smart encoder, is that here I was requesting data from the device and it was stalling. And then once I looked at it, you see here, here's the start condition up here, and here I'm sending, you know, the request. You see this low right here. This is the clock stretch. This is the external device holding the clock line low. Once that is released, then everything else takes off. So that's a real world clock stretch. It still makes me laugh because I think it was Peter Jakacki and Ray and I and a couple of other people saying, yeah, nobody uses clock stretch anymore. And then I ran headfirst into it. So here you can see the details of the thing. Now, interestingly, you'll notice that when you do a read from an I2C device, and I'll show you this in the EEPROM driver, you actually do a write and you write the address you want to read from, the starting address, and then you restart the condition in read mode. So you can see here's an address write. So you notice that this bit is 0, and here's the same address, and the read bit is set to 1. So everything after that is going to be a read. So there's a couple little niggly rules, but they're easy. And there's that data that was coming back. Okay, questions on I2C? I know we're going very fast because we want to get to the fun stuff. Okay, either I'm muted or everybody else is. All right, we're going to talk about pixels. These fun things. I've got, see, they're dangling all over my desk. These guys, got them all up here. I'll do this now. See them going. Yeah, see, Ken's got some too. Now, the pixels that we're using that we got in the kits last year that look like small Christmas lights, those use a driver called the WS2811. It's the original driver of all of these families of things. I may have told this story where about 10 years ago, maybe a little more, a guy that I work with named Mike Deek, who's he's a really great guy and a very smart effects guy. He's very practical. He knows how to make things work. He's the quintessential popsicle sticks and rubber bands guy in special effects. He can make things work because he spent a lot of years working on low budget monster movies, doing fantastic stuff with very little resources. Anyway, one day he nonchalantly says to me, hey, John, we're always using LED strips. Does anybody make a strip where we can set the color of the LEDs independently? And I said, I don't know. And I think this is in 2008 and 2009. So it's way back. And I have a friend named Corey who imports, ship container loads full of LEDs that he sells across the nation. I called him and he said, yeah, we just got this new thing called the WS2811. And he sent me a roll. And I actually tested the original one using a basic stamp because that was a WS2801, excuse me, because it was a 2-wire system. This is why I was able to test it with a basic stamp, because it had a clock and a data pin. So there's synchronization there. The 2811 is the 1-wire version of that, which now we get into where we've got to have a reasonably fast processor to deal with it. Now the propeller never had any kinds of problems at all because we have very precise control with assembly in a cog. And the great thing about the propeller as well is that we can devote a cog to run whatever device we want to run. This kind of goes to way back when, to the age of what we call virtual peripherals. Ken and Chip will remember that with the SX days, we coded peripherals in an interrupt. Well, here we can put the peripheral in a cog. So we can be very, very precise. So the W2811, if you have these, with the module on them, you can actually see it's a little 8-pin chip. It doesn't have the LEDs built in. The WS2812 has all of that integrated into a 50/50 LED with slightly different timing. There is another smart pixel that gets getting very popular, and with the people that I know in the movie business tend to use it a lot too. It's called an APA. Oh, I have a typo there. It's called an APA 102C. It uses 2 pins, so it's synchronous, and it's very fast. It also, this device internally has better PWM capability, but many of you heard me talk about my friend Rick. I mention him all the time. He's one of my best friends. He's building robots and stuff, for that TV show called The Mandalorian, the Disney Star Wars thing. So there are propellers being used in Star Wars. I can attest to that, and some of my code too. So that makes me happy. Anyway, Rick has got some stuff that he's doing on set now. Is using the propeller and WS-2812s. There are also things you'll see called SK68 and then a number. Some of those are 32 bits, so they have a white color channel. So most of them, we have the red, green, and blue. We have red, green, and blue channels. Some of the other varieties have red, green, blue, and white. Because, theoretically, if you mix red, green, and blue together, you get white. But with LEDs and the chemistry and all that jazz, you never get a perfect white. So the LED manufacturers put a white chip into the thing. And now with just the extent of manufacturing, we have, especially again in the film industry, where we care about what's called the color temperature of the light. There are, even that is now, we have warm LEDs. So it looks more like, indoor lighting or sunsetting. And then there's cooler light, like midday, we call that it's a bluish kind of cast to the light. Anyway, all of that stuff. All of these, the WS-28, 11, and 12, like what we're using, are asynchronous. This is synchronous. They're easy to run on the P1 or P2. These are the drivers that I have. We're going to be using this today. So it will handle any of the single wire pixels that are available. They all run identically, and they all have an 800 kilohertz bit rate. It's just the width of the bits internally that change. So there's a whole bunch of start methods that are built into that object so that you can accommodate any LED that you want. Here's an actual project with WS-2812s. I think I showed this in another presentation. Those of you remember a few years ago when Stranger Things was very popular, my friend Matt, who in his youth was a sign painter, made a full-size set in his house of Stranger Things. And so these are holiday lights. They're Christmas lights from a company called Holiday Coro. And so he did a frame grab from the show, made this false wall. And then he invited people, anybody that came over. In fact, people from the TV show came to his house too, because this got such a lot of buzz in Southern California. And you'd sit there, be talking, and then this phone would ring. This is not his actual phone. It's a prop that looks like the one from the show. And when somebody picked it up, then all hell broke loose and the thing happened. And those that remember from the show, the kid that was lost in the other dimension used the Christmas lights to communicate with his mother. So Matt wanted to do that. So behind this wall is a P1 that has an RS-45 connector on it. And so Matt's show control software is sending commands over RS-45 to the P1, which is then controlling the fade off, fade back on of the lights and spelling words out. So it was really quite fun. I made a miniature version of this for trade shows, which people like. So this is fun stuff that can be had with it. This is what the data looks like. There's a lot coming out. So again, this is a capture from using PulseView. Now here I've overlaid some colors onto it so you can see what's happening. Let's say we had 3 colors in our stream, red, green, and blue. So what you can see internally, there are 24 bits are transmitted for every pixel. And in the WS-2811, we send out the red bits first, then the green bits, then the blue bits. So you can see if you look carefully, there are some wide bits in the red. All of these, I'm gonna stop clicking on my mouse. All of these are skinny. by the same token, you go here where I shaded this green behind, you notice in the green section, there's some wide bits right there. And then in the blue, there's some wide bits right there. So it's really, really easy to deal with. Here are the timing requirements for the WS2811. The way that these things work, because you've got a whole bunch of these individual chips and you've got an input and an output. And what happens is that when the data line is quiet for 50 microseconds or longer, internally the chip resets itself. So it's looking at its input pin. So you send out the data from the controller and the first pixel in the string gets 24 bits. Once it has 24 bits, it flips a switch and it reroutes its input pin to its output pin. So the next 24 bits go to the second LED and so forth and so on. This is how the addressing works. It's automatic based on a switch internally. The other nice thing too is that there's some signal conditioning on the inside of the chip. So if you're a little ragged getting to the first chip, as long as you can get to the first pixel, everything downstream should be good because the signal is buffered and cleaned up on the way out. So my buddy Rick, because some of the pixels really 3.3 volts is a little bit on the ragged edge of the input requirement voltage, he'll just put a pixel on his board and use a pixel as a buffer. So pixel 0 is on his board and pixel 1 is the first thing that's in the object. But here's the timing. You'll notice this period is always 1.25 microseconds for 800 kilohertz. A 0 bit has a narrow pulse and a 1 bit has a wider pulse. So this is how we're, this is it's asynchronous serial, but done with bit width. The WS2812B, which is the very popular version, it's like the strip Ken had, that's how you'll see them often. It looks identical, but if we get under the hood, then you'll see something critical here. Here's the red, I want the first thing to be red, but you'll notice with the WS2812, it sends out its green level first, and then it's red, and then it's blue. So the red and green are reversed from what we would normally think. So if you are running a project and you're trying to make something red and it's green or vice versa, change your driver. So if it is a WS2811, if you've told it that's what it is, change it to WS2812, because that's really the difference between the two, is that there's some small timing variations you can see here. All of this is the same. The 0 pulse and the 1 pulse in the WS2812 are a little wider. I think that's for reliability, but you can run WS2812s running the WS2811 driver. But again, if you say be red, it will be green and vice versa because of the byte order that the chip is expecting.
John, that must explain my red and green being switched in your demo, huh?
Yes, but we were talking about that and then got cut off. Yes, that's exactly why. So if it wants to be red and it's green, change the driver. Okay, for those of you playing along with hardware, this is my JonnyMac. I just photographed this about an hour ago. So here's the clock module. I'm using pins 0 and 1. You'll see this, these are defined in the code, but I just want to show you my setup that's controlling these things. These wires are to the next-gen display. The yellow wire, which is the receive into the next-gen, is connected to pin 8, and the blue wire, which is the transmit from the next-gen, goes into pin 9. And then I'm grabbing 5 volts from this header here. Remember, the next-gen is a 5-volt device. You gotta set it to 5 volts, but at least for the basic and the enhanced units, which is what we're using, the serial levels are 3.3 volts. There is another thing called the intelligent display that's got a red or orange PCB that uses 5-volt IO. So you need to put a resistor in for that. And then these wires are for my displays. I don't know if this will show up, but there's a black 3-pin connector on the wires. I just extended those out with male female jumpers, and then there were 2 loose pigtails, and I just extended those with jumpers as well. So you'll notice I've got 2 reds and 2 blues here. So the reds are 5 volts and the blues are ground, and I put them over here on this servo port because there's this buffer capacitor right there. So since these can take a bit of current, now make sure that when you're running these things, you've got a beefy power supply. I've got a big 5 amp, 5 volt power supply plugged into my JonnyMac, so I can run these as bright as I want without any problems. But this is what my board looks hooked up, and I've tested all the programs we're running today with these connection and verified that it works. Any hookup questions? There's a bit of debris right there. I don't know what that is. Okay. Nobody has any questions at all. I'm that good. Sorry, little cheeky today.
And John, it's quieted the chat as well.
Okay, all right. Well then let's look at some propeller code. I'm trying to figure out the best order I want to go in. Yeah, let's look at propeller code since we just talked about those protocols. So if you have them, there are 6 programs that I made available today. The first one is an I2C scanner. This is the same program that we used last year. I just made a new copy of it and hooked up for here. This is a useful tool that I use all the time. So for example, when I look at these guys, I will hook them in and I will run this program because it will show me what their addresses are. So the purpose of this program, and I might as well just be quiet and run it. The purpose of this program is to look at the I2C bus and tell you what's there. Can everybody see my PST window? Yep. So it went through and scanned the available addresses on the bus, and there are 2 things. This AE, that is my EEPROM that is on the clock module. And so now I know that those 3 data bits that are on the EEPROM are pulled high because that's why I've got those bits high. And you can see that here. Here's I've kind of broken it so you can see here's the device type. Here are the address bits, and then these are the read write. That's the read write bit. So for those of you that have done I2C in the Arduino world, they use just the 7 bits. So if you're porting Arduino code to the propeller using my driver, I'm using the 8-bit style. So just take whatever your address is and shift it by 1. The Arduino does that internally. You'll want to do that externally with my driver. Okay, so 2 devices. So there's our EEPROM and there is our clock. So speaking of clock, we'll run it again. So here is a very simple clock demo, and I'll actually go through the code on this one. The EEPROM is, or sorry, the I2C devices thing, you know how the protocol works. So we'll actually look what we're doing. This particular clock, the DS3231, has temperature built into it as well. So it's a very convenient little dude. I had this same module from last year with a battery in it, and the clock was off by an hour. I don't know why it was off exactly an hour, because it seems like it should have been close because of daylight saving times, but who knows? I've reset it, so it's correct now.
Hey, John, I suspect you have, I suspect both those temperatures aren't centigrade.
Oh, thank you for fixing it. Well, okay, so everybody go in and, yeah, here's an easy fix. Thank you very much.
You're welcome.
I looked right at that last night and didn't even see it. Because I didn't have Fahrenheit on there last night. I decided to put it on. So thank you for that, Stephen. Anyway, easy fix. And so on this, if we look at the object, there is an object for the real-time clock, and it is a parent of the generic I2C object. So if we look at that first, here's the I2C object. Now, because there are of those pull-ups that are out on the I2C bus, you can configure them in a variety of ways. So note to those that are already using my I2C driver, I added this constant name called PU ext for external, because I had none, and that meant, okay, we're using an external thing, but it seemed like it could confuse people, like, okay, we don't need pull-ups. So it's the same thing. We're not using internal pull-ups because we're expecting them external. So this is a purely cosmetic thing to prevent confusion. But if we look, hang on, I'm gonna move these control things around. If we look at the summary view, here is there's the start, write, read, and stop. Those are the basics. Everything else is built on that for convenience, but those are the basics of the I2C command set. So it's really very straightforward. And again, when you look at a transaction diagram that you'll find in the documentation, you can just use these things. Now, if you want to read a block of bytes, like if you're reading a big chunk of memory or writing a big chunk of memory, then you can use the write block and read block commands, because they'll take care of incrementing the addresses. Now, since this is kind of a black box, what I decided to do for best speed and precision, this is that feature I was talking about for those of you new to the P2, where I can use assembly language in the middle of my spin program. And so this is called inline assembly. And I really like doing this. So you see this whole program is, the shells, if you will, are in spin. All the code is in assembly. So it runs really, really efficiency. And I have very tight control over the bit timing. That's why I did it that way. If I didn't care about the bit timing, I'd have done it purely in spin. All right, going back to the clock. Now the clock has all the kinds of things that you would expect. Sorry, so if you ever go to summary mode and you get a bunch of weird background stuff, just go back to full source and go back to summary. I've talked to Jeff about this. We don't know why it's happening. The one thing to note about the RTCs is they have these registers in them, and they run in BCD mode. So that stands for binary coded decimal. And here's the nice thing about it. If we take a BCD value and we say, hey, show that as a hex value on the screen, it will look correct. So in BCD, it's treated, it's like a hex, but we don't use the A, B, C, D, and E through F values. And we only, for each nibble, we only can go 0 to 9. I guess that's the best way to put it. So you can see that in the demo, when here's one of the things that I did. Now, you'll notice this instantiates all the objects for the program, and I have this commented out. It says initialize RTC. But what I did, this is what allowed me to set up the registers, so I could program the clock. Since it has a battery in it, I only need to do this once. But you'll notice, so I'm setting my seconds to 0, and I'm setting the minutes to 30. And so this is 30 in BCD. And then it was 5 o'clock when I was doing this. So it was 1700. I always use these clocks in 24-hour mode. They have 12-hour modes in them, but it's always funky to work with. So for me, excuse me, I find it easier to just work with it in 24-hour mode and then have my program deal with the hours. If it's 0, I know it's 12 midnight, and from 13 to 23, I know it's PM. It's just much easier to deal with in the high level code. So if we, now I was wondering why I'm not showing here. So I have a built-in function in the program that says AM, PM. So if I look over in the in this module, there it is. Here's my time string, and it's taking care of putting those values into a string. But for quick and easy things, you can display in hex. And it will show you, in fact, watch, I'll just for grins, I will, since I have the registers here, I can, and I have formatting in my serial. So by doing 0.2x, that will give me 2 digits in hex format. And then I will do hour min. Now, it's always dangerous doing live demos, so hopefully this doesn't bite me. And it did. Is it 2:14? Yes, okay. I was wondering why I was getting 14:14. It's because it's 2 p.m. But here you can see that I'm running the clock. Now this is 24-hour mode because I didn't do the conversion, but it's because I'm treating those values as hex. So bear that in mind when you're doing displays. It's pretty easy to deal with writing the registers directly. Okay, and so since with this particular clock, we have features built in for reading the temperatures. So pretty straightforward. I won't belabor this. We're going to talk more about this next week when we put it to use. Excuse me. All right, the next program accesses the EEPROM that is on that same module. And we look at this, this will show you what a blank EEPROM looks like. When a EEPROM is erased, it's all Fs, everything. So that's one thing to know. And you can use that to check as a flag. If you have a new product, say, and you want to know if things have been initialized, you can put, your program can assume there should be a non-FF value in a specific spot in the EEPROM, so that when you start up, you look for that. And if it's FF, then you know it hasn't been initialized and you can set it up. So here I've written some a byte, a word, a long, and a string into this EEPROM, and then you know, spit that range of values back out. But I want to show you, so this is pretty easy. 0 is 0. For those, you know, we throw around terms like little endian and big endian all the time, but this lets you see it because these addresses are going, you know, they're ascending, going that direction. So here the value is hex 1234, but you notice that the low byte comes first here. So this is showing us little endian. Same with the long. Notice how the bytes are reversed from what it appears, but that's because this is the low byte and this is the low address. You can see that. And then the string does go in order. The thing to remember about strings, which is very important, is that they need to be terminated with a 0. All the string functions that we use expect a 0 to be on the end of that. Sorry, my LEDs are actually becoming quite warm. So easy peasy, we can read and write to an EEPROM. The nice thing about the EEPROM is that we can write to individual cells without caring what's in there. We are not able to do that with a flash until we get a flash driver. And I'm going to ask if he's still here. If Mike Green is still there, did you not do a flash driver using some spy code that I wrote?
Sorry. Yes, I did.
Because I thought you'd send it to me and I couldn't find it. If you wouldn't mind, would you send that to me again? Because I have need for something like that.
I will look for it and send it to you.
Thank you very much. Okay, EEPROMs are super easy. The nice thing about P1 projects is that Well, in fact, again, my friend John Huffman has lots of products that use a P1, and in the P1, it uses 32K of EEPROM, but you would always install a 64K EEPROM because that way you could put non-volatile data in the upper 32K, and even if you had to reload the program, that data was protected. So again, we don't quite have that yet with the or it's not as easy yet to do that kind of stuff with the P2. We'll get there. All right, finally, unless anybody has any questions on these protocol things, I'm trying to move through fast so we can have fun, because now stuff is going to get real. I almost said a bad word. All right, so this demo runs these pixels. And you can see this is my unified, oops, not that. This is my unified pixel driver for single wire pixel, the asynchronous types. And it has different start methods. So for these guys, I'm using the WS2811 driver. I don't have one here close. Those ring LEDs you can get from all over the place. Those generally have WS2812s. Now, this will look, some of you that participated last year were going to say, hey, way to recycle, JonnyMac. Well, you're right, I did. This is a lot of that same code, but, heavy but. This code is written in a better way because it's state driven. There are no delays built into this program. Everything is run in a state machine, which is really a better way to go. The reason for this, and I know, again, this seems plotting, but as you'll see, I'm going through and I'm building a small thing. Yep, that works. Building another small thing. Yep, that works. We go building all these things, and then we can ultimately build out a bigger system knowing that's working. The reason I wanted to redo this program as a state machine is that I wanted the ability to be able to interface with the next-gen display in an easier manner. And this allows that. You'll see that shortly. So if we run this program, you get the similar menu that you saw last year. Notice my lights turned off because it's out. So I have 7 different states of this. Now these have built-in colors. I could pull this down now. So these are my built-in colors. This is a red, and this is a whitish color that's not too bright, so that I don't blow things out. So in this case, if I press 1, bing, the lights turn red. You saw that on my face. 2, they turn white. 3 will flash in between them. Now the flash rate is about 1 second, so it's slow. The fade, I think, looks nicer. It actually does a morph going between the 2 colors. You probably won't be able to see it on screen. Maybe you can. Here, I'll play Rudolph. You notice the color is changing. So it's doing a morph command in between. Then we have the always popular marquee kind of chase thing. So if I do this, this green screen is just a hassle. But you can see it's chasing around, and then the twinkle. Oh, I was clicking on there like it was an active screen. Sorry. And now we get this twinkly effect that we had last year. But you remember last year I had to put, we would actually run out and run the code, and then you have to escape out of that code to get back to the menu. This is running completely differently. In fact, if you look in the program, this is program number 4, the only delay that is in the program is right here. I do this as habit. I have this thing called wait for terminal, because when I'm running a terminal program, if you can see my hands, I press F10, then F12, and then enter to enable. And that will, when I do that, that will clear the screen. So the wait for terminal is waiting for PST and the enter, and then this will clear the screen. And then I just put the 100 millisecond delay in there just to make the screen flash so that I know it changed. So that's just for me to see things. And then this line is drawing this menu. And then here is our state machine. So just running in a repeat loop, this check state method will look to see if we pressed a button to change the state. And then based on our current state, we will run through and do these functions. So the first three are actually quite easy. It's we either clear the strip or we set the fixed colors. Then these are time-based states. So those get a little bit more interesting. So let's look in the check state command. Now this again is a keyboard driven program right now. So the first thing that we do is look to see if we pressed a valid key. In this case, it's going to be 0 to 6 on the number keypad. If it's not one of those, it's nonsense, and we just go back and continue running. The case with state-driven programs like this is you each little thing that you're doing, you want to spend a very small amount of time in it so that you don't get caught out somewhere. Now, if it is a valid state, then what I'm doing here is I'm converting it from a character to a digit, and then I look to see if it's the same as I already have. If it is not a change of state, I abort and get out. Now, if it is a new state, then I would fall through, and so I set my state value to this entry, and I reset my substate, which is used in some of the programs, to 0. And then I start a timer. Now, this isn't a timer object. This is just an internal bit of code that some of you may remember. I kind of harped on Chip last year to put get ms back into the interpreter. And here's why. So I have this timer start. All I'm doing is I'm grabbing the current milliseconds counter from the P2 and calling that sync. And then I don't use this one yet. I can, and then here, if I want to know the millisecond since I started that timer, I call this. It's stupid easy, but gigantically useful. So whenever we change the state, we're going to reset the timer, because some of the things like the flashing and the marquee and all that have time elements built into them. So this is when I do things like this, I call it an internal object. I actually did just move this code out to an object I knew that I would. Here's just for the way that I do things. You'll notice that these are all called timer underscore and then a name. So start, adjust. I copied all this out and then got rid of the timer underscore in the external thing. And then this is in another program you see later. Then I just called the object timer. So for the code that I copied from this, it just says timer dot start instead of timer underscore start. So it's if you, again, with a little bit of thinking, I saved myself a bunch of editing. All right. So now that we're going, there are in the stuff that we're doing today, we're dealing with fixed timing values, so you can adjust them here. So state 3 is the flash between the two colors values. So I'm doing that every second. Now, the next one is called fade, and it has a very short delay. So this is why we want to get on with things. We don't want to wait around too much. It's 8 milliseconds, because what I'm doing is I'm using the morph command in my object. So the morph command takes two colors and it will morph between them based on a phase setting. So the phase setting is a byte, so it's 0 to 255. So if I have a phase of 0, I have these two colors. A phase of 0 means all of this color. If I have a phase of 255, it's all of this color. If the phase is in between, then it's what I'm trying to say, it's a blend of the two colors. That's why I call it morph. So what I'm doing is I wanted that phase, I wanted the change in my LEDs to go from one color to the next color in about 2 seconds. Well, if you divide 2000 milliseconds by 255, then it's about 8 milliseconds. So that's where that is. The next one is the chase timing. And then this is the twinkle timing. And the twinkle will take your color 2 and it will multiply it by, I think I have it set it to from 20 to 100%, or maybe 25 to 50%, and it randomizes it. So you get a nice twinkling effect of whatever you have for color 2. Now, this is a thing that I do often in programs that have displays. Think of it this way: if I was switching into a mode, I'm switching from one state to another one where the first state has a fast time and the second one has a very slow time. I don't want to wait for the timer to get all the way to the end of that new timing condition to do something. So I set a flag called dirty. And what that means is, no, even if the timer hasn't expired, refresh for the new state. That way you get an instant change. In our laser tag products, for example, if you get shot or you shoot somebody, or because you're running out of ammo, every time something happens that could affect the display, I set a flag called dirty so that when you're iterating through the displays, it knows that it needs to refresh them. And this just puts the state on the display. So it's pretty straightforward. And then here's how the code works. Here's the flash, which is pretty easy. So what we're saying here is, if the timer hasn't expired, so the current timer value is less than the delay for this feature, and the dirty flag isn't set, then get out of here. Don't do anything. Just go back to the top of the state and keep checking. If this falls through because the dirty flag is set or the timer has expired, we'll reset the timer, clear the dirty flag. And then in this case, all I'm doing is toggling the substate value. And then here, I'm just setting the strip to either color 0 or color 1. Really super easy. So they would just toggle back and forth. So you'll see the general architecture of all of these are this way. The first thing we do is say, hey, do we need an update here, or is the timer expired? And so that's the first thing. So the fade is a little bit more complicated, but you'll see it starts out the same way. Is if the timer is expired or we're dirty, then we're going to run through. If both those conditions are true, we'll leave. Here we're restarting the timer. If in this case, if it's dirty, I reset the phase and direction values. So in this case, I have a couple of variables that are only applied to this method. And so, Chip, you know what would be really fun someday is if I could do this. So I could have variables that were static to a method but couldn't be clobbered by the rest of the program.
Oh, okay. Well, yeah, they'd have to. Right now,
they would be in the external space. They just wouldn't be accessible by anybody else.
Yeah, they couldn't be put on the stack because.
Yes,
you're
right. They couldn't be stack based.
So they'd have to become theirs, I guess.
Yes, they would not, and that's what I'm doing here. It's just that these variables can be seen by the rest of the program. I want to hide them from the rest of the program.
Right.
Not a big critical thing, but I was thinking about that today when I was doing this. So again, you're going to see this same architecture through and through. So this just says, hey, do we need to run now? If yes, we restart the timer. Here, if it's dirty, we know we're starting over. So we reset the phase, which is going to be our morph control. And then the direction, because what I want this to do, just so you're seeing my understanding here, I want phase to go from 0 to 255 and then from back down to 0 and just ping pong back and forth. So that's going to control those fading between colors. So so in this case, phase starts at 0 and ends at 1. I clear the dirty flag, and then each time through, when on our time element, we add the direction into the phase, and then we use the morph feature of the phase to go of the pixel driver to go between color 1 and color 2. So you see that this controls the degree we get on either side. And then this just checks to see if we've hit an endpoint. So if we hit 255, we can only get there coming from 0. we reset the direction to -1. If we hit 0, then we reset the direction 1. Very, very simple. Again, you'll notice all of the code in these modules is very short and sweet and tight, so that we can just be constantly going through the state machine and making sure that we're processing things as we want. The chase is, after thinking about it for a few minutes, it turned out nicely. Again, all this control is the same. So in here, I have a buffer, because what I decided on my chase is I have 4 pixels in a section, and one of them will be lit. And then they're, it's going to look like the pixel is moving. And sometimes people will use 3 pixels, but I found 4 just looked better. You got a natural, you could tell the motion looked better. So we start out by filling that buffer with color 2. So that's our background color. And then we set the element that is defined by substate to color 1. This section will, you notice I've divided the number of pixels in my string by 4. And I have a local variable here called ch, that's for the channel in the string. And what I'm going to do is just move those into the string buffer. So I'm going to grab the buffer and I'm going to move it to the pixel buffer, at this channel, and then just advance the channel pointer. So that'll go all the way through. If you, like in this case, I have 50 pixels. So if I divide that by 4, I get 48 on an even value. So this will take care of the last stragglers. And then I update the substate. Now this, I was looking at this and I remember when I'm writing code that is for others to use, I'm always very, very obvious in the way that I do things. And if this was for internal use and I wasn't going to show it to anybody, now this is obvious to me, but here's another way to do that that might be a little faster. You could say substate because I want to keep substate between 0 and 3. So in a case where if I have a power of 2 number, I will do it this way in internal code. In fact, I was talking about that ADC averaging thing that I was working with John on. I do this because I have an index thing. So just this code and this code does exactly the same thing. This is a little more obvious for newcomers, so just bear that in mind. All right, Twinkle, this behaves the same as last year, just looks nicer, and all I'm doing here is taking color 2. So I will do I'll grab a random value. So it is 25 to 100%. So I grab a random value between 1 and 4. And then I use the scale RGBW feature inside the pixel to take color 2 and multiply it by 64 times whatever this is. That will, and in fact, that will give me brightness levels of 25, 50, 75, or 100% randomly. So this string will twinkle. So it's the same code as last year, just written much more efficiently. So if you put a little, blip on here, you'd see it and put it on a scope, you'd see it screaming through pretty fast because it's not running very much code at any given time. And it always is between every access to any of the states, it's checking to see if there's a change. Now, where is this going to come into play with the nextgen? Well, remember the nextgen can send serial messages. So we're going to process those messages in this section so that if we tell the display, hey, do something different, we can process that and get back in. You'll see the framework is, this framework works nicely. But as I was saying to Ken earlier, we don't always have to throw a cog at everything. This, is seeming to do multiple things at the same time because of this state process. And it's fairly simple to set up. Sometimes people will refer to these kind of programs as schedulers because you're kind of going through and doing things on a given schedule. but it's an efficient way to do things. Again, my laser tag project, the whole system runs this way, constantly going through, checking, do I have a radio input? Do I have an infrared input? And then whatever is going on in that particular state, iterating through. And sometimes there are substates in that, from displays or sound effects or whatever. And it makes the system easy to manage once you get a handle on the whole state concept. Questions? This has been a quiet group. I'm going to have a drink of water because I'm doing all the talking, which I know people are saying, yeah, you're always talking. Okay, well then let's pop over to the next gen. Did I break it? Oh, I unloaded it. That's why.
Yeah,
So,
I didn't see it on your taskbar.
yeah, I was clicking on that blue thing that was
Zoom.
It's the Zoom button. Yeah. So. I had all these loaded up, but I couldn't send you the files when I had the next gen editor open. So the first thing we'll talk about is, you'll remember this from last week. This is that simple passcode demo, and I'll just run it very quickly. This allows us to put in a code that the thing knows and send a command. And you saw out here a message that said locked equals 0. If I click on a key, it'll tell me I'm relocked. So very simple. Now, if you look into last week's version of the code, every one of these number buttons has a little chunk of code in there, but it's essentially the same thing. It's saying, hey, this is my key value, now run this handler. Well, in the next gen, they have this thing over here called a touch cap. I thought touch cap had something to do with capacitive touch screens. It doesn't. Touch cap is a contraction for touch capture. So what touch capture does, you can see I have one here called TC0. What touch capture does is it grabs the component ID of the last thing that you either clicked or released, and then it has its own events for, for touch, for press and release. So here's the code for the touch cap. What I'm doing is I have a global variable over here called int IDX. So that's what I'm using to grab that value. And so this is grabbing the value of the last thing that was pressed. Now here's where those component IDs become important. So I'm checking here to see if my component ID, which is what this is. So this value that it returns is the component ID of the last thing you clicked or released. And so if it's between 8 and 17, which are the IDs, move my, so if we look over here, if I click on button 9, you see that's ID 17. So this is where there are times when you want to keep your IDs in a specific order. So in this case, these guys that I do the fill in dots, that's IDs 1 and up to ID 7. And then following that, this is ID 8, 9, 10, 11, 12, etc. in ascending order. So when I go back to the touch cap code, again, I grab the value of the last thing, in this case, the last thing I pressed, that's going into IDX. If it's between 8 and 17, which are these buttons, then I'm going to 0 index it by subtracting 8. So now it's going to be between 0 and 9, which matches the digit on the key. Remember, this converts a number into text. I'm going to add it into my entry, and then I'm going to do the check. So in the old version, we had entry dot text plus equals, and then I had a fixed string, but I had copied and pasted that into every button. This, if you look here, no code. None of these buttons have code. And not in the press or release. It's all in here because they're doing the same thing. So this is an efficiency thing. I found a calculator demo on tutorial that one of the guys who works with Nextgen did, and it was a very big hex calculator. All of the keys on there had no code in them. There was a touch cap object that took care of looking to see what was pressed and then handled it like this. So it's a neat efficiency. So that's in there. Well, the reason I'm bringing that up is because next week I'm hoping to have a keypad in part of our light control project where we can set the clock from the Nextgen display using a keypad.
So John, show me where you stored the password. I could never find it.
Oh, so there's a there is a variable here called solution, and when we I wonder, can I pull that out? Oh, I can't. When we go into the page, then we set the solution here. Now, if we were talking to the propeller, I would probably send a message at this and told the propeller that I'm ready, and then the propeller could change this by sending a new code that looks like this over its serial link. So here, this is setting the solution, which is the entry code. This is just clearing the, my entry. And then again, when you look at this, we're taking the key, converting it to text, and then adding it to the string. And then the check, this thing just checks to see where we are. And if they match, then it will change the heading to unlocked, and it will send this out the serial port. It also changes the locked pick. So we go from locked to unlocked. So there's very little code in this project. It's pretty trim, and it's even more trim now with the using the touch cap. So if you're doing things with lots of keys on it, and they're doing essentially the same thing with maybe a small value change, then look at the touch cap to reduce errors and the amount of code you have. Okay, I want to show you really quickly how I did the display for today to encourage you to get artistic with your display. So I'm using Inkscape to do my Nextgen panels. So this is, I'm doing it set, and I should set that in pixel mode. So I click on here, you can see that this is 480 by 320 pixels. But any of you have done, any kind of graphics program or used to layered, programs. So what I have in this, and I do in a lot of things, that I have this faux aluminum texture that I like. John likes it too, so we've been using that on our projects. And then what I did is I wanted to be able to tint that, so I threw in a background color that is transparent, or translucent rather. Here are the controls that are dropped on top of that. Now the sliders, I'll talk about this in a minute. I wanted to make the sliders on this, I didn't want to have to put red, green, and blue text on the thing since this is a lighting thing. So these are very simple little, there's nothing to these objects. There's a background and then a highlight and a shadow, but I made it so that it looks a little bit dimensional. And so these match the width of the slider object that is in my Nextgen project. So I have 3 sliders here, and then I have another one here, and then I did that pip there. And then these are going to be my color samples. And so I just have a black to start there. But the great thing about this is sometimes moving around the objects in the Nextgen display can be a little tricky. So by doing it in Inkscape or another graphics program that can do things at the pixel level. Now, for example, I know that the X is 352, the Y is 22, and it's 106 by 22. And I use that. There's a command called fill that we're going to be using, and I need those values. So the reason I like Inkscape is because it's just a little easier to muscle things around and then do these artistic kind of things. Now, you saw there are radio buttons, and then here's the text for those. I decided to put the text on this because I'm not going to change it. You can make it more generic by leaving that off and then having text fields in your NextGen, and so you can change them out as you wanted. And then remember, we're going to be treating these like radio buttons. So we need two images. We need an image with everything off, and then we need an image with everything on that could be on, and that's what this image is. So you see these all light up. And then we use the crop tool to decide which one of these is on. So it's really, really clean and straightforward. Now, I often will do this too. I'll throw in a layer. This is for my use. I'll say, hey, this is where I want things to be, so that, again, I can click on a, sorry, I have that locked. No, I can click on one of these yellow things, and it will tell me the XY coordinates of where it is. So I can more carefully position things in here. This is an easier tool to use, and then just translate that data over into the NextGen editor. So this is my approach to creating screens for NextGen. So now we'll look at the so that those graphics you just saw, this is the controller that we're going to use. This is going to be the meat of our pixel control code. So there we are. Now it sends out serial messages to tell you what's going on. So when it starts up, it says, hey, I'm in state number 1. Now, so that's changing color number 1. So if I slide this red guy up, green guy up, so I can create a blended color. And when I click color 2, since it's currently black, it will reset the sliders to that and go back. Now you notice when I go back and forth, it goes. So as you look through the code, you'll notice that whenever I change one of the colors, I save it as a 32-bit value that matches what the propeller wants to use for the pixels. And then I do a fill of this, because remember the NextGen uses 565 16-bit color. So I will take the RGB values that I have and make that. So it's a pretty close approximation. I was running this today, and it's pretty good. And so you'll notice here, anytime I change the state, I'm getting a state command, and then I have a delay. We won't be using this today. I could not get that to work, but, and why do I not have, oh, that's not working. Maybe that's why. At any rate, we're not going to be using the delay slider today, but we will next week. So this is the code so if you download it, as Ken and I have, into your NextGen, and then run this final program. So that's this NextGen pixel controller. Now, big fat warning right here. So if it blows up on you, please don't kill me. It is mostly working. And this was not even supposed to be presented today, but I really wanted you to be able to control the pixels with the touch screen. So if you look, this is the same loop that I had in the other program. I've just changed it from check state to check command. I'm presetting the state to 0 because that display that I just did on the NextGen, it doesn't have an off anywhere on there. So for the moment, I've just removed that. We're going to put an off button on another screen next week. And then here is what was check state in the other one. This will go through. So you've seen some of the features this is using from last week when we were looking at, I had a terminal program for the NextGen, so we can just send data back and forth and watch things live. And so the first, when it comes to this, it looks to see if there's a command message from the next gen. If there isn't, or if it was an error message, if it's an error message, this get HMI message will return a negative length. We can just throw those away for the time being. So if there's no message or an error message, we just kick it back. If we do have a message, we're going to parse it. And we have these are destinations. Remember, the way that I do things with the next gen mostly is I have some string, an equal sign, and then the value. So if we go back over to the next gen display and look here, it says state equals 2, and then there's a carriage return after that. So that's how I'm formatting my next gen command messages. I have some command equals some value, carriage return, because that's very easy to parse. And so that's what this does, or sorry, this does. And these are my target buffers for the command string and the value string, because it could be a numeric or a string value. Now, this and the return variable value rather from this is the type. Type 2 means, and I should document this, means, hey, it's a command equals value type command. It's not just a page, just a single word command, which is one thing, or a bogus command. So in this case, I want to make sure I'm saying some entity equals some value in that form. That's what 2 is. Otherwise, so if I don't, you'll notice again with these state machine things, we always look to see if we can escape quickly, if something's not on track. So if we fall through to here, we have a valid structured command. So we're going to convert the command, which is the left side of the equal sign, to an index. Now down in the program, we saw this last week. What I've done is I've changed the code. So here are the commands that this program understands from the next gen. It's going to say state equals something, color 1 equals something, color 2 equals something, or delay equals something. That's what we're going to get from the display. Those are the 4 things it understands right now. And so if I have a string that says state equals, then that method is going to return an index of 1. So this is a 1, the initial point is 1. If it's 0, it didn't find it as a command, so it's not a known command. Now then, if it was a state command, and the next gen actually filters this, so this is actually redundant code, and I maybe remove this. So if 1, that is the command was state. So we're going to grab the value on, this is the value that is on the right side of the equal sign. And if the state is not equal to that, the current state of the program, then we set that. And then the other 2 that we care about, at least for the moment, are the colors. Now the color gets sent out in hexadecimal. If I come over to the here and I go to color 1 and I move the slider. Oh, sorry, I don't know what's going on. One of the things that I didn't want is just a flood of values. So I have to enable the timer to send that. I've got a timer in here, and that will allow, you notice how as soon as I did that, I got a couple of messages. When I'm sliding between 0 and 255, I don't need all of those values. So what this will do is it's every 20 milliseconds, it will send whatever the current value is. But you'll notice here, I can't make that any bigger, but hopefully you can see it says color 1 equals $, and then the value. So I'm sending it in a format, in hex format to the machine. Again, remember, we could look at this in a standard, in the program that I included last week. We could look at it just as text, so we could see what's going on. And so in this case, I know that color 1 and color 2 come across as hex. So this method will convert anything on it assumes what's on the left side of the pardon me, on the right side of the equal sign is hex, and this will convert that value. And then normally we'd have a change of state coming through here. So this is setting up my values for the different states. Next week, we'll be able to read that slider, that state slider, and change it on the fly. And then just like before, anytime we might have to do an update, then we set the dirty flag. So if we run this, one of the things you'll see is that when you have it on your screen, no matter what condition your screen is in, if you're running this next gen code, it'll reset everything to 0. This is kind of a very late addition, but it works better. So down in the setup, after we've started the serial for the next gen, I give it 100 milliseconds just so it can be ready to go. And then I have an object in the device called HS, so it's a hotspot reset. When you click on that, it resets all of these sliders to 0, and it sets the delay value to 0, and it sets the state to 1, which is color 1. So that cleans up everything. And then here's a key thing. See, that's what I just did manually over there. This enables the timer, so now I can register the slider events coming back in. So if well, now I am running this program, so I guess I'm not. Oh, I know why I'm not, because I have a menu in here. So let me go back to this. So when you run this program, because it's using the menu so you can see what's happening, just remember you got to light that up. So right now I'm in state 1, which is color 1. So I can't show you on camera, but I'm going to, hopefully you'll see these LEDs around me. If I push the red slider up, notice how they're going. So I'm controlling them live. Hopefully Ken's able to do that too, because he's got a hookup. And the green button and the blue button. So I'm doing live control of the LED colors with the sliders on the next gen screen. Are you doing it? Is it working for you, Ken?
Yeah, I'm just short on hands.
Yep. Yeah, that is the trick. So if I switch to color 2, which is currently black, everything goes off. If I click on flash, then it should flash every second. Fade, it will do that slow fade between the two. You see that kind of slow throbbing deal. Ken was doing the chase. So hopefully you can see that. And then twinkle. And my twinkle's not working. Oh, I know why. My twinkle didn't work because I was using, twinkle uses color 2. And I had color 2 set to black. So if I twinkle black, it's always going to be black. And so now it's working. So one of the things, as you have time to sit through this, if you look at where I did the text version of this and the next gen version of this, everything runs identically. And I think this is an important aspect of development. It works for me, is developing things in a way where, you can use easy input. So we know that once we got all this stuff working, then it was just a matter of replacing how we're changing the state with the next gen interface, which we had proved in another program. So I promised Ken I would stop after 2 hours. So I'm going to stop talking and just start listening and answering questions that anybody has.
John, a quick question.
Yes, sir.
If you already answered this, don't do it again, because then I missed it and it's my fault. I'll go back and watch the video.
No, I'll answer.
How did I'm not sure I saw you associating the color button to the slider itself in the next gen.
Oh, that's inside the code. Yeah, we didn't get deeply in there, did I? So we'll look very quickly. So we have the 3 sliders and they have their events here. Sorry, let me move my.
So you generated the images outside of the frame, but then somehow you associated those images to the sliders.
Oh, yes. Sorry. I know what you're talking about, Stephen. No, you didn't. Yeah, because this is kind of an advanced, well, not an advanced thing, but it's something that I saw a guy had done it on the internet and I thought, oh, hey, I'm going to do that. So here I have a slider, and over here, trying to look if I remember so here was, it says PSTA.
Mhm.
That tells you what it's going to look like. Right now it's set to image. So if I change it to solid, then
It's got the flat. effect.
because I'm looking on the see, that was changing just this button. The
Yes.
the picture values are what's doing things. So here it says pick 0 is image 0. Sorry, these figure out how to get rid of my zoom control. So here's pick 0 and pick 1, which are the background images of this.
Mhm.
And here are so there's, you can see ID2 is the red, ID3 is the green, and these are the little thumbnails, for the
Yes.
sliders.
Yes.
And the final one is 5. So for the blue slider, ID4 is so pick 2 is going to be the thumbnail. The background of it is coming from pick 0, which has that, that machining,
Nice. Yes. Okay.
and so those are where you set those things. Now,
So you did end up uploading the images of the buttons themselves as
I
tiny-
did. I uploaded my whole folder. So you have the source SVG file and also the PNG files that I'm using in the project. Now, caveat with the basic and the displays we're using, you couldn't put, for example, a round button on there with this background because it doesn't, the small displays, they have very small SCM processors on them. They don't understand transparency. Now, the intelligent display is the one with the red processor, the red PCB rather, it does, you can have odd shapes. So that's why you'll notice everything here is rectangular, so that it's nice and clean. Because I have this, I have this textured background and I have these graticules in there and all that. So if I'll try it. I do have an intelligent display, so I'm going to try it with round sliders or, with a line in them. But even with this very small change, I think it's much more attractive than their generic slider, which is just flat and has these funky background colors. Now, in this guy, it's doing the same thing, but with less effort, because all I had to do is change out the thumbnail, and I made both of the background colors black for that. And so, again, this is I live alone, don't have a lot going on in my life beyond what's sitting here on my desk. I like to do artistic projects with technology, and Inkscape is a wonderful tool for a whole slew of things. I do all of if I have an odd shaped circuit board, I use Inkscape. If I'm doing laser cutting, I'm using Inkscape. And a lot of the services, will accept SVG files directly now. So you don't even have to convert to a DXF or anything like that, which makes it really, really great. In fact, I thought I had one here on my desk. I made a medallion for my friend Emlyn. So this is, I don't know if you can see it, this is a stainless steel. It's 1/8 inch stainless steel. And this is her kind of her Star Wars logo. It says M4N. So that's her name, is M4N. And it's stainless steel. And I got this for $3. Send them the SVG file, and they cut it out, laser cut it out of stainless steel. So I made a bunch of them for her for her birthday, so she can mark her Star Wars cases and things like that. So I live in an apartment. I can't cut metal in here. I'm limited to soldering, and so it's nice that all these services, these machining services, are accepting that.
John, is that place stateside?
Yes, it's called Send Cut Send.
Oh, okay. You've talked about it before.
Yeah. They're I think they're in Oregon. They're on the West Coast. Great service, very nice people, and they can cut, I think, up to a 1/2 inch stainless steel. Yeah. Yeah. Again, I don't have a machine shop, and, I have access to Rick, but he's very busy with the Mandalorian and those kind of things. Yeah. So I guess I could talk a little bit more about this program. So this is kind of state conditional too. You'll notice on my sliders that I am, when I'm making a move on a slider, I check to see if I should actually change that to state. I'm calling it program internally, but it will call this function, which is hidden here, which will take care of making, and that's now, sorry, you can update this. I changed this to 32 bits today, so it match up. But this will do conditional things as well. So you have to be on color 1 to make a change of color 1 with the sliders. You have to be on color 2 to make a change. And if you go between them, it will grab it saves a background color here. You can see color 1 is what I save. And then here in this function, it's called HS show. This is where it will take the sliders and it will convert it into that 565 16-bit. And then here is that fill command. So that'll fill a rectangle here or here, depending on which is selected. So there are some basic graphic commands, fills and lines and circles and that. This I found was a better way to go. In the first time I was experimenting with this, I had a flat button on there and I was changing the button color, and that just seemed inefficient. So as I continued to look through, I mean, even though these are fairly low cost devices, they're really extensive. If you go through their instruction set, there's a lot to it, and we're not using very much of it.
So, John, should I be able to have this working with just my JonnyMac board, the display, and the string of lights? Those three?
Yes.
Because you showed that other device.
Yeah, the clock module is not involved in this program.
Okay, that confused me.
You know what? Here's the thing, John. So if you don't have that clock module plugged in, go into the setup method and look for, because I pre-built this code for the whole thing. So you'll find start methods for the EEPROM and the RTC. Comment those out because they may be snagging because that thing's not there.
Yeah, because mine's not working and with just this.
Yeah, go into the setup program and comment those out and retry it. I bet you that's what it's because there's no, it's looking for the I2C line to be pulled high and it's not.
John, I didn't have that hardware installed and I didn't have an issue.
Oh, really?
Yeah. John Huffman, did you upload the display image?
Yes, but I had to change the type because I've got the enhanced version. So I changed that in the HMI software.
Yeah. So for what? Sorry, John, to interrupt. For those that are wondering, I had set this up on the basic, but if you have an enhanced like what John's using, then you can go here in this device button and go to the device and you can change. So here I have it set to basic. So what John did is he clicked on enhanced and then that size and then downloaded it. You do have to do that. When you try to download, if it's compiled for the wrong type, it will get grouchy. Another thing, I don't know if he's here this week. I haven't heard him. He usually participates quite like Carol Moore asked last week, hey, can we get rid of these labels on here? And you can by clicking, there's a hidden button kind of right there because this looks like it says device ID, but those are actually two buttons. So if you click on ID, it will turn those off. That was a question Carol asked last week, which is good for, I think for screen grabs, because when you're in edit mode, you can zoom in and then you can turn that off and do a screen grab for documentation.
I have a question.
Yes, sir.
Are you going to get to the point where you do talk about implementing multiple cogs with this or not? I know you said earlier that there was no need for multiple cogs, but that would be nice to see as a good programming example if you did do that.
I can, I had originally had anticipated doing that. So John, can I talk about the architecture of your project? He walked away from his desk. He told me yes. So John, is it okay if I tell him how we're doing? Okay, so yeah, see, he just leaned in and gave us a thumbs up. So with John's project, John's project is a camera control system. And so he's live controlling cameras and lenses and a lot of stuff. There's a lot of stuff going on in the foreground. And he designed his next gen, his next gen setup. He's got 16 or 17 pages. He has a lot of things going on. So what we did was in fact, I'm not going to be giving away any of his trade secrets. Let me just load up that program. So you can use a cog, but you don't have to. Well, I didn't think we had to here. So let me show you how I did it for John, and then then you can
John, while you prep that, I just want to thank you because I have to go on another activity. So I'm going to pass the host over to Chip.
Okay. Thanks.
Thanks so much.
Oh, here, what? Oh, good. To remember where we had that. Sorry, I don't remember. You can see I've got lots and lots of files. Again, it's always doing test files to make sure that things are okay. Here's where we did that. Let me do this. All right. Okay, so now this is a test program. So again, John and I, when we work on projects together, we follow the rules I was talking about. There is nothing going on in his foreground, although in his actual product, there's going to be a lot going on in the foreground because it's reading all of the joystick inputs and pod inputs and all those other things that are actively running a camera. So what we did here is you notice where it says, what I'm doing is I'm running a cog called Next Gen Display. So I'm running this. This is a spin cog that I'm loading up, and that's down here. And this is it. This is the cog. Now there's a few things, behind that. But what this does is it looks for a command and looks for, then gets the value. It checks to see if there's a new page. In John's design, he has several pages with multiple values on that. So when we first go to that page, we upload the values to the NextGen that need to be modified, and then we mark it. And so you can see it's actually quite simple. Now, we made this decision on his project because the foreground is doing a lot of work. What the background is doing, whenever you make an adjustment to a value on the NextGen, it's updating a global value. Remember, when you have two spin cogs running in the same project, they can all see the same global values. And so if you want, I'll reconfigure this program, to do that. But it would just be taking that, check, where it says check command and sticking that in its own cog. So it's really simple, but I'll do that next week. I'll make a separate version if you like.
Okay.
It's just,
if it's not too much problem.
It's not, no, it's not. And it's worth it to show people how to use, the nice thing is, again, with the P2, the spin interpreter is really efficient, runs really fast. I was going to use the structure now. Again, with John's project, he's doing a lot of things in his foreground program, and we didn't want to slow that down with anything. So we just instantiated another cog to handle all the message processing and updating variables that the foreground is going to be using live.
Hey, John,
Yes, sir.
I just realized something. Doing that static thing and in making them a var, which is kind of the only, I don't know how else to do it, but by turning it into a var, if you had multiple cogs running those little methods, they'd wind up with communal variables by those names.
Oh, yeah. Yeah, you're right. And that does happen from time to time. We are, yeah. Yeah, like it was the thing where I thought, man, if I don't, but that's why you'll notice when architecturally, I will often, thankfully the compiler tolerates this quite a lot, you know, where when I have a, you know, where I would have liked that these could be static here, I just stick the variable declaration right on top of where it belongs. So I know that
Oh, yeah.
those are associated with this. Now, thankfully, the compiler, as it goes through, it grabs everything up and sorts it out. It doesn't seem to care where I put variables.
No,
Do
it
that.
goes through all the vars and then it goes through the
Yeah.
cons, the vars, the dats, the pubs and the prize.
Yeah, it's just that now these are global variables and could be
Right.
clobbered by somebody else.
Yep. Yeah, there's all kinds of things about where to cut the pie and where to make the divisions and how to make the box size most useful,
Yeah.
all kinds of trade-offs involved.
Yeah, of course. Yeah. And it's just, yeah, so it's one of the things where, well, this is why I do it like this, so that it's, you know, if it gets stuck up in the top with a big list of global variables, you know, to me, it just seems like it's easier to run into
Yeah, I agree.
if I keep it here. So this
You could even just say right above the, because long is the default, you could just put the var right above the pub and say var face comma direction.
I know, but I don't like that stylistically because it's just ambiguous.
Yeah, right.
So yeah, I mean, and I know this about myself. I write in the most obscenely obvious way possible. But then most of the code that I write is for other people. Although even for myself, I wouldn't use that style because I'm an idiot and I want to make sure that I can understand my own code. I know my eyes are looking down here. Here's what I should do is I should move the pictures of everybody at the top of the screen so my eyes are looking more towards the people. So I keep seeing Gavin show up on the screen. I'm excited to think what you and your students might do with a display like this, because I think it's a pretty neat tool.
This is very, very cool, John. Thank you for taking the time to work through all this. I just finally got it working. I'm using one of the what's it called enhanced displays.
Yeah,
but I
With the
finally got
black
it going.
PCB.
Yeah,
Oh.
I've got a 8x8 RGB LED matrix, but this is working fantastic. This is awesome.
Nice.
So, very cool.
Excellent.
So one of the biggest constraints I've had in trying to make things for my students and to create this kit with Parallax is cost, though. So
Yeah.
at about $50 a pop, this does add a huge bit
Yeah.
to the
Yeah.
thing. And I was actually chatting with Ken a little bit during this one-on-one, and the debug stuff that Chip has made is fantastic in and of itself for prototyping and testing. So it's actually in some ways much cooler than this because you have a much larger display, because every
Oh,
person
sure.
that's programming
Yeah.
Propeller has a huge display and also has a keyboard and mouse and stuff too. So I think that this is perfect for like embedded applications
Yes,
where it
yeah.
has to run independently. But I think we really should focus on the debug within the Propeller tool as being a really neat kind of HMI as well. So
Yeah.
that was.
Well,
But,
Mike, I've got, well, like I said, John is doing a product that he needed an HMI. My friend Rick is doing a thing. The laser tag company, we want to have a portable device so we can carry around and do lots of functionality with, and it made sense. So when you're untethered from the computer, this is a really nice device. I absolutely.
Yes. So in student projects, this is going to be fantastic. Many years ago, I used 40 Systems type displays and just banged my head against their interface stuff. So it's mostly we're just kind of taking pictures off an SD card and just kind of doing slideshows with them. But thank you for, again, taking the time to go through this. This is something we're going to use a lot from here on out. It's much less expensive than the 40 system stuff, and it's pretty easy to work with. So
it seems like, yeah, well, this is a case where I have, two of my good friends both needed to know about this. And so I bought one kind of on a whim, and let's see if I can get it to work. And ended up watching just an enormous number of YouTube videos that were useful-ish. And then I thought, all right, well, let's, as when I do my presentations, I do try to present generically. Now, we're all targeting the propeller, but I think an advanced Arduino program or any other processor could say, oh, okay, you're just taking a string and parsing it like that. I can do that in any language, and you could. There was a discussion on the forum. So somebody said, hey, could I do this with the propeller basic, from Eric's compilers? Absolutely. It's just serial data. That's what I like about it. It's just serial data, and serial data is easy, especially with the tools that we have now. So I hope that people will port this to other languages and put it to use, and then it'll inspire other kinds of devices.
So really, again, thank you for taking all the time to kind of parse through all the YouTube videos and stuff and all the stuff for Arduinos and put it into something that we can all use right away. So I've got hundreds of WS2811 LEDs on my Christmas tree right now. So I'm going to try to hook this up to that to get them all doing fancy
there you go.
patterns of the P2. So
nice. Yeah. It was very funny. Ken called a couple of weeks ago and he said, hey, can we do a thing? What do you want to do? And well, it's holiday time. Let's do that again. But I had this, and, and this, I mean, you're a professor. When you have to teach something, it really forces you to learn it. Now, I'm not saying I have this mastered. I don't, but for the utility and making it work within the kinds of projects I do, or my friend John or Rick does, I think I've got a pretty good grasp.
My PhD advisor used to say that his quote was, and it caused me a lot of stress throughout grad school, but he'd always say the best way to learn something is to teach it. Yeah. Because you really have to figure out where all the holes are, plug them in, and be able to explain it clearly.
Well, I thought, I don't know, you're doing your prep. Like for the last week, I've been, because I'm an actor, right? So I'm always in rehearsal mode. So I'm going through thinking about how I might present something. And then as I'm doing, I'm working through oh, doggone it, I found a better way to write this code. And it always worked that way when I was writing for Nuts and Bolts. As I was explaining the code in text, I would find I could write it more efficiently. So that it became an interesting filter.
That's exactly it. I found there's so much, the psychology is fascinating. Every year I teach about 100 students, and just these are all engineering students too, but even among them, they think about things entirely different ways. You have to come at it from different angles. So I liked what you did when you were explaining how you could have written that code more efficiently without the, if it equals this, then set to 0 with the end mask instead. So that's exactly the sort of stuff that I've had to contend with for years. So that's, again, one of the things I think I bring to the table in trying to create this new book with the P2 is that I can send it through all these filters and lay it out in a way that I think will help people to understand it. That's something that Andy Lindsay really has a genius for in terms of being able to step back and explain it clearly. And that's why I think the original What is a Microcontroller was so successful.
And my acting coach, he used to say, because every actors are human beings, right? And we all think differently. So there are lots of famous acting teachers. Again, we've all heard of the method and the Stanislavski method. And there are other acting approaches where my coach, where his genius was identifying the individual and saying, okay, this approach would work better for you. So he had a phrase, he had a poster up in his class that said, like, in acting, many great roads lead to Rome. And I approach that in programming too. You can accomplish the same thing externally through different code styles. And what for me, I think I shared this once before. My friend Matt, who is a very, very bright guy. He once said to me, he asked me for a driver, and I wrote it and I sent it to him, and he said, I don't understand how you think. And that really meant a lot. I mean, he was being complimentary, but what I want to do is present how I think, because I know when I look through Chip's code or anybody's code, because I'm often saying that I don't know how you think, but I'm looking for clues because it might trigger something in me. That's why I will often explain several different directions just to find whatever triggers or in a positive way, inspires people, think, oh, okay, I get that now, and get them to move forward. Nothing is more disheartening to me than having a person just be stuck. And, so my coach, who I have a painting over on the wall there, so I'm always thinking about him. He'd always say, so, if you look at good running backs, it's funny, he was an actor and a director and a writer, but he loved football. So everything in acting was a football analogy. And he would say, the greatest running backs, they hit the line and stop. He said that they just turn their feet and go another direction. They never stop. They might go laterally so they could go forward, but it was always constant motion. So I'm always looking for those things. And again, with the propeller, that I love so much is that we can, for example, we mentioned that efficiency thing. We could have run that through a little bit of code to determine which of those two segments ran fastest. And the propeller gives us the tools to do that. It's one of the things I really like about it. And I will often do in the when I'm coding something where I'm really worried about taking much time, I'll try different variations of code that give the same result to see which one ends up being the fastest. And sometimes I will accept 10 or 15 clock ticks. That's enough. That justifies doing that, as long as I have program space. But I think that's one of the really unique things about the propeller that the people outside our community, have yet to appreciate, and what it would do for them, making them better.
One of the things I've learned in writing code for the past 40 years in multiple languages is the ability to write code in a conceptual way, not writing it so it's geared to any specific device or language. But if you can learn to do that, you're way ahead of everything else. Yeah, and you probably did enough of that yourself, Johnny, to probably agree with that.
Yeah, I've done, because I worked in industry, and the nice thing was back then I had programmers working, on my teams. Because, for example, across the wall, I have a patent plaque for a sprinkler timer that I created at Toro. And, that was one of those. This was back in the mid 90s, and, the costs had to be down to here. And so that product used a 4-bit processor. And so the programmers, and talking with them, because I had done a little bit of programming at that point, and just understanding what they were doing was really fascinating. And one of the guys that I worked with at Toro for a long time is a really great guy named Jerry Mock. He programmed the, and I'm going to not remember the name of those spacecraft that have gone out of the solar system now.
Voyager 1 and 2?
Yeah, he wrote code for them. And,
wow.
And so, we would sit and talk. The great thing about Jerry, many great things, a wonderful programmer, super nice guy, and home brewer. So we would often enjoy we'd go to work at his house and have a nice beer and talk programming. And he taught me, stuff because he was writing code for missiles in the early days. And, taught me how to write code that was how we could analyze all the paths through a particular bit of code so that it always ran the same speed. So you could do timing things, even though you didn't have, there was no interrupts and you didn't have clean ways to do that. So I learned a lot from him. I love looking at other people's code. I will always ask people to share their code so that I can hopefully glean something from it.
Mm-hmm. There's a lot to be said from that. I agree.
Yeah,
that's another incentive to write good comments on every bit of code that you post, because people are learning from your code too. It's not just explaining, even explaining just general spin things in your code. For example, John, in one of the demos you showed it, I hadn't realized you could do set 2 variables at once with commas separating the 2 values. That was a neat trick that I hadn't thought of.
Yeah, that's new to spin too. I don't use it often, but I'm getting, there are times when it makes things nice and clean, and that's common in other languages. Now, I do a bit of Python programming, so I've done it there. And
all the students these days are going through Python, at least the engineering students. So that's become the standard. Again, that's the sort of stuff that, I think that there's been so much that's been developed on this chip over the years through the forums and stuff that, you kind of jumping in, it's hard to kind of catch up on all that until all the documentation's fully out there. But even once it is, everybody has their own style of how they're going to do it. So
Right. Yeah, well, there was a time too, so this will sound a tiny bit self-defensive, but initially when I wrote for Nuts and Bolts, they published my personal phone number, and I would occasionally get calls from people. And so I always wanted to make sure that, I obviously I don't mind talking to people. In fact, I quite enjoy it, but I wanted to make sure that I wasn't getting, I didn't deserve an angry call. And then, I grew up inside the Toro company. We were very teams based, and people were working together. And it's easy. Sadly, I think in now our new world of isolation, people say, "I'm going to do it my way." But again, once a program is compiled, only the target cares about it. But before then, it's for humans. And because of my aesthetic sense, I want it to look nice. I've said this many times. Again, work here in Hollywood. I've also written some screenplays. In Hollywood, the first thing they do, if I manage to get a script, say, to Steven Spielberg's company, he's not going to look at the script until several other people have. The first one is an obnoxious person called the reader, and they'll do a page flip, because they will look at it physically to see, does it look right? Because they make this is a very judgy place. And if your script doesn't look right, then they'll make the assumption you don't know what you're doing. There are lots of wonderful stories that never made it to the screen because somebody wouldn't follow formatting rules. So it's interesting. And I told a producer friend of mine this, that I love screenwriting and I love programming because they are both similar to me. They are structured styles that lead to an artistic result. That's my kind of take on it. And that's why I get very, very fussy about my my programming style, because again, these people here, they will chew you up and spin. They're not nice. Most people will just, give me, fun garbage, but these people are rude. They will tell you that you and your ancestors are all awful because you misspelled a word or you didn't format something correctly. Oh yeah, here's that. Oh, I don't know if I'm still sharing my screen, but if I am, that's what you were talking about. Yeah, there's lots of neat things in Spin 2. Also, is it called a ternary operator, Chip, or the question mark colon? I like.
It's where you use a question mark, and then if it's non-zero, it picks the value after that. Otherwise, it picks the value after the colon.
Yep.
After the first option.
Yeah, I like that. I use it a lot. It's a little more elegant than using an if then else.
Yeah, and you can nest them on the same line.
Yeah. In fact, I think I have it in the
So John, question mark.
in the controller. Yeah. Because it's in the oh, let's do that. It's in the flash. Yeah, here.
Right.
Now, the reason, because I know what you're thinking is, hey, you don't need to do that substate equals 0. Because substate could have been affected by another state, I'm just saying, hey, if it's 0, make it 1. If it's anything else, make it 0. That recorrects it.
Yeah.
So that was planning for, an abuse externally.
Right.
Yeah, so I like that. Yeah, Spin 2 is really, really nice. Now I don't want to wait 15 years for it, Chip, but I really now I want a propeller 0.5. I want a 16-pin propeller with 4 cogs and but the P2 language set.
Yeah, well,
Yeah,
we can make that. If we have our device sales up, we can talk to OnSemi and do that. We've got the recipe to make such a thing.
Yeah.
What were you going to say, Gavin?
I just second that. Really, I love the propeller too, but it's just a very large Swiss Army knife for taking on a lot of camping expeditions.
It is.
But
It's like
it's got
that big fat Swiss Army knife that was like an inch wide.
Yes.
but it's awesome for prototyping. So if you can only have one survival tool to take into the wilderness, this is the one. But it's but I think just for cost reasons to get something a scaled down version would be great. And if it's not a whole lot of work, just to scale it down.
No, we
But I
have the
understand the cost.
recipe. We would
Yep.
just have to get on Semi's approval for the project in the sense that they are kind of, they're not going to invest resources unless they know they're going to make it up on device sales, even though we'd be paying them. So if we can make that case, we can do stuff like that.
I think you could. I mean, again, you look at the proliferation of smaller microcontrollers. I mean, there are 6 and 8 pin tiny microcontrollers that people are using for very small discrete things. Now, again, and maybe I should have called it a 1.5 because I would love something in about the same size package as a P1 rather, but with P2 capabilities.
Yeah, we have like plans for 4 cog with less memory, 2 cog and even 1 cog versions.
Well, with might be tricky with a 1 cog version. Although with things that maybe Chip at one of these times, you should do a presentation. Although I hate telling anybody what they shouldn't do. I think it would benefit the community if you did a presentation on how to do interrupts, in the P. I think it's you and Evan and 3 or 4 other people understand that well. And the rest of us are standing on the sidewalk wondering what's going on.
Yeah, well, there's not that much to say about it, but yeah, I could do that.
But I think you've seen Gavin's presentations and my presentations, with sample working code that functionally does something real.
Right.
One of the things that is always difficult for me is samples that, demo codes that don't really do anything that's, measurable in humans. I mean, we can demo lines of code, but if they're not doing something meaningful, I think it has less of an impact.
As the guy speaking for who does the one who does the Visual Studio Code extensions, their documentation about how to do an extension and what each extension type does is, pardon my personal opinion, but is some of the worst example code, because every time I want to do an extension that does something specific, their example really doesn't do that, but shows the methods that you would use to do that. It's like, well, you're not showing me anything I need. But so I'm frustrated with example codes that don't.
Yeah,
amazing.
Yeah, I was just going to add, Diver Bob Sweeney asked a question about where's the floating point.
Yes.
So there, if you go to the spin 2 document, I put it in there. There wasn't a whole lot to say about it, but I put in all of the, let me go to the first one here. There's 24 instances of the word floating in that document. If you just look for those, it goes over how it works. Let's see.
Okay. I think I brought up the Spin 2 doc, and I noticed that the date update date hadn't changed at the beginning of the document, so I didn't search any further. I figured it hadn't been updated.
Oh yeah, let's see. What is the date? Oh, 9/22. Yeah, well, it's been updated since then.
Yeah, that's why I didn't go any further.
Well, maybe it hasn't. Let's see. Floating point math operators added to spin 2. Okay, so it's sort of in there in versions O and P. I'm not sure what version I'm on now. Let me go to our forums and see. There's that thread about Peanut. I'm not sure how far down it's fallen, but that's where I post new versions of Peanut. Let's see, where would it be?
Well, Chip, what version made it into 2.6 propeller tool? Because that's what
it would be N Now, wait a minute. Does that make sense? And hold on, what are we at in our documentation here?
Documentation's at P.
Yeah, so I'm not sure why that is. The code that I'm running right now that I just compiled, it says it says N. You know, I wonder if I didn't save that one file. Is like, you know, I modify it to output a new version, and then the N version is what's saved, because that's like a little module that doesn't, it changes when I update, but I must not have saved it.
Ah,
That's kind of lame. Let's see here. I got to get up to date here. Let me just do a quick check of my executables in my folder here. Yeah, NOPQ. So I'm all the way to Q. Let me see here. About unit, where is that thing? Yeah, it still says N. I wonder, I must not have saved it, but I don't know how it would get that far behind. So the next
Yeah,
is
the
going to be R.
okay. Yeah, the link from the Parallax website is version 35P for the spin language doc.
Okay. Yeah, and the Q, I think I fixed something. Let me see here. Let me see if I can find latest peanut. I think that's the name of the thread. And just look at the revision history real quick. Okay, is it searching? What's it doing? Well, it's not giving me any indication it's finding anything, so. Okay, let me just scan down here.
Okay, so I wouldn't be the only other one with problems then.
Oh, here we go. Wait, here we go. Latest version. Okay, it took a while. So let me go to the top of this thread. Yeah, so N, we added sprites. O, I added floating point. P, I fixed a compile time bug in F square root. Okay, that was the floating point square root function in spin2. And then in 35Q, I increased the main symbol table from 64 KB to 256.
And then the other tables as well.
Yeah, so Q went, yes. So Q went into what is now the new propeller tool.
Okay.
So I need to update that document. The, you know, I hope I don't have a couple of these things. I shouldn't. I've only worked on one, but does anyone know when at Parallax, not that you guys should know this, but when they put a link, or they have this file I've always worked on, they just link to my copy, right? Or do they like distill something out of that and then post that as the version?
That was just the Google Docs. I don't know.
Yeah, that's what I hope. PQR. So I'll add a few things to this when we get off the call, and then I'll update it. But yeah, I don't know. It kind of concerns me though that my little about unit in Pascal is saying, well, now it says R, but it was saying something else. Just save everything here. So Bob, if you look through that stuff, it's all in there. There's not a whole lot to say about it. I kind of just amended everything that was kind of to do with numbers and how things are handled, and just put it in that way. I don't know if there's like a real floating point section in the document.
Yeah.
Oh, look though, let me see here.
I was just looking for a link that said, here's all the new commands.
Oh, I see. Yeah.
And routines.
Okay. Just search for floating and you'll find everything, or just search for float. And because I'm seeing them now, I installed
in the
them
spin2?
in the spin2 document. Yeah.
I think most of it, you just append a period to the math operation.
Yes. Yeah. That's how a lot of stuff works.
Yeah, that's what it looked like, but you know, I always like to have docs.
Yep. if you do, yeah, just look for float or floating and it'll take you sequentially to every mention of that and you can see what's been added.
Yeah, I'm going to try to, now that we have floating point built into Spin 2, that little BME 280, I think it is, or 680, that environmental sensor. I'm going to give that a try again because I was able to get the I2C stuff working and read all the raw values out of it. But all of this is a case, I think we talked about this before, Stephen, it is really bad documentation. They don't tell you what any of the formulas mean. They just say, here's the code, use it and be happy. And it's really, everything's in C with floating point. They have some generic stuff that will use integers, but they have to be 64-bit integers. So it's just a bit of a mess. Since I can talk to the chip and read all the raw values and do some of the simpler things, but some of the complex stuff needs floating point. So it'll be fun to go back and see if that'll work now. That'll give a test. There's, and forgive me, because I'm reading, since we're, in chat mode, Nicholas Montoya was asking about interrupts. Nicholas, if you're there, can you explain what you're asking for? So, because Chip could probably answer that better than I or anyone else.
Yeah, I was just wondering in regards to just interrupts, if you wanted to do, I guess, multiple interrupts, let's say one for like every 1 millisecond, one for every 3 milliseconds, if it would be good just to have, like, should you just use one cog to kind of just keep count, and then you just have flags, so when it hits this number, okay, sets a flag, and you just do that for every interrupt you need? Or is there a way to do it built in timer to set flags?
Yeah, you could do it that way. I mean, you could simply pull the 64-bit main timer, right, and get a 64-bit value and then just do comparisons to that. Because unless you want to be alerted when something happens and then do something when something happens, you could just handle it that way, which is kind of like what the get milliseconds does and get microseconds. Those operations get the milliseconds or microseconds from start. And there might even be a get seconds. Do you remember, John?
There is. Yeah, there is. There's a get seconds too.
Yeah. So if you're running your code and worried about like how far have we progressed, what time is it, you can use those to figure out if you've hit like a new seconds boundary or milliseconds boundary.
Okay.
And then you won't have.
Nicholas, if you're doing, milliseconds oriented stuff, which is fairly coarse, I wrote a timer object here. Let me compile this that will use those features that Chip was just talking about. So you can see, here, I don't know if my screen's still showing, but start is the same, it's grabbing a sync point. The neat thing about the P2 is that you can have pointers to methods. So this particular object allows you to set a task that is one of the methods from your project and run it every whatever number of milliseconds. So the only thing that you have to do though, because you have to have something that is keeping up with the time. So if you look in the main code, there is this timer update thing. So that goes through and processes everything, but it will allow you then to, so I think here I have, so see here, I'm setting a task. So every 100 milliseconds, I'm running this update RTC method. So for slowish kind of things, this might be useful.
So you basically created like an RTOS where you can pass.
Yeah, a really simplistic, very simplistic one. Yeah, so this timer object has the ability to take a pointer to a method and then the amount of time that is required to run it. And so it will, in fact, I think this program, I ran this last night. I was checking to see if this was, yes. So it's doing this all using that timer thing and not, so nothing happens until it needs to. So it is a very simplistic thing, but I tend to write simple code. This allows me to,
That's nice.
so you can see this timer expired. This real-time clock thing is being updated every 100 milliseconds and then displaying whenever the seconds changes.
Okay.
But that was, so the only rub here is just like in my, my demo today where I had that state machine that's just running very fast all the time and checking to see if there's a change. You do the same kind of thing here. You can see in this repeat loop, there's no delays in here. It's just updating it's running this update method, which goes through and grabs the current time, does the comparisons as Chip was just talking about, and then it'll, this now variable returns, how many milliseconds have elapsed, I think. And then this is if there is a timer that is running. If you've set a countdown timer in there, this will, show you that. So this might be helpful for very simple things, because you'll see that here's that update RTC method, which is just doing a really simplistic real-time clock register thing. It's not being called from this loop. It's being connected to that timer here. And again, this is all spin code, so it's very, very easy.
Nicholas, what were you trying to accomplish with the interrupts? You trying to model something or what?
I was just I'm in the middle of transitioning to the propeller. I just want to just understand more because I just graduated college and university, and we've just been using like single core processors, and
Right.
especially doing like RTOS stuff. It's like it's such a mess and things deadlock and stuff. So I was wondering, okay, there's got to be a better way to do all this. And then I came
That's
across
what the
this.
P1 brought to the table, was that with multiple parallel processors, you don't need interrupts if you just have
Yeah,
a
it
separate
seemed a lot
cog doing it. So,
simpler.
Yeah.
start by thinking about it that way, because that just totally changes the way you look at parallel processing and interrupts. But then after you've filled up all 8 cogs with stuff, and then you need to do other stuff, then you could use the built-in interrupts that the P2 offers.
Yeah, and this
That's-
is
go
not
ahead.
using interrupts. This is using delta timing. So in the great thing about the propeller, as you're learning, Nicholas, is that we have these system counters that are running very fast, and we can get nice granularity out of those. Now with the P2, because for humanish things, I asked Chip for that get MS because I don't do a lot of Arduino programming, but one of the features I do like about the Arduino is a millis function.
Yeah.
And I wanted something that was like that. That's what get MS does, exactly that. It's the same thing. And it's very useful.
Another way to think about this too, from another perspective, Nicholas, Gavin brought it up beautifully. Reshape your thinking to move away from interrupts. There still is asynchronous synchronization that you want to do. If you're modeling data flow, for instance, the producers and consumers operate at different rates. And so now you have to have a way for the consumers to sit and wait for something to be produced and allow the producers to produce faster than being consumed. And so in this case, queuing is a great way to handle handoffs between the different cogs. And so now if you want to go true data flow, I did many years ago with a P1, I did a CAN controller, and you have USB commands coming in and data going back out USB, but then packets being generated and packets being seen by the 2515 chip, I think it is, if I remember correctly, the MCP,
Yeah.
the CAN interface chip. And so I ended up having to deal with lots of different data rates. And so I just ended up queuing between them and handling them first come, first serve off the queues, and therefore didn't need interrupts, right? I just pull the queues and the task just waits for the queue to be serviced. And now we have new mechanisms. Chip, I think, added semaphores operational. Is that the right term, Chip?
For those
To the
locks?
locks, yes, to the P2. And so now you can actually literally stall the core hanging on the locks for the queue processing. So that gets even more efficient rather than just sitting there running testing. So there's some interesting things you can do with data flow models to keep everything running and clean in an 8-core processor.
That's really neat. And do you guys know if there's like a way to enter like a sleep mode for power consumption savings for the propeller?
Well, the best thing to do is just turn the clock way down, and then it will take way less power because everything's kind of proportional to the clock frequency. But I mean, when
That
you
makes
turn,
sense.
when you run more cogs, of course, it takes more power, but the biggest thing you can do is just cut the clock frequency down, maybe use the internal, there's an internal 20 kilohertz clock
Oh, right,
that you can select, which is, I mean, the whole chip will take, oh, we measured it once. Was it like 42 microamps or something? It was pretty low.
Now, Chip, can this be done at runtime so we decide that we want to just idle and pull something slowly?
Yeah,
Okay.
That's nice.
yeah.
But I think, Chip, you said because we have interrupts in the P2 now, we don't go into an automatic low power mode with any of the wait commands. Like in the P1, if you're doing a wait count or a wait PNE or wait PEQ, any of those things, that puts the processor into low power mode as well, right?
Yeah, and that just kind of happened. It just turned out that way. It wasn't really
Oh.
designed to do that. It just
Oh,
sort of worked like that. And
Yeah.
that's kind of how the new chip is. It just sort of, if there's less stuff toggling, there's less power being consumed.
Right, sure.
On one thing I noticed would look nice, because it was a problem I made a PCB with like an STM processor, and it's very finicky. You have to make sure the traces go to the right ports, unless you get messed up if you swap the I2C pins or something. But with this processor, it looks like all pins are treated equally, at least with the smart
Yes.
pins. So it
Yeah.
doesn't matter how
Yeah.
you hook it up.
Yes,
Yeah,
and
they
actually,
don't-
in that sense, it very nicely affects your layouts because you can now move external parts around and connect.
Yeah,
to the
that's so
closest
nice
thing
now.
that you-
And the only pins that you need to concern yourself, Nicholas, are these, because the 62 and 63 are used for the serial programming interface.
Okay.
And then these are the flash interface pins.
Yeah, and they're the same pins as anywhere else. It's just the ROM, the boot ROM uses those.
Uses those, right? Yeah.
Okay, that makes sense. That's not bad. And the SD card.
But
is
after startup, you do whatever you want with them though.
You can, yeah. I'm of the camp that says don't do anything with them, leave them alone. But yeah, you notice here, so these say SF that's for serial flash, and these say SD, that's for the SD card. You'll notice they're the same other than the top two pins. I think this was Peter Kaki's doing, he suggested, which I kind of think, it just seems a little janky to save one pin, but if it works, it works. So there it is. Because Chip, on the new P2 Edge boards, is the SD card connected to these pins the same as where it was on the demo board?
Wait, you mean on the new, on these things here, these?
On the new Edge, yes. Is the SD card connected to the same pins?
Yes, of course, yeah.
Flash.
Yeah, they're just 56 and 57 are now the clock and the chip select on this one board, and you probably can't see that, but it has 4.
That's the one with the extra RAM, right?
Yeah, this has the extra
Yeah.
RAM.
Yeah. This is this is for the standard. And I found that the buffers that are on those boards kind of mess with some circuitry. So these are in my way of doing things, just leave these alone. Let them do this stuff and nothing else. That's why I have these as my fixed IO pins, and then my application IO pins are there, so just my style of doing things so I don't run into any headaches.
Which might be, if we remix this chip, maybe just have a couple just digital pins, not smart pins, for kind of keeping track of the startup, just to save money on the layout.
What do you mean, Gavin?
Well, I mean, the P1 all had digital pins, no smart pins. The smart pins each take up a big chunk of the
I
silicon
see
real
what you're
estate.
saying,
So just have, or even like a 64 pin chip, but the first 32 are smart pins, and the upper
Or
B
just
ones
tri-state.
or just tri-state digital pins that
Yeah,
work like the P1.
we kind of at one point planned that for the derivatives, but in the end they figured, just make them all smart pins because they take up so much perimeter around the die. So they kind of determine like how big the frame is determines how much junk you can put in the middle. So like with 32 pins, that's going to give us like 1/4 the area inside, right? So that could roughly reduce to like, what would that be? 2 cogs, 128K of RAM. That's what would wind up fitting. But yeah, anyway, we'll see if we ever get there.
For the record, the Propeller Mini Propeller One Mini was my favorite kind of package. It just I never really needed more than 19 or so pins, and it was quick to plug and play and small and easy. So for a lot of the types of applications we do as engineering student projects, that's kind of a really good size. So I mean, I love the P2 again. If I only have one survival pocket knife to take into the wilderness, this is the one to do it all. But it's the cost is, I think, prohibitive for lots of little projects.
It is, yeah. Nicholas, without making a circuit board for the P2, you've got to carefully route the power and ground and some rings. If you look at our artwork for our boards, which we publish.
Yeah, it's available.
Yeah, I saw a reference design.
You can see these days, working with Michael on this, like you probably can't see this very well, but this is the board. I mean, this circuit board is almost getting to be like chip design where you're like pushing polygons around instead of wires exactly, because we always want to have, enough metal to dissipate as much heat as possible. And there's just all kinds of vias. I mean, I think this is a 4 layer, but we're redoing it into a 6 to get a couple more heat dissipation layers. But it's kind of like more like chip design than it is traditional circuit board design. In the old days, it used to be, here's a big dip chip and you run a trace out to somewhere else. And now it's more about shapes than it is wires. Especially when you get into like these little switching power supplies, just a lot of stuff going on there. And their parts are almost on top of each other.
Chip, have you seen those Raspberry Pi modules that have those, I don't know what they call the connectors, where they stack on top of the board versus coming in from an edge connector?
Like a daughter board?
Yeah, but they have I'll have to look it up. I think they call them
Castellations.
The compute modules. No, they're not I'm talking about the castellated edges. I'll send you a link. But I thought, man, I would really like that for the P2, so I could just pop a P2 module on the board without having the giant socket and all of that. And
are they using DIMM?
Look at the Raspberry Pi compute modules, the newer.
I think it's using a DIMM connector, like for memory.
No, not that one. They have it. Let me see if I can find it.
Here's another one. Yeah, but some kind of edge card.
All those things, yeah.
No, it's a press down connector.
Yeah.
Okay.
Yeah, pick the middle picture there. There you go.
Yeah.
Oh, yeah. Okay.
So it looks like that from the top, and then it has these connectors on the bottom.
Right.
And so only a single one can be mounted, but it's much thinner solution.
Yeah.
Yeah. Okay. I've almost got the mouse feedback working.
Nice.
And I'm really close.
Are you talking about through the debug chip? I assume that was.
Yeah.
Gavin got very happy with that.
Yeah, that would be amazing to have two-way communication through debug.
Yes. Well, yeah, the debugger is all written that goes in the P2, but I have to make the debugger like window for the PC side, which is I don't know. I just haven't done it yet, but this is like kind of a side function of all that interactivity, right? I'm going to share my screen here.
Go ahead. Here, I'll stop mine.
The others. Okay, yeah, all right, so I want this one, I think. There we go. So here's that sprite thing. So I just, it looks like this, but it's not going to work quite, well, I guess it'll work like this, but but what happens when I run it, look, let's see, F10. Okay, I don't know if you can see this. Can you see the black debug window over the top of
Yes.
my window?
Just showed up.
But not a
Okay.
graphic one, just the default one.
Yeah. Okay, you see it says my plot, because this mouse pose thing compiled into a command which is invisible. So what I have to do is when I output, or when I wait for the long to come in that represents the mouse position, I need to have the P2 side spit out maybe the word mouse pose so it can become a keyword for all of the debug windows. But what it's doing, the reason it just hung there instead of loop, it's waiting for a long to come in right now, and it's going to write it to wherever this thing points to, right? So that can be if you're in PASM mode, that can be a register. If you're in spin 2, then you've got to put in there some kind of pointer to say where you want this 32 bits to go. And the 32 bits, it's like 14 of those bits are going to be the X, 14 will be the Y, and then 1 bit will be the left button, 1 bit will be the right button. And also, maybe if the coordinates are negative, I'll signal, that's how I can signal off of window, so you know whether it's in your window or not. But when it hits this thing during debug, it actually, that cog just stops and waits for something to come in. So the particular debug window that had this message is going to see this keyword come in, and it's going to go, oh, okay, we've got to look and figure out, come up with this 32-bit value to send over the serial port the other direction, just as raw binary data. And then what lands in I, you will have to parse. I mean, I could do it so we have like, well, I want the X in this variable and the Y in that variable, but I might make it that way. But essentially it comes down to something like this, where you have to say where you want the data to land. And at that point, the PC will come up with that value, send it across, and then this thing gets unhooked, so it's no longer stuck, and it will continue on. So I don't know, it might be an hour away from having it work. I've just got to write this last bit of it.
And
I still don't understand why you're always thinking about blocking in that case. Because if you call into the PC and ask for the current mouse position and current mouse pointer clicks, I mean, you can just take the thing which Delphi gives you, mouse position XY, it's kind of a block of information. You send it back. You don't care if he currently clicked it or not. You just send the current state
well,
back. Same with keyboard. You can just give the current keyboard state back.
It's going to turn around really quick and send the data, but the thing is,
but it doesn't need to wait.
The trouble is,
well, now that you need to wait and resend the command and then unlock everything again. Just call in, give me the actual data, get out again. And either you have a key or you don't.
well, the trouble is tying the window to the message. If a certain window, if debug data that's like in this case was saying my plot, if the my plot window wants to know what the mouse is, where it's at, that data has to go back to that debug routine, because you can't give just general data to anyone because they don't know the context or who it's for.
Yeah, but you are asking out of that my plot, asking the PC what is the current mouse position, and then you subtract the position of the debug window, and you have negative values for outside, and yeah, I don't know, clip it. But basically, you can just return the current mouse position. You don't have to wait on anything.
Well, the trouble is we have the pointer to where the data has to be written. That's perishable, right? We have to tie, because when that data comes in, it has to be written to somewhere, either in a register of a cog or to a hub long. And so while we know where that data has to go, and we also know the context of the request, we can return sensible information about where in that particular debug window is the mouse and what's the state of the buttons. Otherwise, it's just like that thing would have to know where its window is on the PC and then do a subtraction, right, to figure out, and then know the bounds of it. It has to know too many things and it gets weird. So it's going to cause a little bit of a stall. But when we get this stuff all put onto a separate thread in the PC, the latency is going to drop way down, and I don't think it's going to be that noticeable.
Right.
And again, whenever you're dealing with the human, you're dealing in milliseconds anyways,
Yeah.
just because that's what it takes to hit a key or move a mouse. So I don't think that's a big deal at all. But that's great that you're getting close. Yeah.
Yeah. It's going to be.
And I would think that the keyboard would be a lot simpler to start with. So I don't know why the mouse is first in
I
line.
know how I can make any number of these things and, contextualize them however, but yeah, we could do, the mouse is the first thing I thought of because, for a plot window, it'd be cool to be able to go, give me the mouse position and whether it's in the window or not. And if it is, what is the position? And then what are the button states? And with that information, you could actually do an entire GUI.
Again, I think this debug system you've created, Chip, is amazing. It really separates the propeller from the pack, their Arduinos and other things. And it's the perfect HMI for doing, testing and prototyping. So this is really a powerful tool you've given us. So we just need to put the icing on the cake, and this is really going to be amazing. So again, one of the things I want to do specifically for the experiments I'm working on is be able to, type in floating point values and stuff through the debug, and then have it register that, and then be able to use all these new functions you've created for us. So, but let's say you're tuning a PID system or something. You want to be able to adjust the gains on the fly while you've got some motor or something moving. And so the ability to just go back and forth would be really helpful. And I've been able to do it with the PST, the paradox serial terminal, but I think that's a little, janky compared to what we've got with this fancy debug stuff, particularly now that we've got sprite capability and stuff to be able to really add graphics, so I really think this is a neat tool, and it's almost there. It's so close.
And I think what you're going to find, I think what you're alluding to, Chip, is that once you have the transport mechanism working, going from mouse and then adding keyboard is going to be a tiny change.
Or even a file system.
Right.
Yeah.
So, yeah, but just.
Oh, Michael agrees with that.
Yeah, I mean, you are now sending out a debug command from cog to my plot window. And you should send on the back way from my plot window to cog 0. I mean, it's a message thing. You just send the message.
Right.
You ask for the message and then you shut down and then you check for the message later on. Or react on P2 side, react on the message. And the message can be, we have no key, we have key A pressed. Or mouse position is inside of the window. Delphi can calculate the window frame and whatever. You don't need to do that on the P2.
Well, the trouble is it's like a line of people getting on a bus or something, and some guy goes, "Hey, what time is it?" And then someone goes to find out, and then 3 people later, he turns around and says to some new guy, "Here's the time," and that guy goes, "What are you telling me for?"
Yeah, now the other thing is what I think what also would be very nice to have the color of the pixel below the current mouse position.
Ooh, yeah, that's awesome for video games and stuff.
That
yes.
also should be returned by a mouse event. X, Y, the buttons, you have, there is that standard format in with kind of button state for 3 buttons, scroll bar state. It's kind of a couple of bytes or long words, I don't know, longs. And you just return the whole package and good. current mouse position state. And if you miss something, then you have to ask more often in debug. But you send the message and then you wait if some return comes next round. Or even, I mean, it should be fast enough to just send that message and send the answer back.
Yeah.
And same goes with keyboard, key state. There's also that standard key state thing working in Linux and Windows, where it says caps lock is pressed and then the key code and whatever. You just return that. We have a keyboard driver already who can decode that bullshit. And
Yeah,
we
you
have,
know,
we have an input
keyboard-
device then.
Yeah, Stephen?
I just have to run real quick. Good seeing
Okay.
you all. Sorry to interrupt.
All right, we'll see you later.
All right.
Bye. You know, the keyboard is kind of, I mean, this thing can happen in a loop so quickly that kind of like saying what was the last thing pressed can create all kinds of headaches. You know, can you imagine this? If you show up and you get like data that's out of time, it's almost better just to give them real-time positional information and let them worry about, is it a single click or a double click, anything like that. Because if you try to handle that, you start to wind up with timing phase issues that are just it'll create those kinds of bugs that you have no control over and are horrendous and you can't get around. We've all seen those kind of things, right? Like if we just give them the bottom level information, they can do whatever they want with it. But we need to give them like, I need to see if it's possible to get like the instantaneous state of the keyboard and, you know, the mouse position and the button positions and the maybe the scroll wheel.
And if one P2 cog is kind of waiting for a key press, then you should wait for a key press and ask debug command, give me the current state. Do we have a key press? He can loop, he is waiting for a key. He's sitting in a menu.
Yeah.
So the cog is kind of constantly asking the PC, but the PC just needs to remove the current state, nothing more. And same with mouse. Yeah, mouse, I would like the PC.
You're saying it's okay to just relay the current state?
Yeah.
Like the instantaneous state of the
Instantaneous.
Yeah, I think so too.
Ask the question and send it back. And same with mouse position and mouse buttons. But position, I think it would be nice if the PC side kind of blocks the window. So if the mouse is outside of the window, then return a -1.
Well, we give a -1 value or something, and that means don't use it. But we've all seen these kind of applications where someone, you know, was trying to give distilled information, and there were always these timing phase errors. So the net result is that someone goes, "Wait, let me do it. You have to do it a certain way," and everyone's like, "Why?" Because they know that if you like try to press events or push events too quickly, things get out of sync and they don't register right. So where you click doesn't register. We've all seen like old websites that had these kinds of issues, right?
Yeah, but Gavin is completely right. We are talking about user actions. That is not picoseconds.
It's milliseconds.
It's not milliseconds. Well, maybe milliseconds, but I don't even think that. So
right.
You don't need to do fast loops and I mean, just ask the current position and give it back. And the P2 side needs to check, has it changed or not? I'm waiting for a key. Yeah.
And while it's really cool that you have multiple processors, multiple cogs, being able to manipulate the exact same debug windows, which hadn't occurred to me that you'd gone through all that trouble to begin with a couple months ago when we first discussed it.
It just kind of wound up in there.
Well, it's very elegant, but it's not necessary per se. I mean, if it's only one cog that can deal with the two-way communication, and the other ones are, you know, just stuck with one-way communication, that's acceptable too. It doesn't have to be miraculous where the bus driver talks to every single passenger and understands what.
Well, you know, practically that's just going to that's how you're going to probably write your code, that you're going to have one cog updating some window, but you could have more than one. But as long as we keep the exchanges kind of atomic, you know, where like some instance at some point in time from some cog is asking for like the mouse position, he gets it. you know?
Well, even on the
It's-
P1, whenever we wanted to use the parallax serial terminal, we always had to dedicate a cog to doing the full duplex serial. So I mean, if you have to dedicate a cog just to be able to do the two-way communication, that's also not the end of the world.
Right, yeah. Yeah, it all still is peer-to-peer, even for the single step debugging. There's no need for any background process.
Yep. But all I'm saying is if that's what we have to do just to get something working, that's not a big compromise.
Yeah, I hear you.
I had a
And
question
we need
regarding.
a debug object which kind of provides a serial TX, serial RX that we can connect those send and receive commands to. And we can use that debug line also to put out the terminal window and get terminal back.
You're right. What were you saying, Nicholas?
Yeah, I had a question. So you're using Spin2, so that's a separate IDE, right? Does that one allow you to put breakpoints and stuff like that for debugging? Was that your?
That's what I'm working on next. I've got it. That little program I was showing you, that's my little personal test, like development test bed. When everything gets done and everything is working to some point, then I'll send it to Jeff and then he'll put it into the propeller tool.
Oh, nice.
The code just
Okay.
gets included in there, but this is like a simpler context that I work in because I know it. And I wrote the editor and everything, so I know how everything works. So it's easy for me to work in. Whereas the propeller tool is a much larger thing with a bigger build time. And, you know, this builds in a second or two or so.
Nice. Okay. And I was wondering, so regarding a multi-core processors, because I don't know, it's just crazy. I haven't heard of this in college or anything. Are there a lot of these on the market? Like, are other companies doing this? Because this is the first time I hear of a multi-core.
Well, you know, it's funny that I know there are multi-core chips, but the thing is, well, the way this got designed a long time ago by us is we figured, okay, let's just imagine like picture like a single threaded processor, right? You're going to do all this stuff and you're going to split time up and then you wind up with jitter and you wind up with all kinds of like possibly lock problems and all these weird things going on. Well, what if you just had like separate processors that could each run only the little program that they need to do their job? Then you can like start thinking really differently. You know, you don't have to think so statefully anymore. You think now, well, this program is just going to loop and he's just going to do this. This other guy is going to go do this. And then, so that's kind of like part of the idea. And then the big other part is what connects it together are simply global symbolic variables that they can all access anytime without any locks or anything. So for a lot of things, like if you have a consumer and a producer, the consumer or the producer just puts out, say, data into a circular buffer and updates the head pointer, right? And then the consumer only reads the head pointer, and then he maintains his own tail pointer. And then he can also read the buffer. You know, so you can come up with all these like really simple, like contractual ways of, you know, exchanging data and without needing to get into a lot of stateful things that get complex when you're dealing with one long program with all kinds of substates possible.
And Nicholas, if you downloaded the project codes, you know, from today, in all of those projects, there's an object, there's a child object called JM full duplex serial, which is actually an extension of Chip's original full duplex serial from the P1 ages ago. But if you look at that, it does exactly what Chip was just speaking about. The full duplex serial, so it's interesting because it's a back and forth thing. The main cog, the parent process, sets up a couple of smart pins to handle the UART capabilities of the pins, and then it launches a cog, and all that cog does is looks at the receive pin to see if something has come in, and if it has, then it puts it into a shared hub buffer and updates the head pointer as Chip was talking about. And then it will look at the transmit buffer also in the head, and if there's something in the hub rather, and if there's something there, it will grab a byte and transmit it and then update the tail pointer for there. So that's a thing where they're working very smoothly together. It's much easier to do with the P2 because the smart pins are handling the UART capabilities. In the P1, we had to bit bang the serial code. Right now with a smart pin, it does that. So that's, you know, if you look at any of the P1 projects that you can get a number of them on the forums, you'll see that same, you'll see full duplex serial there. And if you look, the assembly code in full duplex serial is in the P1 is much more involved because we have to bit bang the serial. And in that particular case, when we're trying to transmit and receive at the same time, then we have to do this, what Chip calls ping pong multitasking between elements. So it gets really involved in the P1. The P2, it's a dream. And I structured JM full duplex serial for the P2 so that it would be very easy to add as many ports as you wanted, because the smart pin is doing all the hard work. In fact, Ray Roddick, a guy from Australia, he's done a 16 port version of my code. And that's, you know, it's an easy thing to do because of the smart pins handling the UART load.
So the smart pins are handling it. You just, I guess you mean you just fill up the buffer and then it will send the buffer.
Well,
to
the
that
smart pins,
TX pin.
Smart pins have a 1 byte buffer. So what we do, the full transmit and receive buffers, those are shared in the hub. So when the object, the JM full duplex serial defines those, and it passes the address, the hub address of those variables, of those arrays rather, into the background, makes that available so that the other processor knows where to write to. That's a key thing with the propeller. Either of them is your shared data is going to be in the hub. So if you want 2 cogs to be able to share data, they just have to know where that data is. So you're going to pass a pointer to whatever you're doing.
And I guess it's already made, so there's no conflicts between read and write between the 2 cogs. I guess
Right.
there's like a lock there.
Yeah, they're all atomic operations. So as long
Yeah.
as one guy writes and another guy reads, there's never any kind of conflict.
Oh, okay. Okay.
Well, but in either case, you can only have 1 cog write at a given time to the same memory location. Because a P2, technically, you could have all 8 cogs writing, but they couldn't write to the same memory address.
Yeah, because then they'll start overwriting each other's
Yeah.
data. But
Yeah.
you could do something if you had all 8 cogs, you have, 8 locations. Cog 0 writes to this one, cog 1 writes to this one, then anybody could quickly read in all 8 of them and just look through them and see what there is.
Yeah, but
All kinds of ways to do it.
in case that there is the conflict of writing, you have those semaphores or locks
Yes.
in 1 and P2. I hadn't actually never, I mean, I played around with them, but I found them pretty seldom used. They are not really needed.
Well, I would counter that, Michael. I would say that if you have a case where you have a cog that needs to write several values before any of them gets used by the receiver, then that's where the locks are useful. As you say, hey, don't touch those values. Let me write them all for whatever number of cycles that takes. And then you release that lock. And now that block of values is available to whomever needs them. That way you don't have a conflict of an old reading and a new reading in the same block, causing some issue.
Exactly. But
Yeah,
that's
I don't use them often.
But
Yeah,
long
you can use
operations
the
are
locks
atomic anyway.
for any resource. Like the debugger uses lock 15, it's kind of fixed. It uses lock 15 to determine who gets to own the transmit and receive serial pins and the save buffer in the upper RAM for interrupts, right? Because those are the resources that are needed to process an interrupt that you couldn't replicate all over. The transmission pins and the big buffer to save off everything that was in the cog. So those have to be used exclusively by 1 cog at a time. So a lock is used to allow one cog to grab it, use it, and then he lets that lock go. Someone else can grab it. He'll use that for a while. And then while he's got it, nobody else can get it. So that's
I'm still,
go ahead.
I'm still a little bit confused about, I understood how the propeller 1 worked. It was just round robin, cog 0 gets the access hub, then cog 1, then cog 2. So that only one long could go back and forth each time. but I haven't totally wrapped my head around this egg beater system. So let's say cog 0 and cog 1 are both trying to write to the exact same address in the hub RAM. How is it physically impossible for them not to overlap and crash?
Well, yeah, I mean, obviously one guy can be writing and another guy can be one clock behind him overwriting, right?
Okay.
So you have
So
to come up with some way to just determine who gets to write it. But normally, you know, okay, the idea of writing over the same locations, that's usually not something that you would need. I mean, you'd probably design your way around needing a lock for something like that. But when you have maybe like collections of resources that are going to be used, like, you know, there's only one, you know, set of built-in pins that everything talks over. It's pin 63 and pin 62, right? So that's a resource that, you know, has to be divided in time for sure. You can't just have other buffers. You only have those two pins to talk over. You know, so you got to determine, you got to have a way of allowing like one cog to own those things at a time. And then when he's done, he lets that lock go. Someone else is in a loop waiting for it. And he goes, oh, I got it now. I can use those two pins. Then when he's done, he'll reset those pins and then he'll release that lock and then somebody else can get it and take over that resource. It's like a bathroom. It's like a bathroom on an airplane. You know, you can have people lined up outside, but only one's going in at a time. And then when he comes out, the next guy can go in.
But I thought that the egg beater was all 8 cogs are writing at the same time, but then they're staggered. So is it like every 8th memory location? Is
Yeah,
how they
like,
get
if you're cog 0 and I'm cog 1, you could be writing n and then n plus 1 and then n plus 2. And in that same time frame, I could be writing n plus 1, n plus 2, n plus 3, because I'm like one step ahead of you in the cog teeth, right? But maybe you've got these things conflated that shouldn't be, like the matter of the egg beater and then the locks. You know, they're totally different things. You could use a lock to, you know, determine who gets to control some chunk of memory, but you would never probably have anything anyway where you're worried about those like clock to clock. The lock is for more of a macro type of.
Yeah, I understand semaphores and locks. That makes sense. And I agree with Michael that I don't think I'll ever really need to use them. But in terms of just, I understand P1 uses this round robin where there was just one, you know, cog gets access at a time, but I don't quite understand how the egg beater works that allows all the cogs to have access, but have it staggered.
Okay, let's see here. Let me see if I can pull on the parallax side. Where is it here? I believe
You make
there's
it sound like it's more pipeline now.
Okay, yeah, look at this. If I can share again, let's see. I want to go to, let me make this thing really small so we can see this one bit of importance. Hold on.
Basically, the RAM got split into 8 parts, and those 8 parts, each cog switches from one part to the next, and the other behind it switches, so they can always access. They don't have to have that wait for the full round.
So is it if you've got, let's say you're starting at address 100, then 100 cog 0 can access 100, cog 1 can access 101, cog 2 can access 102 at the same time.
And if you do it ascending, then you can read every clock.
Did you see the little graphic?
If you do it the other way around, then you have to wait the complete round. But if you read 100, 101, 102, 103, then you basically are in that loop.
Well, do you guys see the little animation?
Bad. You have kind of one miss all the time, like in the P1 original. But if you read in that direction, it works with one result per RD long.
Can you see the automation?
Yes.
or the what is it called? Animation. Okay.
And just to be clear, did you make this in the debug functionality? Yes, this was done with the debug function in the
plot window.
That's
the plot
amazing.
window. Okay, so this is P1. See that? The RAM goes cog 5, what do you want? Cog 6, what do you want? Cog 7, what do you want? right? See how it goes like that? So, but look at how P2 is. It's like each of those little bubbles, those purple bubbles that say 0, 1, 2, 3, those are like 64K RAMs that are 32 bits wide. And now here's the P1. See the P1, the RAM muxes between cog 0, then cog 1, then cog 2, whereas those RAMs are all like busted into little pieces on the P2, and they all, every clock, a cog gets a unique RAM.
Okay, but that's where I get really confused. So if it's 64K in each one of those little bubbles, each segment of the 512 RAM,
Right.
how does it, how can you just address, is it basically, does the RAM addressing skip from each bubble to the next? So you
Yeah.
can start.
Okay, remember that those RAMs are 32 bits wide, right? So
Okay.
that's 4 byte addresses per long. Right. So what happens is if you're imagine your cog 0, you see 0, 1, 2, 3 coming at you. What you're getting are successive longs in memory. Every clock you get the next 4 bytes, the next 4 bytes, the next 4 bytes. And everybody keeps getting the next 4 bytes. It's just they're all offset by, whatever the difference in cog number is.
But how do you randomly access these then? Like, let's say you're looking for, you address 200.
Well, you got to wait for the bus to come. You got okay, here's P1. See P1?
Yeah, I understand P1.
Okay, you have access to that 64K map. So when he hits like cog 4, cog 5, whatever, he's going, what do you want to do? And he goes, well, I want to read this location. Okay. And then he asks the next guy and he gives him the data. And then he goes to the next guy, what do you want to do? I want to write this location. So you had to wait 8 turns to get another chance at the hub RAM on the P1, right? You had to wait up to 8 or 7 extra clocks, because if it just left you, it has to go now 1 through 7 before it gets back to you if you're 0. Whereas on the P2, you've always got some new RAM coming up into your face. So you just have to wait for the starting one. It's like a bunch of boxcars in a loop. You just wait for the one of interest, and then you can just keep pumping data in or out of it. And every clock you can transfer 32 bits.
But it could be up to 8 clock pulses. It could still be up to 8 clock pulses until you get the RAM location you're looking for, right?
Yeah, it could be, yeah.
By random access, yes, you probably have that. You have to wait for the right come around,
Okay, that makes sense to me now. I thought somehow you figured out a way around that. That was kind of blowing my mind. Okay.
The great thing about that is once you've hit your address, then you're able to move data on every successive clock.
Yeah, that makes sense.
Talking about at the beginning, the P2 moves data around really, really quickly.
As long as you access them in ascending order. So
yes,
100,
of course.
104, 108, 110, whatever.
Yeah.
If you go the other way around, you have to wait every round.
Yeah. Yeah, it would be like the P1 in that case.
Right.
That's cool.
All right, let's see here. Stop the sharing. Okay.
Thank you for explaining that, Chip. That's something I've been worried about for a while.
You see the difference between P1 and P2 now, right?
I do, yes.
Yeah.
Chip, didn't you say it had something to do with the lower 3 bits?
The lower 2 bits.
Put them into my graphic.
Well, if you think about it, you're moving to every clock, you're moving to the next long in the logical hub memory, right? Every clock you move. Well, within each of those longs, there's 4 bytes, right?
Yeah.
So there's really the 2 LSBs of the address can be random. You're stepping up from address 0, 1, 2. So starting at address bit 2, everything increments on every clock.
Okay.
And then so if you want to access some, like a bunch of bytes starting at some offset, it waits for the particular long to come around, and then it grabs those bytes of interest, might ignore the first couple, right? Because it wants some where the point of interest begins. And then every clock, it gets another 32, another 4 bytes every other clock. So you can just stream data like mad. So if you're streaming like from long boundaries, then that's one thing. If you're streaming from non-long boundaries, it takes 1 extra clock, because before you can get 32 bits out of it, you have to get part of one long and then part of another to have a whole long.
Yeah.
So it could take 1 extra clock if you're not long aligned to begin the process. Does that make sense? Because now you've got it, you're looking for 32 bits, but that 32 bits is straddling two different longs.
Yeah.
So until you read both of those longs, you don't have your first 32 bits.
In the end, I know just screaming fast compared to the P1.
Yeah. It's way faster.
If, isn't the hub memory byte addressed and it can read any long from any position? So is RD fast or VR fast faster if you start with long addresses because there is one penalty?
And that's just an initial 1 clock penalty because it has to get the data, you know, that might overlap a long boundary. Like say, here's a long, here's a long. Well, maybe you want these two. You got to read this and then this one.
It's just for the first 2 bytes,
the first clock. Yeah, whatever. If you're
so you have 1 clock penalty if you are not starting on a long boundary. But
4
after
longs, yeah. But if you're only reading bytes out, no problem. You know, now a word or a long could overlap the next long. But a byte can't. A byte is like, you know, that's the fundamental unit. There's no extra 1 clock for starting bytes, but then you can't read bytes that fast anyway, right? If you're consuming bytes and you're consuming 1 byte per clock, well, that's where the FIFO has to come in because the thing could deliver 4 bytes per clock. But if you only need 1 byte per clock, that's where the FIFO comes in, where, you know, it's like a first in, first out kind of buffer that's elastic. So once that thing starts filling up, you can pull bytes, words, longs at any rate afterwards. You can go on this clock, I want a long, and then a long, and a long, and now I want a byte, a word, a byte, a long, a long, a long. And the FIFO will do this. So every time that thing comes around, if it has any room in the FIFO, it grabs the next data, sticks it in the FIFO. So once that FIFO is like, you know, queued up, you can take data out in any pattern up to 32 bits per clock, and the thing will never miss a beat.
Great.
I better get going, guys. Thank you for today, and see you next week.
Okay,
Thank
all
you,
right, we'll
John.
see you, John.
Thank you for your presentation, John.
Yeah, John, thanks a lot for that.
Thank you.
Okay, guys, have a good week.
You are very good at this.
Thank you, Michael.
You remember, I should tell you about, remember how we're having trouble with our, let's see, where is this thing? Let me grab the window. Why don't I see it here? Just a second. Let's see, there's a window here. Where do I pick a window? Okay, not a screen. Huh. That's what I'm not, oh, show all windows. Okay, here we go. Oh, here we go. Okay, this. Remember this?
Oh, the driver.
Yeah, so this is so crazy. We had accidentally designed the circuit board. Now this diode here is like, it only goes one direction because for heat dissipation, it has like one really huge pad and then one small pad. And so you cannot put it in backwards. So we designed it backwards. So that diode, you see what's happening? It was like always conducting to ground. It wasn't catching the negative spikes. It was always conducting to ground. And that's why everything kept blowing up all the time.
So you get all the feedback from the motor straight right back to the chip.
Everything.
Everything.
Everything to ground through the diode.
Wow.
Yeah, until the diode blows up or that 10 ohm resistor blows up or something. So what we're doing is, of course, we've reversed the diode. And then we've also taken that, see the C203, that's that bootstrap cap. We've moved that to the other side of the resistor because the side of the resistor it's on, which is the junction of the source and drain of the two big FETs, that thing routinely like goes down to -5 volts. And we don't want that versus 10 volts, that'll charge that thing to 15 volts and it's bigger than what we wanted. So this diode here clamps everything to like 0.8 volts or something, or 0.7. So by putting the capacitor on the other side of the resistor, it's not going to go so negative anymore, and it's not going to create like an over gate voltage. So he's gonna build up a board with the new arrangement. We're gonna test it, but we were checking it out today, and he just made some quick edits with a soldering iron, and it was perfect. It ran everything. He said the board never even got warm to the touch, and we were running 30 volts through it. We were running that big hoverboard wheel motor, and more current than necessary, but just to kind of beat everything up. Our board never got hot, but then he noticed something was smoking, and it was the wires from the power supply. It melted which is good. That's what you want. You want other stuff to die, not the driver board. So this is going to be, we're going to make those two edits, and I think that was it. We're going to put 3 ohm resistors on these gate resistors. This is going to remain a 10 ohm, and then we're going to get we're also going to get a beefier diode to put here, so that it's going to drop lower voltage when it's forward biased than this current one does, because we want to protect the driver chip from negative spikes that can cause latch up and destruction.
Wow. After all that discussion last week, and turns out to be the diode backwards.
Yeah, something totally
Never thought
Yeah,
never thought of that one.
No. No, it crossed my mind, but I was thinking, I don't know if I ever brought it up, but I didn't know that. I just thought, well, that's something that could be wrong. I mean, if the diode's backwards, that's going to cause a problem. But yeah, that was it. Everything ran great after this, and the board doesn't get hot even when it's passing like 40, 50 watts. It's not even getting warm. Although it will melt the power supply leads, which is good.
Yeah, sadly, I wasn't here last week because I would honestly ask, oh shit, some diode wrong? Because I'm doing that constantly.
Yeah.
So Chip, is the diagram correct? It was just wired wrong on the board?
Yeah, the land pattern was actually in backwards for the diode on the PCB.
Huh. Interesting.
Yeah, so that's getting straightened out, and crazy problem. So we know what to do to make it survive now. So it's too bad we had to go through all that, but whatever. Sometimes that's how it goes. And then of these little guys here, this is the one with the RAM, 32 mega RAM. We sent 4 of these off to the Australian guys. Let's see, I don't see any of them here now, but Roger Lowe or Rogue Lowe, he's always making drivers for these kinds of things and hyper RAM. So he has code ready to run on this, I'm sure. Just change some pin numbers.
Yeah, but Roger said in the forum a short couple of days ago that he is pretty busy with some other projects. So, but I mean, if you get one of those, he for sure will try it out. I mean, come on.
Well, no, I think he's curious enough.
So when are you going to start selling those?
I don't know. What happened was, I don't know if you heard, but we realized we needed to add more layers for heat dissipation to allow them to run faster and cooler. So we have a few to prove concept, but then we've ordered some other boards, which are going to be 6-layer boards instead of 4-layer boards, and they're going to allow the chip to go faster. So that's going to be the product. But if any of you guys really want one of these, just PM me on the forum, and we can get you one.
So what's your top speed? What's your top speed estimated at?
Hold on, we built 5 and they all went to Australia. Actually, I don't know if we have another one. I have 2 here. I'm running one in my JonnyMac board right now, and I have one on my desk. But without the driver code that someone's got to write, it's not going to do a whole lot initially. You'd have to write the code to make it go, which isn't very complicated, but it gets complicated when you start running at high frequency and you start having like multiple clock delays of propagation time going in and out of the chip. That's what makes it difficult. But Roger's
just
got
to-
all that figured out.
Just to make sure, so each cog runs at the same clock frequency, or can you set different clock frequencies for each cog?
They all run at the same because remember they're tied to that thing that
yeah, the hub
rotates.
ramp.
They all have to be going the same frequency.
Okay, that makes sense.
But you know, it could, I mean, I've thought about that before. The way to throttle the frequency would be to simply have like a pulse skipper, you know, where you start to go duty cycle, like adding a 32-bit or maybe an 8-bit value. And then the overflow says if you run that on that clock or not. That would be a way to kind of virtually throttle the speed by actually, does that make sense? By running like every 4th clock or 5th clock or.
Yeah, I guess so, yeah.
It'd probably be better to have like a 1/n kind of counter rather than an accumulator with overflow, because then you get kind of jitter patterns. If you get to pick one out of n clocks, then at least you have consistent clocking.
Chip, I have a question for you, which I measured with that. Okay, it was a Ref B eval board. It's the newest one I have. If I let all 8 cogs running in a repeat loop, it takes less power than if I just have 1 cog running and all of the other ones are out.
Is that so?
My measurement.
Well, it could be. I mean, it's whatever. You know, I just designed the logic, right? And then when they did the standard cell synthesis, they threw in these clock gates, and so it analyzed and figured out, okay, what gates can we clock at a higher level than at the flip-flop? And it just threw all that stuff together. So it stands to reason there could be some kind of surprising cases that save power that are not really immediately intuitive. There's some reason why it might be that way, but it's kind of the gestalt of the whole thing working together.
I was doing some experimentation because I'm an experimentalist with just timing of blinking LEDs on and off. I hit something that was kind of an anomaly that I'm curious, Chip, if you could explain it. Let me share my screen real quick. So I just thought it'd be cool to kind of see, you know, what the increase is from spin to assembly, inline assembly. So just turning a pin high and then low.
All right. So
on an oscilloscope measuring, you know, about 300 nanoseconds, but then with the same thing as inline assembly, it's 10 times less, which is kind of cool. So I was just kind of going through this stuff, trying to get a sense of how this worked. I noticed with the weight X, you always have to have at least a 1. If you put a 0 in there, it freezes and waits for it to come all the way around, I think.
Yeah.
But this one I was kind of curious about. So with the drive not, just to toggle the pin, for some reason it seems to be taking 10 clocks worth about.
Well, because, okay, so the drive knot takes 2 clocks and the jump takes 4 clocks. So that's 6 clocks.
So the jump should always take 4 clocks. So then, let's go to the simpler thing just to make sure I've got this right. Because I was just assuming this. So this would be 4.
That's going to be, oh no, wait. No, those are 2 clocks. Yeah, that's 4 right there. The jump is 4 and the others are all 2.
Okay, got it. Okay.
Okay, yeah, and then down below, change those 2.
Yeah, okay, cool. Thanks.
Yeah, that's 2. That's still 3 if you've got 1. Yeah, that's still 3. That's going to be 2. That one's still 3. And then that last one is 4.
Got it. Okay, cool. Thanks.
Now we can go faster. See, the drive knot is good, but what you can do is put the drive knot under a repeat and it'll really go. It'll go like 2 clocks per. Okay, so that drive knot, that's going to be
2 clocks.
Oh, I see. To get rid of the jump and have the repeat lines.
Yeah.
Got it. Okay. Cool.
But yeah, you can do it right now. And then, so what you'd say is after the org, just say,
Repeat.
yeah, no need for even the loop anymore.
Yep.
You just say, or what, say REP is what it is, REP.
Yeah.
And then #1.
Yeah, I'm
So-
still getting the hang of that.
Yeah, push #1. That means one instruction. And then put comma #0, meaning forever. Like if you put 1, it would just fall through. But now put a #0 there.
Yep.
So it's immediate. So that'll just loop forever, and that'll take 2 clocks per iteration.
Cool.
And then the other one above, change that so that, see, it says 2 clocks after the jump. That's 4, and then the one above that's 10 should be 2.
So that doesn't quite work out, does it?
Well, what's your clock frequency?
300 megahertz. So
Okay, so 3.3 nanoseconds times 6 is
Yeah.
20 nanoseconds.
yeah. I'll double check this experimentally too and get back to you if it's, but thanks for helping me clear up some of this stuff. I think this might make a good example within this book I'm working on.
Yeah, and you bet.
So that's pretty
Cool.
cool. You can just do inline assembly like that.
Yeah, this is
A
really neat.
regular
And Spin 2
function?
Chip worked this out for us. So you can just be doing your normal Spin 2 stuff and then just say org and end and just throw it in.
Oh, wow.
And you can
Very
put
cool.
spin on either side of it, in front or back, or above or below, I should say. And then, and it can also, within that block, it can access just by name. It will access any local variables you have in that routine.
Oh, wow. Okay. But
So
it
you can
doesn't have
see some-
access to global.
So here's JonnyMac's code for the I2C, and he just tops into inline assembly when he needs extra speed. There's also, because this has got such a rich language in assembly, there's certain things you can do that you can't do in the higher level Spin, where it's just kind of nice if there's that one command you want, you can just kind of jump in and use it, and then jump back out into the high level.
Yeah, that I've heard that with a lot of other processors that IOs are and they kind of were implemented almost like an afterthought, where you have to access some sort of a register or a memory to get them to do anything, which, is kind of unfortunate, because in this case, we just put it right into the language, stuff. So, I mean, you could mess with registers to do the same thing, but it's not as efficient as just saying, I want this pin and plus any others. You can go up to 31 additional pins after that, and it'll do it to all those pins.
So really, Nicholas, the cool thing about this chip is the community and the people that get into assembly that start doing all this heavy lifting and low level on the metal code to be able to do amazing things on this relatively inexpensive microcontroller. So, for example, on the P1 chip worked out ways to synthesize human speech, and just being able to have that just done through software, but done through hundreds of lines of assembly that really just are as elegant as it can get in terms of efficiency. Juxtaposed to the Arduino, which has all kinds of amazing libraries people have written for it, but they're all just kind of piled upon junk. So it's sort of when something goes wrong, it's a mess. So it's just, instead of having piles and piles of inefficiency, like say in Windows, where you can have blue screens, you can actually make everything pure and beautiful from the ground up. And if you're trying to debug stuff, you can also pop the hood and quickly go down to the lowest level and figure out what's wrong.
There are no unknowables in this thing. Everything is like, you can look at it. There are no lawyers hiding behind cracks.
Yeah.
So that's the philosophy that makes this unique.
See what module I should get. I was thinking of the evaluation board, but then there's also the edge module with the breadboard, which is interesting. So I don't know which one. I guess that one's easier to work with, I would assume.
JonnyMac board's probably the best one to get.
Okay.
Yeah, I'd second that.
Okay.
As of right now, I'm trying to make a kit to teach, based on stuff I've built for my students at UVA. But
nice.
Really right now with the supply chain crisis, this is kind of off the table for a couple months. It's so hard to get stuff, especially from China right now, that that's really thrown a loop in my plans. But I've worked out a bill of material of 100 parts. I'm trying to keep everything under I know something we can sell for around $300 through Parallax, but that's just become very difficult just to source all those parts at this point in time, unfortunately.
Yeah, I'm still surprised I haven't heard of this. This is insane. Like, this is crazy.
Yeah,
Well, it's the way the world works, you know, they're like, most of the world kind of is like on this freight train, and whatever the prevailing methodology is, everybody does that's how they think. And they just go that way. But it kind of constrains creativity because you only think about you can only think in terms of what seems to be happening. So here we have like a small odd group of people that like they look way outside the box, and they'll go, oh, this is like raw material that we can use for this, and we can just do whatever we want with it, like putty.
I've actually used that analogy that this propeller chip, the propeller 1 and propeller 2 are kind of like putty, where you just form it into whatever you want whenever you need it. So it's just sort of like this universal blob that just transforms into whatever you need to fit whatever part you want.
Yeah, and it makes sense because like other processors, like I was using the STM for my senior design, and it has all these peripherals, and it's like, well, I'm not using most of them. I'm just using SPI, I2C. It'll be nice if I can just spin it up whenever I need it, and then not have to use all the other like CAN and all this other stuff. So that's pretty cool. You can just do things on the fly like that.
Because, you know, in order to be able to do anything, you can't get too divorced from first principles. Otherwise, you're off in the ether, and you wind up with like problems you can't really analyze or solve. And that's how a lot of stuff is these days. But this is like, if you can stick with first principles and have like a good, like little toolbox of stuff that's real fundamental, then you can build anything. I wish the whole world would kind of like get that idea, but it's just a few of us.
It's very cheap to get circuit boards made now these days too. Not like it used to be $60, $70 to get a development board, you know, a small one made. Now you can get a 4-inch square board fabbed out of China for like $5 and have it FedEx back to you in 3 days.
Yeah, that's amazing.
Not anymore. Chip, do you remember maybe the name of that document you wrote, that how it came to the P1? It was
why it works.
10 years ago, whatever, 15. You wrote a short explanation why it came to the P1.
Let me see if I can find it.
On website, but I can't find it anymore because that was it's a really readable text.
Oh, here we go. Let's see. Let's see. Let's see the propeller. Let's see. I guess. Let's see. Let's see. Okay, yeah. Well, here's some link I found. You know, it's funny. At the time, I was thinking that you know, we just did it all by hand, but there's a lot of stuff we couldn't know doing it that way. You know, we didn't really have. I mean, the tools that they use these days to synthesize chips with are so far beyond the capabilities of a human being that, I mean, they're getting more out of old processes than they were 10 years after the processes were made, even because the tools keep getting better and better. They can close timing more and more accurately. And so it actually is, when you're dealing with, you know, millions or 500,000 gates in this case, it is, you have to rely on stuff like that to get it all to work. And it frees you up from all the implementation details. But at the time we made the P1 chip, it was all about implementation. You know, I mean, it was from a schematic. So I make a schematic, then, well, no, I think first I write code for the Altera FPGA, get it working. But I write the code with my mind set on a schematic. Then I make a schematic that represents that circuit. Then we lay that out into a chip, and thank goodness it worked. But I mean, these days, the whole process is much more deterministic. Let's see, where's the chat thing at? Chat. Let's see. Come on in, sweetie.
So I saw your comment on the forum about the compiling peanut the other day, Chip. I don't think that's going to work. And I'm not converting object code is probably not my strongest suit, but basically what happens is when I take the object file that the turbo assembler puts out at 77K, then I run object convert on it to convert it from OMF to COF, and it becomes 5 megabytes.
Well, see, there's a lot of buffers that are declared in there.
Okay.
You know, that are don't need to be part of an object file, but if it gets expanded into a map, those buffers are just going to be there.
Okay, because I think that's where the linker's crapping out, because you can't have a unit file, I think, that big. You can't have a unit file that's 5 megabytes.
Yeah. Yeah. So what would have to happen is those larger buffers would need to be declared outside in Delphi or whatever, and then pointed to from within the assembly code.
Yeah. Well, I saw Werfel, she said she got it compiled, so I'm not sure how.
Yeah, I don't know. She knows things I'll never know.
Yeah, I don't know how she did it, but all I know is that file went from 77K to 5 megabytes. And I was like, how did this happen?
It's just all the buffers that are squirreled away in that thing. If I do like, I think DBX, DDX, let's see, I have these macros in there that I made.
I saw all these people were having problems just getting it compiled. And if you look at the errors, it's pretty clear, you know, there's a lot of units that just automatically are inferred to by Delphi, but in Lazarus and Turbo Pascal or Free Pascal, you have to actually add them. So you have to put like the Windows unit in there. You have to put the Win32 modules in there. You have to add all those units in that are inferred automatically, and then it compiles clean. The only thing I had a problem with was there's multiple declarations of the rect function. So you have to specify directly which one you want.
The rect function?
Yeah. So you have to do classes.rect. So every time you call rect, you just have to put classes.rect. It's something in Free Pascal. And if you Google the error that gets kicked back, it specifically tells you to do that. So.
I see. Wow.
So, but no, it compiles all the way to the end, and it's like just on the linker, it dies.
Okay, so do you know what the size limit is? I mean, there's probably like 2 or 3 buffers we could remove and get into.
I think 1200 kilobytes is.
Okay. 1.2 megabytes then.
Yeah, I think that's what it. Let me get the error. Let me look at the error again, and I'll tell you exactly, because some guy was
Wait, so Pina is a debug tool? So you compile the spin code and then
it's that sandbox program I use for development. And then when I get working in there, I give to Jeff and he puts it into Propeller Tool, which is that bigger application.
Yeah, it's got some kind of unique assembly code in it that makes it kind of difficult to work with on other platforms. So it's kind of.
Yeah, there's 17,000 lines of 386 assembly code.
It's kind of stuck in 32-bit mode, and I don't think it's ever going to come out of there unless somebody rewrites it in C.
That is already done.
It's already been done?
Sure, we have flex bin completely in C. We have Würfel's implementation, which is Spinner 2, which is a complete compiler. I mean, we have a lot. We don't have propeller tool. No, sadly, you know. That's a big bear. That somebody get propeller tool to run in Free Pascal.
Yeah, I was trying to, but it's that assembly code so the assembly code needs to be reworked, and then the turbo assembler code just ain't gonna.
yeah, as far as I understood, Würfel or Ada, she was running TASM in kind of a batch file in the DOS window to compile the assembler part into some binary, and then she linked it to the, but she had to go down to DOS mode to compile the assembler part, sort of. That is what she wrote in some post.
Yeah, yeah, and that part's easy. You just open a DOS window and run it. But
Yeah.
the problem is the turbo assembler spits out OMF formatted object code, and the GCC linker needs cough mode.
Ah, shit.
And that's where I'm stuck, because when I convert that OMF object code to cough, it goes from 77K to 5 megabyte file, and now I can't link it because it says the unit is too big.
Yeah, well, there's certainly a couple of let's see here. The object buffer is a megabyte at least. Yeah, that'd be a megabyte. And then let's see, what other big things do I have here? Some other things, let's see, DAT stuff. Yeah, there's just a bunch of buffers in there that could be relocated out. It's around line 1500. There's a whole bunch of these declarations. Oh, and there's the list file itself. I mean, how big is that? Let me see. The list limit. Oh man, the list limit is 10 megabytes. So I don't know why it's not, way bigger than 5 megabytes. You know, I wonder if maybe it got that big. Greg, do you have any way to like look at it and see what kind of, I mean, because they're not going to define an undeclared data structure literally, are they? Like, here's all the zeros that go into it. If you look in that thing and see like a whole bunch of zeros, that might give an indication of what the problem is, but who knows? The way everything is so huge these days. Wait a minute. There is. Maybe it's just bloat, and maybe it's not a problem of buffers, but just too much stuff. Greg, are you there?
Oh, I'm sitting here talking with the muted.
All right.
So I can dump out all of the, with object convert, you can dump out all of the data pretty much, into raw format, but I don't know.
It's not a text file, right? It's some kind of binary.
No, it's a binary. Yeah, it's an object file. It's I mean, if you open it up, it's definitely, garbage. You can't really read it.
Well, do you see any huge runs of the same value?
Let's see.
You have some kind of file inspector program, right?
I just can open it up in like Notepad++ or something, and it's sort of kind of real. There's a lot of like nulls and stuff like that in there, but and some garbage. I don't see a lot of the same stuff repeated over and over again.
Well, modern people might have figured out how to turn it into 5 megabytes.
But there's a lot of dead space in the file.
There is. Is most of the file dead space?
A good part of it is like the first. So like the first 330 lines are solid, and then the next several hundred lines are like 15 or 20 characters long each. So I'm just wondering if maybe there's a way to compress this down or something, or.
Let's see here, check this out. I'm gonna paste something here. I think this is what I use. It's a little program that lets you see the actual bytes in the file.
Oh, the hex edit?
Yeah, you have that program?
I don't. Let me grab it real quick. Is it a free one?
Well, it's just an executable.
Yeah.
Yeah, it's free. Yeah, of course.
Let me grab it.
It's kind of stiff-necked, but it does let you see what's in files.
I have been summoned. I was watching on YouTube, and I was hearing the problem with the object conversion from OMF to COF. The solution is you don't use COF. COF sucks. Use ELF. It works.
If I convert it to ELF, the file size comes out the same. Already tried that.
I don't know. It works for me. I have a repository of it in it, with the thing in it.
Did you use object convert to convert the object code?
Yes. Sorry, I was hearing double.
No problem.
Yeah, because I tried to do it in ELF too, and it still was fairly large.
Again, I have this repository.
Okay.
It blows up for him at the linker stage.
It doesn't for me.
Can you post your command line options for object convert that you ran? Can you put that in the chat?
I'm looking for the repository right now. If I can find it, maybe.
Maybe the linker will handle larger ELF files.
Well, yeah. Let me try to do it in ELF and then see if it'll work in ELF. Okay, now let me try to link it again. Let's see what happens.
Otter, were you getting anywhere where it was actually going to be platform independent?
Oh yeah, it is. It already runs on Linux, but only if you have the 32-bit multilib installed.
Now I'm back to the when I convert it to ELF, I'm back to the same original error message I had from the linker where it says illegal cough magic while reading.
I just posted the link to my repository in the chat. You can see it's got a rake file in there. It will tell you all the commands that it uses. As you can see, it doesn't really do anything particularly strange, except it bundles the object conf because I don't know, because building C programs is always pain. So I just included the Windows binary and just run it through YNB. I actually discovered that the turbo assembler is a hybrid binary. Only the installer that you can find on the internet for it's DOS only, but the actual program is a hybrid binary that can run under Win32. So you don't actually need DOSBox. You can just run it.
So you're using Rake to build this.
Oh yes, Rake.
Okay.
How do you pronounce your handle?
My handle, you mean Würfel?
How to say that again?
Würfel.
Würfel. I see your posts all over the forum. I was wondering who you were. That's interesting.
Well, I'm just a person.
Such modesty.
I don't know. I'm boring, except when I'm not. But mostly I'm boring. Yeah.
So, are you compiling this with Free Pascal compiler, or are you compiling this with GCC?
I'm compiling with GCC. I don't use any of the Pascal code.
That's where you're. That's why I think it's working for you and not for me.
I just wrote like a very stupid C code is just like 300 something lines. And that basically does it. It just takes in the files and like loads them. And it basically just all the stuff that the compiler should do itself. But I don't know, probably it would be terrible to do that from assembly. And like, I actually wrote that before the peanut source got released. I only had the assembly part, so I kind of had to infer it. And I thought I made a mistake because it didn't work, but I actually just made the list buffer too small. And for some reason, I tried making it bigger, it didn't work. But now I tried it again, and it did work. I have no idea why this happened. So we could have actually had this a lot earlier, but I'm just an idiot. And again, this is really stupid and not quite production ready because it has the very cool property of always trying to read the dependency files in the current directory. It has no idea of like a library directory. But I guess if you put like the object name as with a directory, which I think is a thing that the propeller tool doesn't do. I don't know what Peanut does, but the propeller tool hates it. When you try to use subdirectories, it just doesn't let you. This would, but it's always relative to the current directory because it's just shitty and hastily written. I'm also thinking of, because FlexWin has a preprocessor, you know? Well, that's a mostly independent thing. You can just, I can basically just take that and slap it on, and then you can have the Spin2 chips spin compiler with pre-processing, which I guess is a useful thing.
Yeah.
Well, having seen speaking of having seen that assembly code, can we please just do FlexWin? Like, can we just add bytecode stuff into FlexWin and be done with it?
Yeah, I think that's the only issue we have is the bytecode.
I mean, the thing is there, like the structure for bytecode and the P1 implementation is there and works okay. I've had not a single bug report on this. Not a single one. It even no one is using it, or it just works so good. I like to think it's the latter.
Maybe a combination.
Oh, also, with regards to the buffer sizes, I just forgot. I actually removed most of the buffers from the assembly source.
That's that.
Yes,
Greg?
mostly because it's easier. Mostly because it's easier to make this modification to the assembly source than to figure out how to allocate the objects into this pre-made buffer. That's kind of complicated, isn't it? Whereas just calling malloc from C is very easy.
Yeah, and I think that's why my object file is 5 megabytes.
Yeah, check my modified P2Com ASM. You can just search for W21 and you'll find all my little modifications. There's like, how many of them are there?
Search for W21.
Yep, in the assembly source, and you'll find like the 5 lines that are modified.
Okay.
And that basically changes it from using these predefined buffers and offsets into those buffers to using just pointers. They'll end up on the heap, on the C heap.
Yeah. Take a look at this. I was going to have my son help me out with this. He's graduating from college this year, and but he's off to Europe with his girlfriend for the holidays. So I was fluttering a little bit.
he knows more about this stuff than you do?
He knows more about the underpinnings. I never really took like an architectural compiler class or anything like that in college. They didn't have that stuff around when I went to college. You know,
Well, I never took anything, and I know more than a lot of people apparently.
you know,
Like
I
I'm
said
all
before,
self-taught.
you know, I learned Fortran and COBOL and Pascal when I went to college, and all my professors said, don't worry about C, it'll never catch on. You know, it'll never be more than an operating system language.
Oh, wow, how wrong. Though C is like terrible for like most application development. It's kind of bad, but it's the only thing you have if you want to be like portable and not terribly bloated. C++ is a thing, but that's just C, but with more weirdness. But I guess you get like templates. Templates are cool. Except when you overdo it and they like, you like nest them to the nth degree, and suddenly one line of code expands to like 50,000 lines of templates that needs to be instantiated. That can happen. But what was the other thing? There was a thing. Oh God. Anyways, RAM edges, anyone? I have one, and I will do evil things with it soon. If by evil things you mean maybe try to get the Motorola 68,000. Yes, I always get this wrong, presumably because it's x86 and 68K. I always have to think like 5 seconds whenever those come off.
Yeah, I love that 68 assembler language. It has so nice assembler mnemonics. I mean, chip is kind of bound to those short ones, you know, but if you go to the list of the assembler mnemonics of the 86,000 or 8640, there are some so nice nice words. I like it. I mean, I like I've worked with 86 for a long time, and if you have an emulator, I'm ready to test it with whatever I can. I can write assembler still, you know.
Well, my thing is, I only have like the sound and the graphics parts for a Mega Drive emulator, so I'm gonna do that probably. That's nice and flashy. You can play, I don't know, shoot Thunder Force 4 on your P2 and I don't know, get angry and smash your entire setup because the game is bullshit.
No, I would be interested in to run some kind of Atari ST or something like that, you know.
Problem is that those 16-bit computers, they have lots of RAM, and that'd be kind of, well, Atari ST that doesn't really have like the same cycle accuracy that an Amiga has. So I guess you could probably do a decent job, but just be really slow.
Yeah, but basically just for the fun of it, I love that assembler. I mean, writing code in that assembler.
You know what's the funniest assembler language? It's PowerPC assembly, arguably, because everything's just a number. It's just numbers, and like 3-letter opcodes that do like 3 things at once.
No, I never tried PowerPC. You know, I don't know.
Because sometimes the number is a register, 0 to 31, a GP register. Sometimes it's a floating point register, which I think there's also 32 of. I don't know. Who cares about floating point? Sometimes it is some sort of modifier to the instruction, like the branch instruction. Is it a looping branch instruction? What is the condition of the branch instruction? What is the meaning of life? It's all encoded in a number. You can write a more long-winded thing if you're writing manually, But if you're just like disassembling something, it often just gives you the numbers. Like, is that really disassembling if it's just some letters and numbers?
Do you ever have heard about FASM? FASM is a macro assembler which can basically assemble anything, because it's basically just it's www.fasm.net, I think. It's an absolutely cool macro assembler for I mean, Chip might be interested in that too. It's one of the rare forums I'm following. And this thing can produce anything, basically. You define macros and you can assemble anything and I mean, it's a weird concept of a Polish guy, a guy named Thomas Gristar, and he is working on that project since 15 years, and it's one of the best assemblers I ever saw in my life. You know, it eats everything. You should take a look at it. FASM, FASM. It's a cool, really cool website and a really cool product. If you have time over Christmas, take a look at it, please. You will like it.
Yeah. I put his fixes in and I got it down to 2 megabytes now, but it's still too big.
You know,
So
this reminds me, there was a time when people would accidentally assume that that you have to he or him me, because that's evil. So I put it in my forum signature that's she her, and people just ignored it once. Then I made it like underlined in bold and italics every time someone forgot it. It hasn't happened on the forum since. I think it has now enough text effects that it stands out.
Yeah, and my other beloved forum member who got me into all of this, because M Park built a spin compiler running on a P1 computer, and that what got me in.
Michael Parks.
Yeah, Michael Park. And Michael Park got that thing with she, her, and he has this signature now. He, him.
Yeah, I think that started on like Twitter because I don't know, everyone on Twitter either has like a stupid profile picture or like anime, which is not stupid. No, it is. So people had to start putting it in there because no one knows, and I think it's spread. It's a good idea because you really don't know on the internet. The obvious solution would be to adopt languages where that's not an issue, but I don't know.
Your approach with she, her is basically a good one, you know.
Yeah.
Except
does Esperanto have gendered third-person pronouns?
You would
that's
kind
a weird
of
question.
change your forum name into Wilfelin or whatever. But basically, isn't it kind of legal? Also ich meine, ist das nicht eigentlich völlig Wurst, ob du Männchen oder Weibchen bist? So
technically yes, but but also not.
Okay. Yeah.
No, it's important enough to me.
Yeah, I mean, John McFarlane is the same thing, you know. He wants to be called John or JonnyMac, but not Johnny. Then he gets mad.
That is very important.
Yeah, I mean, it's kind of, I don't know why, but he has it even in a signature, you know. And you have to
presumably because it happened and it annoyed him.
Yeah, I probably, you know.
I watched the video from last week, and apparently Ken made that mistake right off the bat.
Oh no.
Yes.
Has he been sent to the Shadow Realm?
I've got this thing sending back now data, and it works.
Oh, Chip's doing the live coding. Unbelievable.
Awesome. Can you share the screen? Or-
Yeah, about JonnyMac, he's worked at Parallax since, I mean, off and on since, I want to say like mid 90s, early 90s. He knows. I think it's probably early 90s. And at that point, his name was John Williams. But being in Hollywood, he changed his name to John McPhalen because John Williams was some kind of composer or actor or
Yeah,
something.
he's the biggest composer. He does all the Star Wars. He's done all Jaws. Yeah. He's the most famous composer in Hollywood. So that makes sense.
Hollywood namespace conflict. So he changed his name to John McPhalen. So, but I always think of him in my mind still as John Williams. But it's John McPhalen now.
But didn't they tell him that he could not use that name? He tried to get a gig or something, and
it's possible.
You can't use that name. That's a famous composer. You got to come up with another Hollywood name.
Right. That URL's taken. You need to come up with something different. Here, let's share the screen here. Let's see. Okay. Now, where is this piece? Oh, here we go. Okay, so you see that window there. Let me just, oh, there. Okay, see where it says my plot? Here, I'll put it near the top. It says mouse pose. Can you guys see that?
Yes, we see the debug screen.
And then I did an update, and then I printed out what it received. So I was sending out the bytes 0, 1, 2, and 3 from the PC in response to this keyword mouse pose coming in. And so later that's going to be like the encoded mouse position, but for now I just set it to that data. So you can see it's coming through.
Awesome.
And so let's see if I shut this down. Here is where I did it right here. So this is the thing right here. So that's where it see it's sent to that window. That window got the message. And it said, give me and put it into PS, right? So PS was just a little variable I declared up here. And then I printed it down here. And so we could see it was 0, 1, 2, 3. So that works. All I got to do now is put the right data into it. I've got to come up with some format for the X, the Y, how to say if it's in the window or out of the window, and then what the button states are, and then maybe something for the scroll wheel too.
Yeah, basically there is that format with XY. You have usually on mouses 3 buttons, and then that scroll wheel which gives you an value, and all of this is in a structure used by Linux and Windows. It's kind of a one call into some, and you get that information. I think you should just give that block back, and the user can pick out what he needs.
Well, I'll try to make it somewhat, sometimes Windows is just too verbose about how it structures things. I'll try to just pack it into.
Basically, what we need is the mouse position in that window, which you send that debug command to that window. The window answers, and you need the position in the window. And if you are outside the window, you get -1, and you are not inside the window, so it's in window.
Right. That's what we need.
Yeah, and that's simple.
Whoa.
But because keeping track of position of the window in the P2 is bullshit. Relative position to the window corner.
Right. All it cares about is the window, because
which buttons are pressed, and if possible, what color of the pixel below is it?
Right. That was pretty painless. Literally adding that feature in was like, well, aside from the serial port initialization on the P2 side, it was like a dozen lines of code on the P2 altogether, and then maybe 8 lines of code in the Delphi program. But I got to make it now get the proper data. But that's cool. It's handing back the window of interest is getting the data that applies to itself now.
Exactly. Yeah.
Gavin, you're
Only
gonna
8 lines. That's not even gonna be painful to integrate into the FlexBin debug support.
no. You can do like a file difference or something and see where it is. It's just real simple
Yeah,
stuff.
because I made a couple changes to it. I think mostly to get the compiler warnings shut up.
Oh yeah.
The way that FlexBin does all its files like that is it basically all the system files, unlike your stuff where you compile it into the binary, it actually just has the source embedded into the binary and compiles it at runtime. So if there's a compiler warning inside this embedded source, it will print that source. It will print that warning every time. Sorry for the thing.
Yes. Did you ask a question, Ada, or you're just stating what was happening?
Yeah, I'm just stating things that I believe to be things that I believe. Yes, that's 2 levels of belief there.
Gavin, for your students, do you think it's okay if I send this data out? I mean, how ideally should we do it? Because we have a few things. We have button states. We have a flag that says, is it in the window? And then we have X and Y. Now I can pack this all into 32 bits, right? And just send it out as a thing. But then your students have to then break it apart. Otherwise, we'd have to have like a structure to write it into.
Again, I'm fine with leaving the heavy lifting for the Propeller 2 chip and its processor. So just sending a whole packet of data. And I don't really expect students to be digging into this all that much. What I really need to do at a higher level with the students is have them interacting with the Propeller in real time. So the ability to be able to, type in values and have it sent out from the keyboard to the Propeller 2 as it's running, or mouse click or something to it would be that. It's all just really enhances the human machine interface for prototyping and testing. So it really enhances that. And that coupled with the sprite graphic capabilities now really is going to make it a really interesting back and forth. The video game has been great because it teaches the students how to program the propeller. So there's not anything else like that that's really meant for programming microcontroller chips and enhancing those skills as you practice. So it's and that. So again, JonnyMac did this great presentation today about how to use these little HMIs that can be embedded into systems, but they're expensive. Everybody already has, their PC they're using to program this propeller chip. So it really enhances the whole environment that you've created. So it's just the more functionality it has, the more streamlined the user interface is going to be. So. But again, the heavy lifting can be done by the Propeller 2 chip. It doesn't have to be done on the PC side. Just sending the data there and let the Propeller program parse it out and do whatever it wants with it.
I kind of like the idea of just sending one long because it's simple and it's quick. If we have to send more data, then everything's slower,
I agree. And so something like this, the mouse wheel is nice, but that's not, again, if it doesn't fit into the long of data you've got. I was also thinking about it, and the scroll wheel is a quadstring coder, so it might only send a tick when it's just a receiving.
Relative. Yeah, we would just say that it.
Well, so I don't know if the processor on the mouse takes care of an absolute kind of positioning based off of that.
Oh, I see what you're saying. Well, I think it just gives you like that it incremented or it decremented. I think that's how it works.
Okay.
I think over USB it's actually absolute, but the operating system turns it back to relative in like some sort of bizarre way.
Yeah.
On USB, everything I think is absolute. I think even mouse coordinates are absolute, but not relative to anything. They're just absolute relative to wherever the mouse started up when it gets enumerated. I think that's just maybe wrong, but I don't know.
That sounds right.
I think it's designed that way, so similar to the keyboard also always gives it its absolute state over USB. I think the intent is such that if a message is dropped, it doesn't go haywire. I think that was the intent, but USB is really confusing and stupid. No one knows what the intent was.
Yeah, but Chip, I think we can even split that in different debug calls, like give me mouse position and you get one long back, or mouse position and buttons clicked. Same with keyboard, give me the key clicked or not, is one long. But you can put another call, give me the position of that scroll wheel, or I mean, we can give multiple commands that we always give just back along. We don't need to give back a 16-byte buffer. Give me the state of the control keys, caps lock, shift, control, whatever function keys.
You know, it is kind of a very unique and specific.
Calls, but the first thing which is needed is give me simple the first having ASCII code of the keyboard.
Right.
But keyboards are not ASCII. Keyboards are either scan codes or translated into ASCII, well, Unicode these days. And the problem there is you cannot probe if the Z key is held down, for example, at least not in any reasonable way. You can only probe if the key at the position of the Z key is held down, which is fine if you're in Americana funny land. But as soon as you go literally anywhere else, the keys all move around. The letters usually not that much, but all these special characters, they go all over the place.
So basically, we have to send over the key code, which is
you'd have to.
Yeah,
sometimes you want scan codes if you're doing like something like a game where you're just using the buttons as actions. But if you're typing text, you'd really want an API that's like ask for a text character, and it will send that character over. And of course, there's additional complexity because there's additional complexity with getting a text character, because you can just do that, but well, you can just do that if you're not doing Unicode, then I think it's fine, because I think it's fine unless you're using like a weird thing. If you're just lazy to type the accents on French, you can use an IME for that. But with Asian languages, you use an IME. You don't type the letters directly because there's too many. So use an IME, and that's additional complexity, because that's really not obvious support.
To me, just letting the propeller 2 and whatever software objects it's running take care of that complexity is fine. So we don't have to worry about every permutation. I think just having whatever code the propeller 2 can then decode to figure out what letter was pressed is fine.
Yes.
Yeah, but you don't know what the keyboard is on the P2 unless you encode a scan code to key thing, like you need to do with the USB driver, for example. If you're attaching a USB code directly, then you have to deal with that. But if you're doing the debug thing, you really don't want to deal with that, do you? You want to have the PC deal with the mapping from keyboard character to actual character. And
yeah, the keyboard is more complex than the mouse because of these issues. But about the mouse,
and I just realized it's not just IMEs that are complicated; it's dead keys. You know what a dead key is? No, you don't, because you're all Americans.
Actually, I think Delphi on the PC side can take care of that, and it is installed on a Japanese Windows or in whatever. But what we currently use on a P2 or also P1 is a serial terminal with ASCII codes. FlexProp installed already ANSI at least, but UTF-8 or something, we don't really need that for a debug window. Come on. It would be nice.
No, not really. You only really need ASCII, but on a German keyboard, you probably actually know this. On a German keyboard, you know how do you enter a backtick? It's not just a single key press. You have to press the backtick, that key, and then you have to press the spacebar.
Now, right? Imagine how complicated it is for me to kind of write German umlauts on an American keyboard.
Okay, you can actually get an IME just for that. It's like entering Asian languages, but for like languages with umlauts and accents. You just type it in and it automatically figures it out.
Anyways, I think if we just would get like in the serial terminal, we get an ASCII code 0 to 255. And we send ASCII 0 to 55 and ignore every UTF.
That's what I mean. You have to get the text that the OS gives the debug window, and you have to poll for that. Is there a new text character? And the encoding of that doesn't matter, of course. If you're getting weird stuff, then it doesn't matter. Again, I'm not sure how you would do it so it works correctly with anything that's more weird than just a standard key press. I don't think I've ever particularly thought about how the
My
dead key
opinion,
actually
we
works.
should- In my opinion, we should make two, I mean, mouse is clear. We need one call, mouse XY position and inside of the window and -1 for outside. So
You know
we
what,
are either
thinking
inside
about
of
this,
our MyPlot window or we are not inside our MyPlot window. The next
Thinking-
thing is we need if the buttons of the mouse are pressed or not. And the third thing we need probably would be nice, could be another call, the color of the pixel below the mouse pointer.
well, look, I kind of think we should maybe just have a record of like X, Y, and then a couple of, well, they because it has to work with PASM code, they need to be, because look, if we ever give anyone this 32 bits raw, they're going to have to parse it apart, right? They're going to have to apply all this code to it to pull the fields out. And it's going to take them instructions to do that. Then it's going to take space to store the results. Why don't we just take it in, all parse it inside the P2, and then write it to like several consecutive locations pointed to, right? So what you do is you have an address that's like 5 that points to a 5 longs. The first one is X, the second is Y, the third is like the button states, and then the fourth is, or maybe the on-screen.
I think your previous idea that you just return one long, that you are out of it fast, is better. And we can get a demo call, give me mouse XY. I'm not.
Well, yeah, well, what I'm saying is, we only need.
I just want the position. I don't want even to know if the button is clicked or not. Give me state of the mouse button.
Yeah, well, that's what I'm saying, but
give me just make different demo calls out of it, and each of them just returns one long. If you are not interested in the position, you just want to know if the mouse is released, you just call mouse button.
we'll see what we could do though is we could take care of the job rather than have them have all this rote code they have to implement every time they use this feature. If we just say point to the first of 5 longs, I could take that long that gets transmitted and I can parse it out and go, here's your X, here's your Y, here are your buttons, here's your on-screen flag, done. Then all they have to do is look at that data. They don't have to like parse anything because it would have taken them more than 5 longs of code to rip it all apart anyway. And then if we do that for them, the job's done.
Right, and you have one thing which says mouse position and button position, and you might have another one for the roll thing or whatever,
Yeah.
And that's for the mouse and position relative to the debug window.
Right. Yeah, and we could use, we could make, if the X or Y is negative, but they'll both be negative if that's the case, that means you're off screen because that's a simple thing to test for, right? If X is less than 0 or Y is less than 0, you can just look at one or the other.
On the P2, if it minus, no, I'm out of bounds, mouse is not here.
And you've already got that in the debug plot screens. As you move the mouse around, it shows you the XY coordinates as you move.
Yeah, we'll need a setup thing to disable that. You know what I mean? Because you don't want a secondary mouse necessarily. The guy running the plot loop might want to plot the mouse position as he goes with some custom thing, rather than always second guess on the PC side and have some sometimes unwelcome overlay. We need a way to cut off the mouse pointer when you're inside the window. It'll just be something that happens in the instantiation line.
Sure.
Yeah, you could kind of put a parameter there, mouse on, off, or whatever.
Yeah.
For a mouse style, we have those styles, kind of give me an underscore, give me a whatever pointer.
Yeah. I'll have this thing working all by tomorrow. I'll post it.
Cool. So Chip, just to reiterate, what you've suggested is fine, just having one command spit out a whole bunch of data that gets parsed into different RAM locations. I think that's fine. I understand what Michael's saying about having a separate command for everything you might want to do, but I can understand how that's going to junk up the spin language even more.
Yeah, because they're going to have to they're going to have to execute the same weird little code to keep extracting all those data fields. Might as well just do it for them.
Right.
Make it easy.
Right. And again, all this can be handled in objects written after the fact, to
Right.
make it more streamlined if people really do want to dig into it. But I think that's, again, one of the beauties of this chip is that, people are taking the time to write nice objects that then people can just build upon. But then unlike the Arduinos, it's much easier to dive down into those objects and figure out what's going on if you need to.
And
Yeah.
they are pretty simple usually. That is a funny thing, because most of them are written by JonnyMac, and he is good.
Hey,
Oh, he honestly has a lot of objects written in the last 2 years, whatever. They are all in JonnyMac style, and everybody should learn from that style.
Yeah, that's something that worries me too, is that with the object exchange, it was pretty easy to upload the files and stuff. But I think the GitHub is going to be, we've got to do a better job of kind of explaining how that's going to work. And
Yeah,
I know Ken made some videos a couple months ago, but I think,
should we try to reinstitute the object exchange somehow?
it might not be necessary, but I think what we need is a bunch of JonnyMacs and UChip back in the trenches, kind of making really amazing code that just makes things easier for everybody.
Yeah, but that GitHub thing is not organized, and obviously, I mean, it is, but it is. The OVEX was way better. You search for something, you got the author, you got a short description, you got the object.
I think what we need is a really well-honed set of code that is installed automatically with Propeller tool every time. And I think the JonnyMac one's really got us a head start on that, but I think we need a bit more on there that just makes it seamless right off of the bat when somebody for the first time downloads it and tries to get something to work.
Right. I mean, basically what we would need would be in the Propeller tool, not the library folder and the demo folder, but an GitHub folder, which gets shown in your program when you start it, and it can browse through that stupid GitHub folder out of the Propeller tool, like you browse in your library and you browse in your demo folder, and you don't need to take care out of GitHub at all. You just browse in that local folder, and if you need a file, it gets copied to whatever. I don't know how it works. But basically, a complete GitHub integration in Propeller tool would solve a lot of them OVEX problems, because you can browse there inside of the Propeller tool. That would make sense.
The old C compiler for the Propeller One had that built in. Whenever the smart libraries upgraded, you could just click a button and it would download the update.
Exactly.
Maybe if we had a hook in the Propeller tool to just
do the same.
The same thing.
Yeah.
And you would have a local copy of the current library, and you can update it whenever you want.
Yeah.
And I mean, come on, it's not that big that it doesn't fit on your 1 terabyte, 500 gigabyte hard drive.
I don't know that I don't think JonnyMac uses GitHub, but if everybody that wrote the objects used GitHub or GitLab or one of those could all be just downstream tags in Parallax's GitHub. So anytime you made a change, it would automatically show up there.
Yeah, that's a thing that you could do. You could just load them as submodules into the main repository.
Right.
Well, actually, a submodule, you still have to update the submodule reference to the latest head, and that doesn't actually work.
Right, but if you wrote a module, and they did a pull from your and linked it into theirs, then every time they did a git update or a git pull from their system, it would update everything.
I think you can set it up such that you can refresh all these submodules at once.
Yes.
It doesn't happen automatically. If
you
don't do anything, it will fetch the exact commit that was current when the submodule was last updated.
Yeah, you can set the config file for Git to do that, or you can pass it a command line parameter to do that.
I don't know, submodules are weird.
Yeah.
I think we should, kind of distinguish though between the sort of super users that really know what they're doing, that are writing assembly, and the kind of noobs that are just kind of messing around. And so I think there needs to be some kind of certification of, quality code that at least is in the.
Well, there was two, the GitHub started out, there was two. There was a community library and there was a parallax library. But I think everything's kind of convoluted now and it's all just like in one library.
I think that is there anything in the parallax library? Is there anything there?
No, there's nothing.
Yeah, that's because all the good stuff is in the community stuff. Has anyone played with the OPN2 cog? I'm really proud of that one.
The what?
The OPN2 cog object. It's a sound chip emulator I wrote in. I know. I think I made the object really pretty and easy to use. I hope. I think it's a good example of what an object probably should look like. Has a nice little header bit and nice little descriptions for all the functions.
The problem is that in the old OBEX, everybody who used parallax.com was able to look for an object. The problem with it was it got spammed because the software it was running on you couldn't kind of get the comments kind of under. So it was a big amount of work to keep that thing running. So they decided to stop that OBEX, which was a really nice program, except that it kind of got spammed too much and was too much work. So then they moved to all that drama started with kind of moving to GitHub and moving starting here and nobody in Parallax really knows about. I mean, even Chip is starting now with a version control system and kind of. I mean, you heard himself saying he can't give you a source code because he don't have the last version. I'm using floppy disks,
Oh no, my software has fallen under the desk again. I have to go find it.
Yeah, so the problem is that basically nobody in Parallax really knows how GitHub, I mean, they know basically how GitHub works, but they don't really understand that thing because
I don't think anyone does. I don't.
Yeah, I know.
Maybe Linus Torvalds understands how Git works. Maybe he does.
Well, yeah, I think so. He wrote it.
So there is kind of.
Yeah, but he didn't write all of it, so he probably doesn't understand it either.
Yeah. But in my opinion, Würfel, and that now I'm kind of pushing into. I'm pushing you. You went through the sources of all that bullshit. You know how those compilers kind of search for files to include. Could it not be possible to get some link on a GitHub repository to look at another pack of libraries?
Totally, yes, I get what you mean.
But look at GitHub and if you don't find JM serial because you don't have downloaded it yet, it will kind of find it in GitHub. Isn't it possible to change compilers and you looked at all?
The compiler just asks, basically the code just asks, give me this file, and the compiler has to find it somewhere. And
so
you could totally hook that to search in a Git repository for that particular file. You could even do something that's not really a file name. You could do a reference to a particular commit on a particular file. So that way, if the file changes, it doesn't just magically change your program and things like that.
But Ada, you are maybe able to do that. Chip just started to even use GitHub just because of you, probably because you asked for the source.
Oh, I mess up with Git all the time too.
Even with JonnyMac, I mean, there's been times where I've used one of his modules and asked him a question in the forum, Oh, that's an old version. I fixed that a long time ago. Let me send you a new one.
Yeah.
Big problem with Spin and GitHub is that Propeller tool saves these files as UTF-16.
Right.
Git just fucking hates UTF-16. Yes, the explicative was justified. It hates everything that's not ASCII compatible. So it just usually it will what will it do? I think it just turns it into Mojibake and just displays like weird shit. Sometimes when you don't set it as a binary file, because yeah, the issue is that if you're committing from Windows, I think it by default will try to do line ending conversion. This does not work if your thing isn't at least somewhat ASCII compatible. And in UTF-16, it will then misalign the characters and it will all turn into garbage.
Exactly. Yeah.
So
I gave up.
The big thing that would really help is if the Propeller tool would be able to read UTF-8 and write UTF-8 files. There's no difference in functionality. It just changes the format.
Yeah, what if Delphi from 1980 still can do that? I believe.
I mean, UTF-8 is relatively easy to implement if you don't have to, if you don't want it to work perfectly with like weird edge cases like cut off strings, like where a character is cut off in the middle, or where there's a surrogate pair encoded as UTF-8. So what the fuck is a surrogate pair? A surrogate pair is, and that explicative was not justified. I am sorry. A surrogate pair is because basically they designed UTF-16, right? 65,000 characters, that's enough for everyone. No, it isn't. So they made UTF-32, but that's a different thing. But how do you encode these extra characters that don't fit into the basic multilingual plane, such as the emoji, into UTF-16? Use a surrogate pair. And these are, but if you treat these as individual characters and turn it into UTF-8, you have utter gibberish. These are all the weird edge cases. But I hope we don't have to think about them if we do it properly. I don't think Propeller tool as is does anything with surrogate pairs, because it's all convoluted. The more you think about things like that, the more your brain starts to rot.
You have to watch the history. I mean, that Propeller tool and Peanut developed in somewhere 1919, 1,000 years ago, and they're just working with ASCII. It was a basic.
Oh, the Propeller tool uses UTF.
Originally that thing was a basic stamp, or no, probably even Javelin.
I don't think I've ever had the basic stamp editor.
Working with ASCII, 0 to 2555, and then came up those Windows and all that thing, and they decided they go to UTF-16 because Windows wanted that, and then they did it, and then since then they are sitting there, and but basically it was not planned like that, and basically it just want to have a character set with 250 bytes per. I mean, it doesn't need anything else, And basically,
the compiler internally works on 8-bit characters.
Exactly.
It just translates it into the. Actually, I'm not sure what the Spin 2 compiler does, but the Spin 1 compiler translates it into the same character set that's used for the ROM font, because obvious. That's also what the Parallax terminal uses. FlexSpin actually uses UTF-8 by default, which is funny because if you compile something that's supposed to output something to the screen with the ROM font, it just turns into gibberish because, well, as we say, Mojibake, because all the single byte characters that are supposed to come from the ROM font, like the box drawing stuff, just gets turned into stuff.
Because there is no ROM font there.
No, the ROM font is there, but Flexim by default, Eric added a switch because I asked for it. That makes it do the right thing. By default, use UTF-8 to represent strings, which because it's useful when you're using on a terminal.
Okay. Yeah.
And that actually breaks when you try to compile something that tries to display something on a screen using the ROM font, because the one character that's supposed to come from the ROM font actually turns into like 3 UTF-8 continuation bytes, not 3, like 2, I think, for like a
Yeah, so
like
all
only
those
parallel
diagrams
specific character
doesn't
like an
work
F0
when you
something
don't have-
something.
You don't have the lines and you don't have the diagrams which people took as comments into the source how to wire things. That all gets messed up because there's no propeller font.
I mean, on the propeller itself, it happens when you by default reflects them, because it actually does use UTF-8 internally, which there is no particular extra overhead. That's the nice thing about UTF-8. You don't really have to think about the fact that there's more than 255 characters. You just have to not cut off a string in the middle or something like that. Then it will be angry, but you can detect that error. Unlike something like shift-JIS, which is the old Japanese encoding, that is terrible because it uses the regular ASCII characters and some of the other single byte characters as continuation bytes for the multi-byte characters. So if you're searching for like an E, it will find a match in the middle of a multi-byte character that just has that as a continuation byte. It's like really stupid. But it has the nice advantage that all the wide characters are 2 bytes and all the narrow characters are 1 byte. That was at one point maybe an advantage. Like if you're using a monospace font. That is the one advantage that it has. It's terrible otherwise, which is why no one uses it anymore, except they do still, because people still use the like 255 character ANSI code pages because Windows still does that as default. So you never know where the stupid old shit shows up.
When we kept, I mean, okay, source code should be except the UTF-8 also, but if I don't know, input output should just run in ASCII bytes.
Yeah, probably. I mean, UTF-8 is basically ASCII. As I said, you don't have to think about UTF-8. You don't have these issues, as I said, with shift-JIS, where if you search for an E in the string, it will find you half of a kanji. It doesn't have that issue because all the continuation bytes are in like the above 128, and all the normal bytes are below. All the ASCII characters are as they are, so that doesn't cause the issue.
Yeah, so Chip, the only thing is that you need to read UTF-8 also instead of just UTF-16 and use it as ASCII, sort of.
Hey, what about, you know, to solve this OBEX problem, perhaps we could do something, I mean, maybe the backend could be, or maybe the stuff could be stored on GitHub, but maybe we need like a publicly accessible, something like a Google Sheet to organize everything at a high level.
I mean, I have something like that. It's not a Google Sheet. It's like a thing where all the little propeller things I've written or am writing are listed out. You may have seen it in my forum signature. I kind of have something like that. You think something like that, but like as a Google Doc where you can just put stuff.
Yeah, where people can, you know, there needs to be like a description, maybe a little field about resource requirements of the chip. And then there needs to be some link to where it is. And then there needs to be maybe some kind of rating system. So that you could you know, you could then like, what do you call, sort it by a number of different criteria. So if you're looking for some type of function, you want to do a search, or you're looking for the best rated objects, whatever.
But who rates the objects? I don't think we have enough people that would actually rate the objects for that to be a meaningful metric.
Yeah, well, maybe not at the moment, but
well, that's where I think that we need to have sort of like an oligarchy of super users that I know that Parallax doesn't have the staff to do this or the bandwidth and the staff to do it independently, and that's kind of why we got rid of the OBEX to begin with. But I think just having a couple forum friendly, people that are knowing what they're doing, that can,
Does
quickly,
this object suck or does this object slap? That is the question.
or does it stand up to the standards that we're trying to put on the public front, that
Right.
really helps to show people that this chip is ready for prime time, and we're competing with the Arduino, and the Arduino just makes things super easy, at least with their standard libraries. So we really got to come up with that core that just makes it right off the bat, people don't get frustrated.
Yeah, we should have just, can we just go through all the Arduino standard libraries and figure out an equivalent?
I think that
an equivalent is there. I mean, we have the
fantastic,
full duplex
yeah.
serial, we have the SPI object. I think do we have one for P2? I don't know. We have one for P1. I think the P1 mostly does that with the default library. I don't think I've ever installed the P2 propeller tool default library because I think it would mess it up, but I don't think it does. It's really confusing having multiple versions of propeller tool installed, because the new propeller tool has some bugs that the old propeller tool doesn't have. And the new propeller tool, of course, has the P2 support, and it's all very confusing.
Yeah. So one thing I'd worked on a little bit, I haven't really touched this in a while, but this is going to be an appendix in my book, that is to have I'm going to share the screen real quick. Kind of a cheat sheet for people that are transitioning from the Arduino to the propeller, or from the propeller 1 to the propeller 2. And so this is kind of a quick kind of overview of everything that you'd expect on an Arduino versus how it works on the propeller chip, just to kind of show that we can do all the same stuff plus extra things, of course, with smart pins and parallel processing. So just kind of help people transition between the Arduino C language and spin. So again, I'm going to polish this up, and this will be part of the book, but I'll probably get it as a separate document.
That's totally a good idea.
Yeah, so I've been working on this. There's also somebody on the forum probably 6 months ago that had worked out something not with a table like this, but it kind of helped to explain how to transition from an Arduino to a propeller. So something like this I think would be helpful. So I'm working on it.
That's cool. Yeah,
I might have some questions for you, Chip, before this is officially published, but yeah.
Super. Yeah, I also think if we can make the tools so that they give you a visual of like your resource utilization, that's always helpful, because it's really always good to know like where the boundaries are, so you can kind of, because that gives confidence, and then that certitude makes things work better.
Yep.
Carol, are you still there?
Yes, sir. I'm still here.
You're the guy that makes all the you use the plot to make the diagram of the chip, right?
Yes, sir.
Okay, I thought it was you, but anyway, this mouse thing, did you hear our discussion on that?
Yep.
Okay, so you could make those things completely like two-way.
What do you mean by two-way?
So that you could actually, if you wanted to that smart pin thing you had?
Yep.
You could actually make it configurable in the window. Because now you'll be able to build a GUI if you want.
Yeah.
So that when you click on a pin, you'll know the guy clicked on a pin, and you can bring up another like sub window in that frame, a little drawing of like what's there, and make it configurable. And
that's my plan. That's my project I'm working on.
Yeah.
Yes, but see, I plan on using an encoder. Spin the encoder, and as you spin the encoder, the pins light up.
Oh, yeah.
If you have the one you won't, then you push the button on the encoder, and then it brings that window up so that you can configure that pin.
Yeah, I see. Okay, so that's more like real, like aerospace instrumentation.
Exactly. It's kind of like the same type of Twizzler that the Orion uses for navigating their displays.
Right. Okay, that makes sense. Yeah.
But having a mouse would be pretty interesting. I'd like to prototype with that, see how that works out.
Yeah, it'd be good for that, I think.
Yeah, I flipped those cogs around, the direction of those cogs like you recommended, and started them at the 11 o'clock position. And it took me a whole 2 minutes to do based on the way I've coded it.
Oh, good. Good.
Yeah, but
That's good.
that was my intention, was to be able to navigate to a pin, press a button, bring up another window that shows, I was trying to show how the pin was configured, but you can't do that. So basically what I'll probably have to do is clear all the pins and then configure a pin. And then it'll show the registers that you can see coming back from the pin, shows the data coming into that pin. So that was, and I was even thinking that maybe if it was like reading like analog data, like you could even throw up a third window, which would be the plot of the data coming into that pin.
Oh, yeah. Yeah, that could all be done.
Yep.
I mean, I could add that mouse feedback into the scope window as well. You know, I mean, you could actually like use the scope, but make it like you could effectively create the knobs that are on the front of a normal scope, but without being knobs, but you know, have some kind of thing that you can touch.
Yeah.
Yeah, it should, but a lot of stuff should be possible. It's one of those things where it's not hard, it's almost working, but what could be done with it could go on and on.
Well, you could have knobs. What you could do is with that optical encoder, as you press the button, it would move from knob to knob to knob. And once you had the knob you wanted, then you could twist the encoder and you could actually dial in that particular dial, that knob. So yeah, you could do that. Got that window up. If there's anybody that hasn't seen it, if they want to take a look at it, I can
Yeah,
throw
show it.
Okay, let me
Were you here last week, Gavin?
No, I had a sick cat that I had to put down, so I could last second come again.
Oh.
Yeah.
So let me see if I can bring it up. Let's see.
Carol's made this pretty cool, like, you'll see.
So do you see my screen now?
Oh, wait, no, I don't. Hold on. I'm not sharing. So you should be able to say share screen.
Oh, that's right. You have to share on this thing. So now do you see my window?
Yes.
So this, I was working on some Inkscape stuff. So let me put that away. So here it is right here. And I'll restart it.
Yeah, so he used the plot window to build this whole thing.
Yeah, I mean, it'll get going. So I've got it going from pin to pin to pin as quick as it can. And then when it hits a pin, if it hits like V0003, then it shows all the pins that's on that rail. That's why it keeps blinking red. Let me slow it down so it's a little bit slower. Hang on a second. Let's see, delay. It'll be a little bit slower this time before it gets started. So you see now it's basically just calling a pin number. And when it calls a pin number, that pin number is highlighted in yellow. When it hits like a V247, it'll highlight in red all of the pins that are on that particular power rail.
Oh, yeah.
And then when it hits a VDD, it'll show all the VDDs that's on that power rail. That's why when you hit certain pins light up in red. And this is something else I didn't show. And also these are the cogs. So you see I reverse the order of the cogs. And then I put the 0 at 11 o'clock, like you recommended. And there's one other thing I didn't show last week is, let me do this. It's actually scalable. So by changing the font that you want, you can rescale it to different sizes.
Oh, nice.
So.
And it's redrawing the entire screen every time from scratch. Is that right?
Yep. Every time you see a pin, it advances on a pin, it's redrawn the entire screen.
Yeah, it can do that really quickly at 2 megabaud, and then it doesn't take too much data to drive all that.
Yeah. Now see, right now I've slowed it down so you could see what pin it's on. If I get rid of the delay, then it'll redraw as fast as it can. It's got different modes. In the lower left corner, you see it's going through different modes of showing pins, different ways. So this is it drawing as fast as it can. And I'm still amazed, it's still rock solid. And every now and then you'll see a funny artifact. It'll throw one of the labels will get larger, really big. And so I think it's just an artifact of, the delay or the speed or whatever.
I wonder, yeah, there must be some maybe data error occurring or something.
Yeah, at least 2 megabytes. There's just line errors occasionally.
Yeah, every now and then you'll see them, but it's very rare. One just happened a few minutes ago. So, and what I plan to do with the cogs is I want to actually be able to press a cog and then select a tiny application to put into the cog, and it'll bring a list of different applications, and then you select the application and it'll put itself into the cog, and then it'll start it up. So anyway, that's my plan.
Looks good.
Last Friday, I was going to finish it up, and I was going to put the code online so that people could take a look at the code and play with it themselves. But we got called Friday afternoon and told that they wanted to give a demonstration to the Gateway Program Manager at NASA, and they wanted to use our laptop interface in the actual we call it a GSVL. It's a Gateway Software Verification Laboratory, and they have the actual hardware they're going to be running on the Gateway, and we're building the user interface for the flight software. And they go, we'd like to have your GPC in this demonstration for the program manager. So I've been scrambling for several days, getting that integrated into their system over there. And I missed JonnyMac's demo this afternoon, and it just about killed me because I just got home about 6 o'clock from NASA. So, but what I'll do this Friday, I think I'll have enough time. This Friday, I'm going to take this code right here and I'm going to put it on the forum so that people can take a look at it and use it if they want to use it. So anyway, I'll let it go now.
Looks good.
Yeah, that's awesome. Thanks for sharing.
You're welcome. Let me see if I can quit. Here we go, right there. All right.
I wonder, there are always finite resources, and if you know the boundaries, you can use things kind of to their limit. So like my first blush would be to do that where you have like the cogs, in some kind of arrangement. But then they can be operated that way, but there's another way of looking at it too, which is just like a pool, that can be randomly assigned as needed, and then they can relinquish. And so it's like puts bungee cords between everything now. Things don't have to be in solid places anymore. They can move around. It's kind of, I don't know, challenging to figure out how to like represent this stuff and keep it represented in a way where it's easy to understand, but it's also apparently fluid. Like, you don't even really need to load a program into a cog. You could launch a cog and have it run straight out of hub memory, with whatever data it had in its registers to begin with, or from whatever it was shut down with last time. There's all kinds of weird things that you could do, but I think if we could like somehow find a way to present that so that people get it at all times, then it would be really effective.
I'm not sure I'm following right now. So you have code that will fit into a cog. You're saying something about running right out of hub. So,
well, just that it's, okay, you've put the 8 cogs in a circle, right? And I've got to come up with some kind of way to show the single step debugging potentially for 8 concurrent windows. And so there's all these challenges about how to represent stuff and still, without making it look too staid, like inflexible. Like as soon as we put things down, like things start to, the supposition is that, oh, well, that's always going to be right there, but it's like interchangeable. Those cogs are like all interchangeable parts. You could use them to varying degrees. And so I'm just thinking about having tools that somehow like show the person what's there with it like shows the constraints, like the limitations, but not the possible permutation, but still allows for like many permutations, you know, so they don't think that, oh, one thing is always in this place, another thing is always in that place. Because in order to think about things and use things really flexibly, you have to like have a dynamic model of what it is that you're working with. But always it's like the first blush is always to make something that looks kind of static. Like I'm just thinking about how you have the 8 cogs there, you know, they're more like in a pool that can be like drawn upon, and then they can release themselves or they can get shut down. But they're kind of like, they almost could be like represented, like a 2D picture can't quite do it, but 2D with motion could, where maybe you show them like always slowly moving. You know, like Apple phones these days, they take pictures that show like half a second of movement. So it seems like the picture is kind of alive.
Right.
It's like, we almost need tools like that to show that, no, this thing is not tied down here. You know, it's because usually the way things get represented, there's an assumption because they're in a certain place that that's just how they are, and you have to think about it that way. But it's just challenging to come up with notions of how to convey that these things are all like living. You know, they can move around, do different things at different times. I'm just trying to
That's
think
really
this-
how I don't think I've ever seen a propeller program that really has really actually uses cockstop. I don't think like I've seen
No.
it, of course, but like 90% of the programs I see, which to be honest, that's a bit
it's
of a
probably
slanted
the
thing.
rudest instruction.
Never
Well,
uses cockstop.
That's why I like the video game is for teaching students how to make spin click for them. Is so that we use cog stop and start all the time with their, you know, this is just something quickly I'm pulling up. If they want to, for example, if they're doing just a simple Mario demo and they want to have a Goomba moving at a certain speed with certain weight counts between it, and you know Mario running and changing the picture so it looks like he's running at a reasonable speed. You know, you might want to have extra cogs doing something like, you know, swapping out the pictures of his legs moving, or if you have a fireball, you might
As an
want
actual
to
game developer, I cringe.
yeah, you might want to, you know, start it up and then you have it, once it hits the Goomba, you know, turn off that cog. So it's an easy way but again, this isn't about video game programming. I'm trying to teach students how to think in terms of parallel processing.
Yeah, that's it works for that, but I just say that as someone who programs games, I cringe because in game programming you usually have one big loop that just visits
Yes.
everything at once.
But then you have to, you know, break up everything into, you know, timing of a fraction of the overall loop or a multiple of the overall loop. If
Yeah,
you
you
want
have
to have
to
things slow down.
think about individual time steps.
Yes, which you can still do in this, of course, but instantly the parallel processing just makes that trivial if you just, you know, have global variables changing on different cogs and only being updated in the main loop.
Well, in that case,
So-
you get issues with race conditions, where basically, depending on weird external factors, two things might try to do a thing at the same time.
But the only
And then-
one cog can change the global variable at one time. So
Yeah, and it kind of gets this race condition, which one goes first.
well, then they learn about race conditions. So it's, you know, it's a learning experience, but because it's a video game, it's fun. So that's why I'm using the video game and not having them do something else, you know, more academic. But it's a really quick way right off the bat to have the students kind of explore parallel processing and master spin 2, you know, all the same.
As a parallel processing example, I think that works. Yeah.
Yeah.
Think about each object kind of as its own entity that it just lives in this world. That kind of, and just ignore the fact that there must be some sort of time step for refreshing the display, but I don't know. The object doesn't need to know technically.
Right. So the application that I like to use the propellers with is mechatronics or robotics. So when you start having, you know, humans in the loop with, you know, computers doing their control algorithms and stuff, you have different scales of time happening all at once where, you know, you might want to have, you know, a cog wait for, you know, a couple of seconds for a human to hit a button, or, you know, debalance that button for a couple of milliseconds, where you don't want to have everything else slow down as a result of that. So that's where, you know, the kind of temporal multiplexing is useful with the parallel processing.
Well, something I've been thinking about is that in many of these cases where you're like waiting a second or something, there should be some sort of easy way of doing preemptive multitasking inside one cog, because you often have these multiple tasks that just don't really have to happen with like precision timing and don't really need all that much processing power. They just need to wait a lot. So it'd be good if you have like if you had like a thread start instruction, which would then just set up like the interrupts and everything such that
yeah, Ada, I had
kind of
that all,
do like virtual cogs.
yeah, I had that all figured out. We could do that in Spin just by setting up different stack frames for each process. And then on an interrupt, actually do a complete context switch to like a round robin of contexts.
Exactly. Then just add up a little bit of quote unquote magic to so you could have a thread just wait. We don't have to context switch to it if it's just waiting on a thing, and that a bit. But oh, and of course you might want to insert one with a higher priority. Not sure how necessary that actually is, but I think that's a bit
Yeah,
boring.
it gets into lots of like how to organize it. It's
a simple round robin thing would just work for a lot of things where you don't really need an entire cog to just wait for seconds at a time. That's just wasteful.
Yeah, the BOS was really good at that. The BOS had an excellent preemptive multitasking operating system. I used to love the way it worked.
I mean, alternatively, you could also make it so that as an alternative to preemptive, you could also just have a yield keyword that would do the context switch without an interrupt. Because in some cases you do have a little bit that needs to have precise timing, and when there's an interrupt in the middle, it will make it blow up. But the other task just doesn't really care. So I think there's a lot of cases where that would be useful too, if you could do without an interrupt, just with like an explicit instruction.
But that's after you've maxed out all the 8 cogs, because if you've still got extra cogs, couldn't you just offload that to another processor? I mean, that's how I look at interrupts too. I mean, interrupts are great, but I don't, you know, there are very few occasions where I'm using all 8 cogs now that we have smart pins.
I don't know. I always use all the cogs. I rarely don't use all the cogs, unless it's like I'm like building one thing. Pretty much everything that I did with that's like quote unquote finished and not just a part of something larger, it always uses all the cogs.
Okay, how about all the pins? You used all 64 pins yet?
I don't, but then again, most of the things I write, they need exactly like 8 pins, 2 for the like USB, maybe 2 for the audio and 4 for the video.
So again, that's why this chip is unique, is this chip kind of creates a bridge between the computer world and the real world. And so I'm more focused on the real world. You've got a specialty in the computer world, but it's meant to make that bridge between the two. So that's,
yeah, I could totally just add some hardware onto it and control that directly. That is kind of interesting. Like I could just press a button on the keyboard and something happens on the screen, but then also something happens in the real world. That's like something that is really good at. I don't have any good use cases for that. Well, actually, I thought about. I occasionally think about like cool microcontroller projects that I'll never do because I'm lazy. And I always think, how can I do this with Propeller? And a lot of the time, that actually ends up being the most natural solution to the microcontroller issue. Is to do it in some sort of threaded way with multiple cogs. I.e. not use half the chip just to render the screen display. That's what what usually happens with me. Like half the chips just renders the screen. That's what you do when you don't have anything else to do.
You know what would be cool if, I mean, I thought about this, but I didn't get to implement it because I was always thinking I had something else to do. But would there be like, you know, in your video game scenario for teaching kids, could you imagine if they could write like some code, but have many instances? See, if you have multiple processes or even little virtual processes going on concurrently, you don't have to have your code be very stateful, right? Because it's switching contexts instead of switching what state am I in. So I wonder if it would be good to for a lot of non-playable character type little things that are moving around on the screen, if you could write like one program to define one non-playable character, but then make many instances of that so that they run concurrently. That might be kind of cool. And they can use random numbers to generate different behaviors. But see, then you don't have to cycle through, because the other way you have to do it is you have to go, gee, what variables do we need for each character? And then you got to come with that. Then you got to make an array, and then you step through the array and process each one, and you loop. But that's like getting away from thinking about what the NPC has to do. And right, it becomes more of an implementation problem. But if you have if you can switch context to I just have one set of variables and it's for this NPC, and it's for any NPC. And I manipulate those, draw stuff, send out sprites, whatever. And my program just loops. But the thing is, there's maybe 30 programs, 30 instances of that are looping in their own little stack frames, so they each have their own way, so that you get to write one program in the obvious way to write a program, but then you get many, many instances of it, each doing something unique based on either input or randomness or something. Does that make sense?
Yeah, it does. That's cool.
So you mean one thread per object? Yeah, that's only something you can do. I mean,
then you get to write the
I find
program
the
once.
time step method kind of, I always think in terms of time steps, because that's how I usually write stuff. And in some cases, that's really unnatural, because you have to keep track of a lot of states, especially when there's something that's a little bit more stateful. Some things are very natural in time step to think about in a time step way. Some things are very natural to think about in a more stateful way, which the thread would be kind of ideal for. But some things just kind of need both in some sense, because you have something that needs to happen every time step. Like we need to check, have we received a hit or something? That needs to be checked every time step, but you also have something larger that's going on, like move to this location. And it has to figure out how to get there, and that's kind of like moving from one tile to the next tile on the screen, and then that individually has to be spread out over multiple frames, because that has an animation to it, right? So that's basically, that's actually a really complex kind of thing to think about. Some of the most complex programming that doesn't have to do with maths, I think.
Yeah, well, but the thing is, you got to the whole point is minimizing the effort for the person, right? Let him think in the simplest context possible. And then through some kind of preemptive multitasking or whatever, you can then switch the context. He doesn't even know it. All he knows is I write this program and I'm running 30 of them at once. But all I had to do was write this little program. And you could even set it up so that like what Carol was saying about the OS, you fire it off and that thing runs through what it amounts to an iteration. And then it gives some command to say, I'm done. And then it goes back into it frees up that thread in the pool that can be then, allocated to some other instance at some other time based on some other circumstance. But the point is, though, that you keep the coding as simple and as local as possible without ever worrying about scanning through arrays of stuff. And then, because everything that turns into implementation effort, it takes away from the thinking effort, or what it really elementally takes to make happen.
I mean, that's what happens when I code. My funny game I've shown it a bunch of times. I always write in assembly, and I think I've written a lot of different. I've written the same code a lot of time that scans through the object list. Stupidly, it's actually a fixed list of 32 objects. If I were to write it from scratch, I'd make it a linked list that with an allocator, but I'm too lazy to rewrite everything, so it's a fixed list of 32. To scan for something, so some sort of criteria. I've written that code 10 times at least, because I can't reuse it because of assembly language. It's always different registers that are free, always different things. So I think I get what you mean. If it takes a lot of time, if it takes a lot of effort to do something as simple as find me the objects that are in this range, it's kind of fatiguing to try things out.
It kills creativity because everything requires pushing 1,000 pounds around, where you just want to push an ounce here and there.
Yeah, so basically you either have to spend a lot of time or have a good idea to begin with.
Yeah. I thought of something else, but now it went out of my brain. Maybe it'll come to me, but there's something about these things.
Mind you, a Fortnite. I have like, oh god, I need to show this. This is so cursed. This is the most utterly cursed piece of code you'll ever see. I think I've said that already, but this time it's true. Let's enable.
Hey, pay attention, Michael. This is going to be worse than my code.
Problem is Zoom kind of crashed. So. Zoom kind of crashed my desktop compositor. I don't know if the screen sharing will work. I have no idea why, but my desktop compositor has crashed. And oh, are you seeing a VS Code window?
Yes. Yes.
Let's just remove all the clutter and make it a bit bigger. That's a bit too big. So you can't actually read. This is sorry for the microphone bump. This is called obg_check collision_macro. Check out all the parameters to this.
Yeah, I remember what I was going to say, and it applies to this. See, eventually, in order to simplify things, it has to go down to the hardware level where you have things like content addressable memories, where you say, here's the data, you tell me the address. It's like a giant.
Yeah. You mean like a hash table?
It could be, yeah, I guess that'd be a way to do it too. But CAM in hardware works in like 1 or 2 clocks, at a gigahertz. So it very quickly.
You mean like the sort of thing that they use for caches, for like multi-way caches?
But do you know what a content addressable memory is? It's like it's like a reverse memory where rather than you give the address and it gives you the data, you say, here's my data. What have you got for an address? So that's the way to check, because what happens is you have to, the idea here is you got to check many, many things in parallel, right? So, but you have to do them serially in this case.
I mean, this here is just cursed because there's a lot of different things that you may need to check for, you may not need to check for.
Yeah.
This is just this doesn't even do a lot of iteration except for the does it even have object collision? I don't think it has object collision in there yet. This is just different cases. Are we colliding with the edge of the area? That's this bit here. If you don't need it, we don't need to compile it. Do we need to check collision against the map geometry? That's this enormous block of code. It actually compiles down to very little code, but that's because there's all these conditions that just compile in what's necessary, and that's why this is so cursed. For example, there's something called the flyover bit, which for each, it's kind of complicated to explain how it works. The map is made out of 16 by 16 tiles. Each is then further split into 4 8 by 8 regions that can either be solid or not solid. And then the entire 16 by 16 region has a bit that can tell you if you can fly over it. Like, is it something that's just on the ground, an obstacle, or is it a wall, basically? And then there's also something very cool called special, which is basically a nibble in the tile data that tells it what kind of special tile it is. And the higher numbered special tiles, you can't walk on them, but they're not solid. And for example, they're water, and that needs to be specially handled by the player ticker, which is basically the time step update function. I call it ticker for some reason. because each tick it gets called. But if you're something that does not have particular context for interacting with water or like gaps, you probably just want to collide with them, right? That's what this special threshold here does. And again, this is all the unrolled macro code. This is so cursed. And there's things like, for some things like this, we need a Z flag, right? But sometimes we don't, sometimes we don't. And we don't want to generate the code to save and restore the Z flag when we don't need it, right? Well, that's what this cursed thing here is. Basically, if any of the features that require the Z flag are enabled, we set the Z clobber variable. We set the Z clobber variable, and we unset it if we don't care about the Z flag, which is also a parameter. If we might just not care, and then we can save the code that would do that. And based on that, we have the very end here, I think. Maybe. Here we go. That will restore that from R0. Now R0 is actually double used. Both to the top bits used to store the Z flag, but its bottom 9 bits are used to store the collision reason, which you may not actually care about. So that's another micro parameter. So you can morph as it's into there. And then just mask off what you don't need. Again, this is utterly cursed. It gets instantiated like 50 times with different parameters. It is utterly cursed.
But it's like a one size fits all that tailors itself to the need, right?
Yeah, that's I mean, this is powerful macro assembler, and by powerful macro assembler, I mean it's a Ruby interpreter where I've defined methods called add and ifc and cmp sub and such. And that's why I can do things like, for example, here I have this anon exclamation mark function, which will give me a label as a value that I can assign to a variable, to a macro variable. So I can have a label as a variable, which is kind of like not a location pointed to by a label itself. Well, not really a label at that point. At that point, just a symbol, like a name for a label. And then I can create it somewhere, like here. It says local no-map label. There's this anonymous label that has been generated up here. As I say, massively cursed if you if you aren't familiar with all of this, which you are not, because the only person familiar with this is speaking right now, because I wrote all of this, and I don't know. I think I'm going crazy talking about it. It's like my personal hell.
Well, you've done a lot of work. I mean, you wrote some kind of thing where you can. This is generating P2 assembly language.
This is generating P1 assembly, yeah. But it
P1
also
P1 assembly.
Yeah. But it also, I think I've explained this before. It can run on P2. Basically, it encodes it into a different format that is neither P1 assembly nor P2 assembly. It's some sort of, but it's something that the P2 can easily take apart and then interpret. But it's equivalent to the P1 assembly.
Right.
But executing actual P1 assembly instructions would be too difficult because the fields are all over the place. Whereas in the format that I use, it's all very obvious. And then it just kind of does the execf and the skip patterns. It's kind of complicated. And I think I've already shown that this can also translate this assembly source into C++, which is even more cursed. Again,
maybe you're a masochist.
No, not really. Oh God, I am reminded of something stupid. No, I'm not going to talk about it. This is too much brain rot for you to handle. It's nothing bad. It's just my brain rot. I watch too much stupid stuff on YouTube, and now everything.
Oh, well, I think I do too. I suppose
everything now has a stupid association with some sort of silly meme that like no one will know. and I like think it in my head, and they're like, ha 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 ha, everyone will get it. And no one thinks the same way I do. Because
yeah, isn't that interesting? This thing about memes, I don't know if it really existed, but now they get created and they become like these little encapsulations of like stances and ideas, and it's like more memorable than sound or language, and more like impactful.
I mean, what is a meme? It's a concept, really, more like, what is it? Well, I guess sounds can be memes.
Yeah.
You know, the ding 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 ding. No, you don't. But I think if some people were to hear this, probably with the right pitches, because I'm terrible, they would have screamed the word "sus," and I don't know, exploded. That's how people react to hearing things. Or like, oh yes, the trumpet, the MIDI trumpet. What's it called? Romantic TP. It's this really fat trumpet sound. It's like over the top. It's a bit of a meme.
Man.
Or
Hey,
like
guys,
the
it is almost 7. You guys have anything else you need to do?
I want to throw up one picture if I can for grins, if you don't mind.
Absolutely, go ahead.
And this picture illustrates how I want to eventually program. Let me throw it up here. This is the programming tool I want. That's how I want to eventually program, Chip.
Okay, I'm kind of there.
Yeah, I keep coming back to this and looking at this. If you notice in a lot of these, there's 8 little pins in here. And I'm thinking, well, those are cogs. Those are 8 little cogs. And that cog is running this code, and this cog is running this code. And it's all symbolic coding is what it is. And I'll eventually get there.
Oh, is this really a representation of some kind of program?
It's supposed to be. It's
Well,
supposed to be an alien method of programming.
Oh.
What they call what do they call it? They called it I don't remember. It was like self-awareness programming or self-activated software or something like that. It was supposedly pictures that came out of a research lab in New Mexico.
That's very vectory. I kind of like it.
I like it too. I would like to be able to figure out how to program like this. It's all symbolic. Anyway,
ever heard of like node programming? Like you do it with like that's how you do shaders these days when you don't like typing. You basically just have these nodes and you drag little connections between them, and it makes a shader program in the back end.
Yep, that's kind of what I understand. It's like it's on a piece of hardware. The hardware is the computer, and by dragging these nodes around and reorganizing them, you actually reprogram the computer that they're sitting on top of. It's like having an e-ink display directly attached to your hardware. So I thought it was kind of cool.
Yeah, that is. And that's still 2D. I mean, the whole 3D thing is largely unexplored. How to represent code. And I mean, 3D for the purposes of encapsulation is really cool. I mean, you could even just do 2.5D, and have planes that are stacked. I don't know, that's kind of what Windows winds up being, but that just gives us a headache. But something that you could easily navigate and get into the boxes inside of the boxes, but still have maybe whole other viewpoints on too, so that you could, what looks like something constrained and has a certain shape in one perspective, from another perspective, and I don't mean moving around it and looking at it from another angle, but I mean like changing the qualitative things that you're observing. You could, like, there are tools sometimes for code that let you do that, like profiling tools, give you some kind of weird views on your code that no other tool could give you. But it'd be neat to, I'm sure stuff like this exists. It's just not maybe widely thought about or used, but.
I mean, I think there was at one point a tool that let you, and it'd probably be easy to write from that, basically colors in your source code. The redder it is, the more time it takes in the profiler. So.
Oh yeah. Yes. Well, I thought what we could do for the single step debugger is, well, by doing a thing where we ping, we just do random interrupts, breakpoint interrupts from another cog. We could kind of, it's like what's that called? Monte
it's like
Carlo.
stochastically sampling the execution position.
Yeah,
That's
it's like
something-
Monte Carlo simulation where you just kind of pepper it, and over time you build
that's
up
the thing.
a
That's the
map.
thing. The good thing about that is that you don't need to instrument the code at all, and it doesn't really slow down either.
Yeah.
Like you can do this in, oh god, have you ever used JVisual VM? Probably not. It's the sort of profiling tool that comes with Java, and that has a profiler in it. But when you click it, it takes forever to load, and everything slows down. But there's also a sampler tool which basically just randomly stops the program at some point and looks where it is, and that works.
Yeah, you could build like
that
a
works
heat
basically
map of
just
your
as well.
code. The
Problem
trouble
is
is,
if you sometimes don't catch everything, but that's fine. I think it's mostly accurate to what the actual profiler says. In some cases, more accurate, because sometimes a tiny function, the overhead to log, oh, I've executed this in the profiler and it took this long, it takes way longer than the actual function.
Yeah. The only problem with our chip is that repeat blocks cannot be interrupted even in debug. So, people are probably, if they're writing that kind of code, they might be spending a lot of time in very tight repeat blocks. But that's kind of esoteric only for assembly programmers.
Yeah, but why? Not necessarily. FlexSpin can generate repeat loops.
Yeah,
it totally does.
implement them automatically.
So I guess you could probably add like an interrupt safe flag that will disable them, but then your code gets bigger and timing changes.
Well, but like that rep instruction, that can't be broken into because there's too much state stuff that would have to be stored and restored. And so you can't interrupt those. They didn't make it that way. So those would be impervious to the shotgun. Otherwise, you get like a Geiger counter, just randomly fire breakpoint interrupts at another cog and look at where its program counter was. And over time, it'll build a picture like a heat map of where it's spending most of the time.
I mean, even if you're wrapping, it will do the interrupt after it's done, right? So you just get a really hot line on the first instruction after that loop.
Oh, yes. That would probably work, wouldn't it? Let me think though, if you
and that is of course the line that is labeled with the end label for that repeat. So you can just say that entire repeat takes this long.
Yeah, that's cool. That would probably you'd know that if you had a really hot line after the thing, that's right, because it would stop there afterwards. Yeah, I'll have to look at that code and just kind of do a little reality check on what it's doing.
Also relating to the task switching thing, can you save the Cortex state? Because I'm thinking, not the pipeline state. The pipeline with pipelining it gets complicated, but I'm thinking if I do a queue rotate with 2 given values and the angle is 0, do these values come out exactly the same? I could just test that, but I'm just asking you right now.
Yeah, well, you could, but you know what? What I do in the spin interpreter is I protect all Cortex operations from interrupt by putting them in a repeat block, which is something I think one of the Australian guys figured out how to do. And so
yeah, that's a cool thing.
And it takes only one instruction, not a stall eye and allow eye. It's just one repeat instruction, and you put your Cortex operation in there, so it protects it. So for doing like a preemptive multitasking switch in spin 2, it'd be no problem.
Yeah, okay, but I'm thinking I'm pretty sure you could interrupt in the middle of that thing. but you just would have to check, is there a chaotic operation going right now? If yes, save the results. And when we're done,
Well-
if you rotate with angle 0 and these two results that we got, that they come out exactly the same.
You don't
So the program
really
doesn't
know.
notice that that happens.
You'd have to wait until and see if anything popped out of the pipe. It'd be kind of a pain. It'd be better.
Isn't
to
there
just
an event
protect
flag for that? Like a chaotic empty event flag, like you check the result and there was none,
Mhm.
something like that. I don't know. I
Let's
just
see
thought about
here.
that one day and didn't really think it through. I probably should have tested it, but I don't know. I'm lazy. You know how it is.
Yeah.
Yeah, I'm gonna have to drop off, Chip. I looked at my clock a few minutes ago and it was 7 o'clock and I just glanced over and it's 9 o'clock. 2 hours have just flown by, man.
Yeah. This is 6 hours now. We should get off this thing in a minute anyway, but okay, Carol, thanks for coming today.
Yes, sir. Thank you for the information. It's always very beneficial to listen to you guys talk about your stuff.
Likewise.
Speaking of the chaotic, there's one design choice that always baffled me. I have to ask it now. Why is the cumul unsigned? It always annoys me when I think about it in my
Why
sleep.
is the what?
Why is the cumul unsigned?
Oh, because I figured it was more important to be able to do full 32-bit operations unsigned than it was to do this, to not be able to do them, because we need to be able to ratio things like NCO values, and that's all kind of unsigned, full 32-bit stuff. And so you can add a little code to do signed operations, but if we made it signed, not only would it take a lot more transistors or gates, but we wouldn't be able to get that full-blown 32-bit unsigned behavior out of it, which I think was most important.
Yeah, the one thing that always annoys me is, of course, if you're just doing 32-bit integers, the lower half of the result is, it doesn't care if you're doing a signed or unsigned operation. But if you're doing fixed point multiplication, you suddenly have to grab like the middle 32-bit.
Oh yeah, yeah.
And that's like really obnoxious. You have to first figure out the result sign, then you have to queue up the operation, and then when the operation is done, you have to get both results and like shift them around so they so you get the actual results. And you can't really pipeline that very well. You can't fit it into the 8 cycles. You have to go with 16.
Right.
So you're wasting half the shots, kind of. It's a bit obnoxious. It's something that I've noticed.
Let's see here. Break event. Oh, okay. So I wonder. I'm trying to just look at my code here and see if I've made the break event stateful. Let's see. Okay, so I got to just look, where does break event go to? That's the big whopper here.
Oh, looking pretty funny Verilog code.
What's that?
If you're looking through the funny Verilog code.
Yeah, here, I'll show you.
Oh yeah, that's always funny. If you have to trace like one signal that goes through like 50 different lines, that's.
Wait a minute, is that, do you see me highlighting stuff?
Oh yes, I do.
Okay.
License upgrade required.
Where do you see that?
In the title.
Oh, at the top. Oh, really? Huh, okay.
It's
So,
like an activate Windows in the corner and an unregistered Hypercam 2 at the top, and it'll be perfect.
so let's see. See, here's where the asynchronous break comes in, and it has to be enabled, right? It's kind of like your code, except it just resolves to hardware and takes a nanosecond. And okay, so break event, what does break event get used for? Okay, it goes there, int signal. Okay, so let's look for int signal. SIGNL, I think it was. Oh wait, was it? There it is. So hopefully this gets latched somewhere. Yeah, it looks like it does. int signal, and yep, here, this is a, or wait, is this not? No. Okay, now this makes, okay, this creates this, which goes here, which goes into this flop. So it is stored. Okay, yeah, that's how it would have to be. So yeah, it should show the first, if we do an asynchronous break, it should show the first instruction really hot from where it was spending a lot of time before. First instruction afterwards. All right. Okay.
I mean, thinking about it, it's always offset by one instruction, isn't it? Because you can never break during the instruction.
Right,
you can
right.
only break the next instruction after.
Well, and there's a pipeline too, you know, so you have to, like, the way the interrupt works is it actually, like, some instruction wants to go into the pipeline, and when the condition's right, it says, nope, you're not going in. I'm dropping this call into the instruction. It's like a call D, and that goes into the, I mean, I drop that into the pipeline. So you hold off what was going to go in and you drop in a call D instruction, and that's how the interrupt happens. It's actually a call that gets inserted into the pipeline.
That's actually pretty smart compared to how it's often done. Like, you know how these processors with like 100 cycle interrupt latency with the weird microcode that does the interrupt?
Oh yeah. Microcode.
I think the 68,000 actually also has a really slow interrupt response. I'm talking about that because, again, I need to write that emulator for the RAM edge.
Yeah.
And then we can all get angry at Thunder Force. Or
At what?
I don't know what are the other games that you can get angry at. The other shoot games on Truxton is one.
From the Amiga, right?
No, it's the Mega Drive. Is what I'm thinking.
The what?
The you don't know it. It's the Genesis in America.
Oh, okay. Mega something.
It's called Mega Drive in Europe and Japan.
Okay.
It's called Genesis in America.
Okay.
I don't know. Sega thought that it would be cool. Anyways, I want to write an emulator for that, for the RAM edge. I mean, I already have the graphics part and the audio part. Well, the audio synthesizer part, not the audio CPU, which I think someone's been working on a Z80 emulator, because the audio CPU is a Z80. But this one has to be timing accurate because they made a very cool thing where to play audio samples, you have to write them into a register. And it's literally just a DAC register, which is very cool because the sound CPU has to be turned off whenever you do DMA, because otherwise it'll corrupt. So all your sound samples are really garbled. It's a very really stupid system.
Wow.
And if the CPU emulation weren't timing accurate, it would not just sound garbled, it would also sound too fast or too slow. Well, more likely too fast.
I see.
Because and I don't think the 80 emulator they've been working on even tries to estimate how long the instruction would take on the actual CPU. So I think I might just have to rewrite that too.
Right. Okay.
But,
All right. Well, let's get off this thing, and then I think we have another one of these next week, right?
Yep.
All right. Ada, it's like 5 in the morning. No, it's 4 in the morning for you, right?
Yes, I don't have to do anything tomorrow, so it's fine. Actually, what day is tomorrow? I may have just get horrified.
Well, it's already today for you, right?
I mean,
So,
technically, it's not tomorrow until I went to go to bed.
you're like my cousin, yeah. Well,
English,
that's
today
how
not.
I need to get back on that schedule because I work better that way. I've been driving the kids to school in the morning, and it's got my work.
Okay, it's
basically
gonna be Thursday.
Ada, it's basically Thursday in Germany.
Yeah,
now.
okay. I don't have to do anything on Thursday, I don't think. And I know my
Alright.
schedule says I need to shower. I don't think that's something that needs to be done at a particular time of day. So it's fine. it'll mess up my sleep schedule, but that's messed up. That just messes itself up. I don't
Right
have
on. Yes.
Yeah.
There's some rumor that Chip
It's me.
may be doing 25-hour days just out of principle. So he is kind of scheduling around over the week. I'm not sure. They Ken told me. I'm not sure if he's still doing that, but he said over years you started just doing 25-hour days instead of 24. For whatever reason.
I mean, I do that sometimes. Sometimes it's 25 hours, 26 hours. Sometimes it's like 20 hours. It's really interesting. Some days you just want to go to bed early because I don't know, no energy. That's mostly the days when the Coke runs out and I don't have any, and I'm too lazy to go to the store to get a new one. Yeah, that's the days when that are 20 hours long, you know.
Chip,
Yes.
I'm still alive.
Good.
The shy girl at your left side some time ago is your doctor?
Oh, our daughter. Yeah, that's our oldest daughter. Yeah.
Yes. She needs her own bench. Only that.
She needs her own what again?
Bench. A bench with some solder iron and
Oh, yeah. Well, you know, she does a lot of art stuff. She's really good painter. She can like make a picture of someone and you really know who it is. She's good at that kind of thing. But electronics, yeah, that doesn't appeal.
I believe she's just curious, but is shy about asking you for permission to do the same thing you do. So if you establish maybe another room, a bench with meter, a solder iron, and the boards and components she wants, and a little bit of instruction each day, she will go away on her own. I know because my own son did the same way, the same way, but he was very young at 11 years old. And I believe your doctor is a little elder.
Yeah, she's like 15 now. She just turned 15.
Yes. Let she goes because she is just curious about what is going on. And when she touches the things with her hands, she will flow in her own pace.
Yeah, no, I could see that.
You'll be very surprised.
Yeah, well, I could show her some things, but I don't know if she'd find it too interesting. She does do a lot of like crafty stuff and painting and like, I don't know, writing. She likes to write. She's she was coming in here to tell me about some probably drama at school with the kids. She always tells me what's going on.
I look in her posture and her gesture, and she is curious. She's just curious about what is going on and how you do your stuff. I survived. My eye is healing. I'm just looking like Gene Simons from Kiss band.
Oh yeah.
Yes, I'm horrible.
Yeah, Enrique had some. You have like it's a sinusitis with some kind of.
Started with the sinusitis that I don't know where come from because there is more than 50 years, or no, about 40 years that I don't have any episode of sinusitis
so hard, and it becomes a cellulitis. That is as an infection under the skin, almost in the all the left side of my face. I sent you.
Yeah, I saw that picture.
Yes, yes, I'm more horrible. For Michael Sommer, you have complained about your eyes. I don't know if he is awake.
Yeah, Enrique, I have
Yeah.
the same problem with a runaway sinusitis since 30 years or something.
Okay.
I'm sucking on it and trying to get the stuff out of it, but it's a hopeless fight. But I'm fighting with the same problems. Somebody broke my nose in some fight, and I hadn't had any insurance to go to a doctor, so I fixed it by myself. And since then, I have some bones stuck in the side of my head, somehow blocking the sinuses, and not fun.
There is
Not fun.
there is an antibiotic that you can heal you. The name is azithromycin in Brazil.
Azithromycin.
Yes, yes. 7 days, one drop each day. 6 days of rest. Another 7 days.
That will loosen up. That will loosen up that sticky stuff sitting in there.
I don't understand. Please repeat.
That will sort of loosen up the stuff sitting in there. Because I'm too poor to buy health insurance. I'm uninsured. I can't go to a doctor. I can't afford it. The exchange rate is pretty fucked up between Europe and America. And even being a programmer since 15 years or something, I'm fighting with kind of the prices here.
You can't you ask for a doctor for a prescription for azithromycin or no?
Can you?
3 times 7 days in a row. 7 days, then 6 days of rest without medicine. Another 7 days, another 6 days without medicines. And the last one, 7 days. There are 21 days of taking pills with 2 intervals of 6 days in between. 7, 6, 7, 6, 7. And it will heal you for about 25 years.
Oh, that would be
You
nice.
don't have any episode. But in my case, I discovered that during a little rainy day where I'm not using an umbrella in the sidewalk of the streets of Mesquita, the place where I live, incidentally, 1 or more drops of water rolled from the roofs of the houses or the stores alongside the sidewalk and did hit my face. And because there are too few rain those days, the water that follows was heavily contaminated by bird, pigeons, and vultures and bat drops. So the bacteria or virus that lives in the roofs are very concentrated and could find their way to the corner of my eyes. So they penetrate through the lacrimal channels and just inside the sinus, the paranasal sinus. And the infection goes without any treatment for 3 days. until they exploded.
Mm.
It was the worst infection I have in my life. I'm just resembling some of the heavily maked up characters of the movie Suicide Squad.
Elephant
Yes,
Man, yeah.
terrible. Yes,
You're
yes.
looking like the Elephant Man. Yeah.
Yes. You need to look. You need to look with red lights in your back. I was reading about using red lights, soft red lights, in the backside of your head. So the environment needs to be reflecting a little of red, not blue, not green. And the screen can be the amber character set, amber color in the character set. So they will not stress your eyes. You don't need to look to that red screen and with the red light all the day. But the most part, you want to heal your eyes, you want to use the red or amber lights, so they will ease your eyes, will not force the other receptors in the backside of your eyes.
Yeah, okay.
Yeah, it will help you.
So a heat lamp, yeah.
Or
Red.
Johnny Mac's new system where you just adjust the amount of red that you want. And
Exactly, again, adjust to the right amount of heat.
But not that strong.
yeah, so you can bring it down. So.
Fantastic. But not, yes, not that strong. Very, very, very soft red lights in the backside of your head. And if you have an amber text monitor, or can program your monitor to have amber characters into a marrow background, it will work to heal your eyes from the blue and for the green that can be hurting your the backside of your eyes. And there is one Chip.
Yeah.
I was boiling water in the kitchen. It's about 4 meters from here, but I hear you telling that there was a diode inverted into the board of the mother. The Zener, no, the Schottky diode was inverted.
Oh, yes, yes. Yeah, that was why we were having so much trouble. Once we turned that around, everything worked. Hey, Enrique, I posted a video in the chat. It's this doctor came up with some way to drain sinuses. I tried it. It didn't really do much for me, but people who left comments said it worked really well. But he like pulls on his ear and presses on some bone, and it sets up some situation where sinuses can drain. But I emailed it to you just now also.
Oh, okay.
Might be worth
I
looking at.
did it. I saved the chat screen because the audio was cut when you were explaining if it was the Schottky diode that was inverted into the board. When I asked it, yes, that was the problem.
Yeah.
Okay.
Yeah, we're gonna have to, well, we can maybe get some other kind of diode and fit it onto that LAN pattern, but then we got to turn one cap 90 degrees to get it to solder correctly, but we might just redo the board. This has been so crazy. It's taken us so long to get this silly motor driver thing done.
those kind of actuators based on NMOS transistors
Right.
are known to have that kind of problem since 1993. I sent you the files from Harris and another provider, and the application note from Fairchild back to 2008.
Right.
2000, yes. The best application note I saw that it was that one from Fairchild that now is on semi. They explain step by step how the calculations are done, because the protection circuit you described it with that multi-purpose gate don't account for the time of the turn on, turn off of the transistor. You can control the time that the signal reaches the gate, but if the gate is still open or is closed and needs to be opened, the total time of the operation cannot be controlled unless by software. You can do by modifying the position of the pulse control modulation.
Yeah, we have like a 1 microsecond break before make right now in the driver.
Oh yes, it's enough, because everything occurs, assuming all the possibilities, everything occurs in less than 100 nanoseconds.
Yeah.
The transistor plus the circuit, everything summed to a little less than 100 nanoseconds. So,
but you know, there's another thing that when we open those transistors, the coils in the hoverboard motor, this thing, they kind of release. And so it's good to actually give them like a whole 1.5 microseconds. And what happens is the current dissipates through the freewheeling diodes in the big FETs, and it takes like way less power from the power supply to run the motor then. Because what was happening is when we turn on too quickly, those fields were collapsing, and our power supply had to fight against it. So if we give it a whole 1.5 microseconds, the freewheeling diodes in the MOSFET take care of the deal. And then when we step in with more current, there's no more active pushback from the coils in the motor.
Okay. It's very interesting. It's a challenging circuit.
Yeah, inductors are the most complex. You have resistors, capacitors, and inductors. That's the RLC, the basics. But the inductors have like multi-dimensional personalities. A resistor is the simplest. Capacitor is more complex. But then it's like each time. And then when you get to an inductor, it's like a whole nother dimension.
In the future, you will change for the new kind of FETs made with carbide.
Oh, carbide, yeah.
Yes. They can withstand very heavy loads and very fast pulses without destroying, never. So, well, yes, you can destroy, but you need to push they very, very hard before they can be exploded or feedback some bad effects to the actuator circuits.
You see all this equipment, the stereo equipment?
Yes.
This guy, Nelson Pass, he's kind of like the living grandfather of solid state hi-fi. He paid some, I don't know what company it was, but he had a couple wafers made of some special carbide transistor that's normally only used in, like, I think microwave applications. but he wanted to get some of these for his audio experimentation. So he paid a bunch of money to some company. I forget who it was, but it was like $50,000, and they gave him these custom transistors that were, the technology is not normally used for audio, but he's all about, how to minimize distortion and what's the fastest transistor and fastest circuit topology.
You tell us the name of the, oh no, it was the audio,
This guy's name is Nelson Pass.
yes, Nelson Pass, yes. Yeah, I remember. Yes, I studied. He is like John Williams from analog devices or something. Yes.
See,
He's kind of a genius.
We didn't work with them, but we know him and we know people that work with him. And he sold us these speakers for at about their cost. And then he just kind of gave me that whole stack of preamp and phono stage. And he didn't want me to pay for it. So I still got it. I've had it for like 13 years. No, more than that. I think I got this. It was in 06. Is that 15 years now? But these speakers, it's cold outside, but they have 4 Class A amps in each one. See, each driver has its own Class A amp, and there's an active crossover when the signal goes in. So the whole back of the speakers is a big, it's like an extruded piece of aluminum that acts as a heat sink. So those two things, I just leave them on, and the office is so nice and warm without using one of those nasty directional IR heaters. This thing the whole office is really warm. It's very cold outside the door here.
Dual purpose.
What's that?
Dual purpose, sound and heat.
Yeah. Well, yeah, these speakers they're awesome heaters. They're very gentle and they heat the room really evenly.
It's fantastic. Thank you. Thank you. And
All right.
thank you for the tips for the draining the sinus. I will study the links.
Yeah, I had never seen anything like it. He has kind of a 2-point plan to pull and push on things, and it didn't do much for me, but maybe I wasn't doing it right. Because I often have sinus issues.
Yes, in the 70s, I had an associate that was prescribed by a medical doctor from Minas Gerais, one of the states of Brazil, with a cream made of a very strange mix that caused hurts in the sides of the face, just after the eyes, about 1 centimeter or 1.5 centimeter. And through the scratches the cream causes, there is all the secretions are flowing in his face all the days. We worked together at CompuCorp Brazil at the time, and he uses a lot of paper towels to absorb that liquid and wash his hands all the days, because there is a lot of fluids flowing. And I asked you, what is that? Oh, my medical doctor prescribed me with that cream that causes an infection over the skin that drains the inside of my face.
Gosh.
I think no, I will never use something like that. Okay. So let's. I appreciate your attention.
Likewise, Enrique. All right, are you guys all ready to go eat something? All right. Okay, well, take it easy and we'll talk to you soon.
Thanks, Chip.
Thanks for
See-
coming today.
Yep. See you next week.
Okay. Bye-bye.
Bye-bye.